How's it going, guys? Joe here. Today I'm going to be doing a rather strange but hopefully interesting live stream. So let's just jump right in. So what am I going to be doing today? Well, today is going to be all about exploring AI and basically making tweaks to the custom chatbot that I've created. So I suppose I should probably give some context on this. So essentially a while ago I created a custom chatbot because I wanted to learn what that process was like. And what did I end up doing it on? Well, a while ago I made a time travel video. In case you didn't know, I'll kind of show what that is, sort of show a TLDR of that right here. But I decided to make a time travel chatbot essentially. And the idea with the basically what I did was the time travel chatbot, it's basically satirical, and what I did is I tried to make science and sci-fi and reality come together as closely as possible with this. So usually we see time travel on films like Back to the Future or Bill and Ted. I think Rick and Morty has some if I'm remembering correctly, but there's a lot of time travel films out there, right? Well, when I watched Back to the Future for the first time, there were some concepts that were shown in there that I really wanted to explore myself. So I decided to make a time travel film, but I didn't want to just steal what you see from sci-fi shows. What I did was I sort of invented my own time travel strategy and tried to make it as realistic as I could so that it was unique compared to what else you see out there, and I could explore all these different concepts. I didn't really want to take that journey because of the time commitments and stuff, but I thought it would be really interesting to explore because there was a lot of potential for exploration. And I got to a point where I'm making up concepts for how the time travel is going, but I'm trying to make it as realistic as I possibly can in this world. So maybe not all of it is fake, but of course, combining these things together doesn't actually result in time travel. But it's a little hard to argue exactly why, I think. So that's basically what I've done. I created a time travel film for that. So I got to a point where I did some research like, how am I going to accomplish this time travel as realistic and convincingly as possible? Well, I did a bunch of research and spent quite a long time getting that all together so that it'd be kind of hard to argue why it's not possible. And of course, everything is acceptable within the universe of the film, so I got to a point where I could answer just about any question that anybody could have regarding my approach to time travel. And wanting to explore custom chatbots, which I'll show here in a bit, I created a custom chatbot that essentially goes over that exact same thing so that it can answer questions in a similar way that I would for how I accomplish time travel, especially to skeptics who might be like, that's not possible. Of course it's not, but how realistic could we get it? So that's what my chatbot is. So if you haven't watched the time travel film that I've done yet, I would highly recommend watching it. It's on my main channel right here. That's essentially the time travel film. So basically a TLDR of that is what I did was I showed some basically realistic concepts. It's just the context in which I apply it doesn't actually result in time travel, as you can imagine. So we're not going to watch the whole film here, but I'll give you enough context so that you're not too lost if you're just coming here to see what I'm doing. So yeah, I have this time travel film, and then I've created a custom chatbot. So actually, one of the points of me doing this live stream is so I could show basically what I've learned creating these custom chatbots, and I've learned quite a lot about AI exploring this and quite a few other things too. So on top of demonstrating this and showing my thought processes for improving this custom chatbot, you'll be able to see how I actually refine things live. I'll show my thought processes, and on top of that, I'll show basically what I've learned from this whole thing. So yeah, I guess I'll start off by giving some context on how the actual time travel works. Then I'll do a demonstration of the chatbot and then what I want to change, and then we're going to go over some of the weird things that I've learned about AI and how certain things can affect how it behaves depending on how it's set up. And I'm going to try to do some live demonstrations of that too. So then once I do that, then we'll make some refinements to my chatbot because of course it's not perfect right now. I'll show my thought processes for making it better. And there's some things that I don't even know how I'm going to approach it, but I'm going to show all that live and just kind of my thought processes for how I'm going to approach it because, well, one of the unintended consequences of creating a chatbot like this, which by the way, you can access on that video, I have a link to the chatbot in the description of this video, so you can check that out if you want. But one of the consequences of doing that chatbot is I basically did enough research to be able to make the film as realistic as possible. There's certain details that aren't all that realistic that I couldn't address, as you could imagine. So now that I have this chatbot, we're probably going to want to be able to make that chatbot address these rather strange nuances about my methods of time travel. I don't even know how I'm going to address some of the things myself since it is fictional after all. So throughout this stream, I think it could be rather interesting to not only explore AI stuff, but my thought processes for how I'm going to handle those things that I didn't anticipate. Like the math that leads to 1.21 gigawatts, which you might be familiar with on the time travel film. I show this toward the beginning, and if you look at these mathematical steps, it actually leads to 1.21 gigawatts. These steps do actually lead to that number, but of course, I made it so that the steps lead to that on purpose. I'll kind of overview in this live stream what I actually did to make that possible, but also these variables are technically meaningless. I tried to make them based off of things in real life, but it doesn't really come together in that way. But what about people who want to know how this all works? Perhaps I could address that in the stream as well. I don't know how far I'm going to get with that, so this might be one of the last things because it gets quite mathematical at certain points. But we'll explore a little bit of this at least in because the variables that you see on here, A, B, C, D, E, I'm trying to get it so that E, which is energy, results in 1.21 gigawatts. What are the other variables? Well, I kind of made some placeholders at the time. They do mean something. Like, I think A represents amperage for something. B represents maybe the ohms for the current, I guess, that's involved. C represents current or something along those lines. I forget what it is. Might have to do with wattage. I had the variables mean something. Now I can't remember what it was, but I think I have it written down somewhere. I actually have a behind the scenes podcast of the time travel film as well, which you can check out by the way too. So if you go to my second channel here and you go to podcasts, then you can come to here, and this is many hours worth of behind the scenes of that time travel film. It's not just talking about the time travel film. I allow myself to go on rambles whenever I want to. There's stuff about lucid dreaming, Star Trek, and AI with dreams, comparing how dreams are like a biological AI, and some of the quirks that Dream has is similar to quirks that you see in AI video generation or image generation and stuff like that. I talk all about that throughout these live streams. There's a lot of content, but there are time code navigations that you could use to navigate. So like the biological AI, there's a bunch of chapters for each thing, so you could explore what you want from there. And yeah, so I talk about this math sheet on that right there. And then, as I'm going to allude to later, I actually trained my custom model to take information from these podcasts, not the whole thing, but certain parts I trained it on information that I said in the podcast. And part three will, for the post production, will come out soon. It's about, I think, close to 11 hours long. And then that will complete this podcast. And if you listen to the podcast, you'll also know that one of my goals and dreams and lucid dreams is to teach Commander Data from Star Trek how to use Vim, which is text-based editing. And actually, I think I might have it right here. Yeah, so the way I'm going up and down and typing right here, that's all Vim. I could go to the top, the bottom, very quickly navigate around. I'm using Vim in my note-taking software. Kind of hard to do a live demo. There's probably some cool demos I could do, like if I want to change everything from here to the end, I could just go like that. More stuff. I can undo that, which you could do without Vim, of course, undoing. But Vim is pretty cool. There's a lot of text-based shortcuts, and I feel like Commander Data from Star Trek, if you know anything about him, he obviously struggles to understand human emotion and human nuances in general. And in a lucid dream, well, I had a thought experiment one day where I was like, if he were to learn Vim Data, would he be able to go through it easy, or would he struggle massively trying to understand how Vim works with all of its intricate keyboard shortcuts? So like going to the beginning of the line, I do capital I. Whoops, I deleted that. So I hit U to undo. Capital A goes to the end of the line. J and K go up and down. H and L go left and right, which I almost never use. Capital G goes to the bottom. Lowercase gg goes to the top. DD deletes a line. There's a lot of weird shortcuts in Vim. And then if you wanted to replace certain, let's say that in all these lines, I wanted to replace a left parenthesis with a, I don't know, an ampersand. And I would do, I highlight that with, that's visual mode. That's another Vim nuance. Then I do substitute on the bottom, as you can see here, with substituting a left parenthesis, which I believe I have to escape, which that's a weird nuance right there. I'm going to substitute that with an ampersand. I'm doing that everywhere. So now all the left parentheses are ampersands in that area. So the point I'm trying to convey right now is Vim has a lot of weird nuances. And actually, if you wanted to preface all the bullet points for these next like 10 lines, I could go like this. And then I can type in all those areas at once. Preface stuff. It's a little weird. So there's a lot of cool things you can do in Vim, right? I wish I had my keystroke visualizer right here. Then you could see what keys I was pressing to accomplish all that. Well, Commander Data, would he be able to pick up on that stuff easily, or would he struggle to understand the nuances? I decided to ask an AI chatbot that, and it didn't have a very straightforward answer. On one hand, he could excel like he excelled at so many things being a machine already. But on the other hand, this is built on a lot of human nuances that he might struggle to understand. So what better way to explore that than in my own dreams, which is a biological AI. It's a way to interact with Commander Data with a realistic sensory experience and simulation. But I could also get answers to that question. I share quite a few stories of that in the podcast with what I've done so far. I haven't completed it yet. I still will, so there'll basically be supplemental updates in here for that as well. That's basically what I'm trying to convey regarding that. So there's also going to be follow-ups for that if I get to it one of these days. Anyway, we should probably get back on track. I'm rambling. As you can see in the way I'm doing that right now is quite similar to how I do it on these podcasts. It's worth noting that I did these podcasts while driving, and obviously driving takes a priority, and I use AI to basically remove silence and all that stuff. So all the editing, there's virtually no silence, and AI did all that stuff for me. So there's an AI model that accomplishes that. I use software called Recut in this example. So I can give it my podcast. I set some thresholds right here. And then it automatically gets rid of silence based on these thresholds. I'm not sure if those thresholds are AI based or not, but I'm told that it is. So as you can see, AI is becoming quite potent in this world nowadays, and this live stream is going to be all about that, I promise. I know I'm rambling on all these different things, but if you have context on some of this stuff, then if I randomly talk about things, hopefully it'll make sense if you've been watching all this. So yeah, let's see, where should I continue? Well, it's probably give some context on the time travel film. I try to make it as realistic as I could in this world. Think of this as a sci-fi meets reality, or sci-fi blends with reality, something like that. So yeah, obviously this is a trailer, but I love how I made that reference right there. Yeah, there's the math sheet that I show right here, which we're going to go over in a little bit. I'm going to try to figure out how to realistically convey that math sheet with the chatbot. I don't even know how I'm going to do that, but I thought it would be kind of fun to brainstorm that live. So obviously the 1.21 gigawatts is a Back to the Future reference in case you haven't figured that out, but I use this math sheet to make it look like I accidentally stumbled across that. And on top of that, turn on sound. 41 gig. I think sound should work for you guys now. Gigawatts of infrared blast. So if you look closely right there, you'll notice that it's a little more precise than just 1.21 gigawatts. It's all these decimal significant figures to be more precise. We could argue that's what it is in the film, and Doc Brown wasn't being very precise. We could make that argument. It's kind of hard to not argue that because that information wasn't revealed, but yeah, so I made it look like I accidentally got the 1.21 gigawatts. And then as for my actual methods of time travel, using a multimeter, which normally is meant to read current,
skin or tissue damage,
I'm using it to capture electricity as well by wrapping electrical tape around it, which acts as an insulator. But then on top of that, I'm ionizing the electrical tape since there's no way we'd be able to do 1.21 gigawatts from that alone. But ionized radiation is the opposite of that. We could use ionized radiation to get more power. Now to clarify, we're not actually getting more power. Instead, it'll allow us to do more with less power. So I'm not getting more power, but ionization effectively accomplishes more with less. You know the saying, less is more? Similar principles there, I suppose you could say. So ionization helps bridge the gap with the 1.21 gigawatts. In reality, it probably wouldn't, but it is on here, I guess, within the film's universe. But this is a way to make sci-fi blend with reality, I guess you could say, using pseudoscience rather than science, which is totally fine, I think. Works for the film. So then I'm using this hearing aid dryer to ionize the tape. That's how I'm accomplishing the ionization. And basically, there's some problems with that we'll get into later, like how do I know if I've ionized it enough? I just say if it feels warm from ionization, probably good. But yeah, so I'm talking all about that. Then I'm talking about the issue with emitting energy all at once. So rather than emitting energy all at once, you can use a concept called temporal dispersion, which is a term that I coined. I think it means something else in the real world, but in this context, it means I'm emitting energy over time rather than all at once. And I'm using a TI calculator to accomplish that. So yeah, I have a calculator like this one, which accomplishes temporal dispersion using recursion. So basically the idea is rather than emitting all the energy at once, it does it over time at a natural rate. But because of recursion and how things go deeper and deeper into the call stack, if you're familiar with recursion, energy basically gets emitted while we're going down into the call stack, and then when the base case happens, aka we've emitted all of our energy, then we're returning out of our call stack, and the energy appears to be emitted as one continuous burst, thanks to time travel itself. So I'm using recursion with time travel, and that allows me to look like I'm emitting all the energy at once when it's really emitted over time at a natural rate. So, and I'm using recursion to accomplish that, which is pretty crazy to say. When I came up with that solution, I was like, so I like the idea of emitting energy over time, but the problem with that is, how do I make that happen? I could do some crazy math on here, figure out how long it'll take, and figure out how to reverse engineer it using, I don't know, some sort of crazy reverse entropy concept like you might see in movies like Tenet. So then I was like, well, it's almost like we're capturing energy in a bucket. And once it's captured, we're returning that bucket full of energy into the present. And I'm like, yeah, that's a good way to describe temporal dispersion. So what does it actually do? Well, or how do I do that? How do I figure out how long it'll take to emit the energy and then return it? Well, there's no real way to do that. I could take a guess, but the energy output is variable, and there's no way I'm going to guess the exact point. Well, recursion takes care of that because recursion just goes as long as it needs to, and then when all the energy is emitted, it'll return itself out all by itself. It's a self-fulfilling mechanism. So, yeah, it's a pretty cool. I thought it was a pretty cool idea. Here's how I explain it in the video. So it gets emitted from the present into the future, but the signals will go. Ask me how I. But fortunately, we can send the signal using anything that can send raw signal to the multimeter's common ground interface right here. I'm going to use a TI calculator for this. So the way the signal gets sent is through some calculator wire, which I have right here. And that calculator wire, that was a little bit of a joke. That's not really what it's called, but there is a wire that could really hook up to the end of the calculator, as you can see right there. That is a real concept. I don't remember what it's called. I think it's just called a link cable. In reality, it's meant to be used to transfer programs and stuff from one calculator to another. But in this context, I'm hooking up the calculator to the multimeter and essentially having it do stuff through that. We can have the multimeter conduct the signal using electrical tape and this link cable. That's the way I'm hooking it up. Okay, so as it turns out, and then this is a problem we'll have to address in the future. I guess I'll show you this part real quick. I actually had the multimeter wires hooked up incorrectly. This is not the correct way to wire things up. It will work here, but not in all contexts. The way you want to actually wire it up is the black ground always goes to the COM port for common ground. And then if you're measuring voltage like I was in this video, then you want to have the red one hooked up to the one labeled according to the voltage. If you're doing stuff with amperage, then you want to move this up here. If you have this hooked up and you're doing something with voltage, it might kick the breaker out. Don't ask me how I know that. But yeah, this is a more proper way to hook it up, especially if you're doing voltage on this particular multimeter. That's a clarification that I want to make on the time travel chatbot, by the way. How to properly hook it up. It probably doesn't address that, but if you have it hooked up wrong, you could kick the breaker out. I'm speaking from personal experience. So Yeah, careful with that. I'm going to try to make a clarification to the chatbot about that. I showed this so you have context on what we're doing later. We can still hook up the calculator to the spare port because we're taking advantage of EMI radiation and residue. The reason why you can hook it up to any port, the calculator, to any of the spare ports, such as that one right there, is EMI radiation. When you try to send signals using the send command on a calculator, it just goes through there. Then EMI radiation is what makes a multimeter actually do stuff, allegedly. And it does that because it's an electronic, much like this. They both operate on binaries, so that's a plausible explanation for why that actually works. Speaking of which, I'm a little curious now. If I ask it that question, will it answer properly? Why does hooking up the calculator to the multimeter actually result in sending signals? Well, PWM signals. I want to see how it answers that right now. So I've designed this to answer pretty much any question about the way I'm accomplishing time travel, which I'll demonstrate as needed. I'll show how to actually tweak it in case you're wondering how custom chatbots work. I'll show some weird quirks I've learned about how the whole system is designed. And I'll try to do some demonstrations showing the quirk in action, basically. Specific nature of calculator's programming and how it interacts with the multimeter to manage it. It sends PWM signals, which I just explained. The multimeter, though not typically designed for this, is treated in this setup as a conduit for energy control. Yeah, it nailed that. I was surprised at how well it answered these questions when I first created this chatbot, and then I made further revisions over time. Energy captured through EMI. Okay, I want to check to make sure that it's a representation of energy. Okay, the reason I'm getting hung up on that explanation right there is because, well, not only can you send signals through that wire, which I don't have with me right now, but you can also read what's on the multimeter itself because of EMI. There's a little bit of EMI residue in those spare ports on the video. And because of that EMI residue, that's why you can read signals. It picks up whatever it's picking up there, essentially. So, yeah, but the reason I'm getting tripped up about this explanation is it's almost implying that energy gets captured through EMI, which is not really true. It only controls what the multimeter does, whether it's sending PWM signals or reading energy itself. Like, it's not dealing with actual energy, it's reading what's going through the multimeter, kind of like how you can read current through a multimeter in general. I just wanted to make sure this phrasing wasn't implying that you're reading actual energy rather than just a reading of the energy. Sorry, that probably did not make any sense there. Temporal dispersion. It knows about my calculator programming as well, and it can explain pretty much any part of that, which is, I think, one of the most exciting parts about it. It's dispersed through the fourth dimension, hence temporal dispersion. Fourth dimension being time, of course. The system creatively repurposes existing technology, utilizing programming in a way that's consistent with the theoretical needs of time travel. Okay, now the phrasing right there is some slightly subtle phrasing that might indicate that it's not real. And I was thinking about getting rid of that behavior, but I think anyone with common sense knows that this isn't real anyway. fact, if you've seen creators on YouTube like Theo Joe, he used to make satirical tutorials, and you'll notice the way that I do this is very much his style back then when he did these videos. So, yeah, you'll notice a high consistency in that style. Then on top of that, we're both named Joe, so yeah. Um, Obviously, it talks about theoretical needs of time travel in the film's universe. I think that those who don't know that it isn't real probably won't even take much of a hint with the subtle phrasing. It's not directly saying it, but it's implying. If you know, then you know, kind of thing. So I think most of that behavior I'm going to leave because most people know it's fictional anyway. So yeah, and as far as like safety goes, I'm obviously not responsible for anyone's safety, but since the concepts are fictional, these things that I show here don't actually work in the real world, as you can imagine. So from that perspective, I think it's fine, but I'm still not responsible for people's safety and what they decide to do with all these things. Obviously, since I'm doing stuff with an electrical outlet, take precautions there. Oh, so right here, now I explain temporal dispersion in case you didn't quite get that. Trying to get it to go backwards right when it starts. I'll just go to 747. That's about where it is. Actually, one of the other cool things about the chatbot is you can ask where specific moments are too. Where do I start talking about temporal dispersion in the video? So you can ask questions like that as well. It'll probably say 747, 547. Well, I do start introducing the concept at 547, but then I further explore it at 740. Where does it start after the multimeter correction? About that. Then I'll probably say around 747. See, it knows where the multimeter clarification is. I trained it well. I'm pretty sure that's about right. So if I go to 639, see, it knows exactly where that is. So then at 740, I suppose that's when I'm done with the clarification. So probably that's awesome. So if you're looking for a specific moment of the tutorial, it can do that. At first I made a reference when it's, so the custom chatbot, I'll show you what that's like later on, but it isn't just giving it custom instructions. As you'll see, you can actually chat with the creator essentially, which is, as I'll explain later, ChatGPT, but it can tweak the custom model on top of just chatting. And when it got things right, I had to do some tests. It did really well. And then I was like, you're learning a lot, my young Padawan. And of course, being a chatbot, it got the reference. So, yeah. Okay. So here's the temporal dispersion explanation, I guess. Probably the easiest way to accomplish power distribution is utilizing a programming concept called recursion. So the way energy typically flows is it gets emitted from the present into the future, but the signals will get sent in a recursive nature. So to help illustrate how this works, using this as a timeline, we start off here in the present and energy gets emitted into the future, but recursion will return and emit the energy in the present. So it's like a metaphorical bucket collects energy as it flows at a natural rate. And then when it's done, then energy will come back into the present because recursion returns out of the call stack. If necessary, I might do some demonstrations on recursion just to kind of show how the actual programming concept works. But yeah, so that's the idea. It makes it so it can emit at a safe rate, and then utilizing time travel itself, it can come back into the present. We can't time travel while power is still being emitted, otherwise our temporal dispersion will fail, and so will our prior time travel. So there's a paradox right there that we can try to avoid. So, well, if you're emitting things at a natural rate, I think according to my calculations, it'll take like almost 2 hours. I talk about that nice pausing moment, facial expression. I have a lot of those. So if you look into that behind the scenes podcast that I showed earlier, then you'll know from that I kind of talk about energy emission rates. So I should also illustrate the pre-production basically talks about coming up with the idea and the writing process and then tangents from there. The post-production is all about shooting the film such as this, the editing, and all the other rambles like lucid dreaming. So what am I trying to get at? Well, since it takes about 2 minutes to emit the energy at the natural rate, factoring in ionization and all that stuff, if you disrupt that process during time travel, the original time travel won't work at all, which kind of helped prevent a paradox. So basically, if you try it and it doesn't work, that means that the energy emission failed at some point. Obviously, if it succeeds and then it later fails when you alter the timeline by mistake, that might create a paradox. So you have to do everything you can to make sure that doesn't happen, obviously. I also get into some of those aspects on the podcast as well, like getting a little bit fun about the paradoxes with the time travel.
If we actually alter the
I just
timeline,
do a raw discussion regarding that. And then here's the calculator showing the calculator programming that actually does recursion. So if you know anything about recursion, you'll recognize that I got base cases on the top. And then this for loop. So that's a thing we're going to be addressing later on as well. That for loop, what it really does is, so obviously every time you do recursion, you're basically calling a function on itself. And every time you call a function, it creates an execution context that temporarily stores stuff and then it gets cleaned up once it's done executing that. But every time you create one of those execution contexts, no matter how many layers deep into the call stack, you're taking up a certain amount of memory. And calculators being from the 80s or 90s, like the TI-85 was from the, I want to say 90s, there's not a lot of memory on them. So you can't do very many layers of recursion because of that. So I did a little test, and that for loop essentially, it allows some PWM signals to be sent without recursion, which, if we're getting technical, that violates the concept because every single PWM signal should go into each layer of recursion if we're being technical about it. But in this case, I'm doing some memory management, and you could probably argue that I'm grouping some of the signals together so they do all still get sent. But obviously the reason I'm doing that for loop is memory management. I figured out the total number of iterations that are involved altogether. And based on that, I then figured out about how many layers deep I can go on the calculator. And then I picked a reasonable number for that for loop. Basically for memory management of recursion, if you're familiar with that. So then, but on the, I can't really make that argument on the chatbot because in the film's universe, I don't want that to be the explanation. We could argue that that factors in ionization. Since we could do more with less power through ionization, we could argue that the for loop factors that in. And if it does factor it in, people are going to wonder, where did I get that number from? Other than the most optimal memory management. I think we could argue memory management too, I suppose. Or we could just say it's a quirk of the original thing, which is factoring in ionization. See how these concepts are all coming together in very strange ways? Well, So I think what I'm going to try to work out is, where did that number come from? You could say trial and error, but I don't want to just say I was figuring out memory management. So what trial and error could I argue that I was doing? That's something we're going to think about later if there's time. So yeah, and then that send one, as I explained, that send is an on-duty PWM signal because one translates to on or true in binary. And with it being hooked up to the multimeter and both devices being electronics, it'll effectively act as a PWM signal. And then I basically translate the power that I'm capturing. I read it from the multimeter and then display it on the calculator screen. That's what the rest of that programming is. And then I handle the return statements at the end, essentially. In fact, if you want to see what the whole program looks like, show the calculator programs. It'll be able to do that. So that's what's on the film. The travel program, which is the starting point, and then that's the recursion function, since that's how it works on calculators. And actually, if you're doing recursion in general, you definitely don't want that recursive function to be the starting point in general. That would be a bad programming practice if you really look at it. So this is perfect for that. Initialize the variables, initialize everything, then do the recursion. It's better to have a function that sort of acts as a starting point, and then that starts the recursion. So yeah, those are the base cases. That's the actual logic as shown in the film. This is the recursive call. That's the last return that everything else doesn't cover. Because obviously, with recursion, you're coming back to the top. But there's going to be a point when you suddenly go below this. The base cases aren't going to capture that. So then you just have a return there. And that'll naturally return the energy. And I'll show a little bit later one of the clever responses the chatbot had about not only why recursion is what actually results in temporal dispersion versus just a while loop, which effectively accomplishes the same thing. But what was it? It had something clever on it. I can't think of what it is. Well, I have a return statement. I think it explained why that's there correctly, even though I didn't explain it. So yeah, so that's basically those principles. And then I also wrapping the ionized tape around it, hooking it up to the calculator. Then we'll just hook it up like so, hooking that up to the wall. So you can see the counts going up accordingly. There we go, which is cool. Now capturing some energy, as you can see. So then, now I'm talking about stuff about the way the remote works, like how do you go to a certain point in time? Well, it's all based on the Big Bang. A certain point after the Big Bang and a unique infrared signal. Speaking of which, there was one thing that I just thought of that I might want to address at some point. I'm gonna add it here. So I'm probably gonna also want to address it can work with other forms of light waves as well, like UV light, if you can translate signals correspondingly with wavelength, etc. So you don't have to do ionization because there's certain properties, as I illustrate right here. That's the formula. The speed of light in meters per second divided by the wavelength of infrared multiplied by the number of seconds since the Big Bang. Now, if you're doing like ultraviolet instead, well, you can take the ultraviolet wavelength and then adapt things accordingly, technically. Obviously, it's kind of hard to send ultraviolet signals, but if you can make the math consistent with each property, no reason why you couldn't use ultraviolet instead or something like that. So that's something that the chatbot isn't trained to handle yet, so I might want to train it on that someday too. I don't know. So then there's a bunch of math showing how you calculate the number you punch into the remote. And as I address on there, what you want to do is, while you're not sending an on-duty PWM signal, but you have the remote hooked up to the multimeter, you press buttons, and because you're not sending on-duty PWM, the signal will have residue inside the continuity. And that's how it stores all the button presses to result in a unique signal. And then when you start the calculator program, that residual signal that builds up as you press each button will then emit all the energy at once. And then obviously there's signal differences between TV remote brands. So you notice this number is really high because of that formula there. Because it's so high, the difference between TV remote brands is negligible with this amount of margin for 1 second. So it doesn't matter what TV remote brand you do, the difference between them isn't even gonna matter. So that's one of the cool things about that. That was something that I got stuck on for a while. Then when I did the math and just kind of moved on for a little while, then I realized we don't actually care about we have a lot of margin actually when you look at it this way. And then there we go. So anytime I had a problem coming up with a solution, then I kind of postponed it for a while, and sometimes solutions randomly emerge when I worked on other things. So obviously in the video I said that I researched time travel. It was really figuring out this so that I could make it as realistic as possible. So now this math you see right here is real math. Although this Big Bang year, that's likely not what it is. I said that it was, I even said on the video, we don't have the exact year, but that's a close estimate right there. So the estimate was actually derived from, there's a certain range of years. And the estimate was essentially a margin of that. I'll go over that more later, but based on that Big Bang year, then you tack on, as I explained in the video, the month, day, year, hour, minute, second. You tack that all on, and then you got your Big Bang, well, your unique number that you punch in after you multiply the number of seconds by this, which is also per second. And I trained the chatbot to be able to go over the math, so I can do that as well. Explain how to calculate the first TV remote number shown in the film. It can go through the math as well. Actually, that's one of the reasons why I decided to explore this custom chatbot. I was trying to figure out what I could create a custom chatbot on, and then I thought maybe this. Because after all, after doing all the research for the film, I came up with a creative solution for how I'm going to be able to answer just about any question people could throw at me. And then I figured, since I'm doing a custom chatbot, why not do it here too? So yeah, this can go through the math. It goes through the actual steps, which is pretty cool. 752, 700, that's promising. Every once in a while it calculates the wrong number. But if we look at the numbers shown on here, my hand in the way, come on. Get out of the way. Infrared wavelength and everything. The current, here we go. So if we look at this number right here, it should match what I have on the whiteboard right there. 260, 491. Oh, come on. How do I show this when I don't have a lot of room? There we go. 260, 491, 398. Oh no, that's wrong. I'm guessing the reason it got wrong is because it either did a Big Bang year or not. We're going to want to make a note of that. It's gotten it wrong a couple other times too. So let me find where in today's example, or in today's thread, what's it called? Guessing my remote just shut off. So I'm not actually live streaming from this computer that you're seeing here. That's on a different computer. If you heard that beeping sound, this is currently controlling the live streaming computer. If I just need to do something real quickly, it shuts off after 30 minutes. So that's what that beep was. If I turn it on, you're going to hear another one. Oh wait, why did I explain that? You're not going to hear that. I've actually muted that audio. I heard a disconnect sound with that remote. Disregard what I just said. I disconnected that remote and yeah, you didn't hear the sound, so no need for me to explain that. I'm gonna make a note to take that out of the cut version of this. Alright. Yeah, for whatever reason, I'm guessing the reason it got that wrong is where are my time travel video? Here's my notes for the actual time travel video, which of course is fictional. Where's the remote numbers? So I trained it on these notes right here. Ah. Okay. I'm guessing that the number it displayed was this one, when in the video this one was shown. That's what I would guess happened. So that's probably why I got the number wrong. I probably need to clarify my instructions of which number to do. It's probably not clear in the instructions. That's probably why I got it wrong. So yeah. And then when I harnessed the power, then I hooked up the multimeter to the TV remote using electrical tape and duct tape. And then I shut off the multimeter to suspend all current so it doesn't escape, as I explained in the video. You know, I feel like I probably would have been better off just watching the video versus watching me explain it again. And then I time travel over time. Oh wait, right here I say that the math is wrong. To begin with, I was using a... I say that I corrected the math right there. It's possible that what the chatbot showed was correct after all. Yeah, 129.911.068.412. The number is correct now. The chatbot was actually correct to begin with. I forgot that I corrected it after the fact within the film itself, which I think is kind of hilarious because it'd be one thing if I made a mistake that went unnoticed, which I did, but then within the same video, I acknowledged it. That's kind of hilarious that I corrected it right on the video itself versus just left it in there or something like that. So yeah. Then I time travel. Ready? Right there. There's the infrared. So yeah, that's basically all the context you should need to know for the time travel film. So of course the whiteboard changed from the present to the past. So did that. So did that. As you'll see in the video if you watch it. I think I've explained enough now. So yeah, that's basically some context on that. So now I think it would probably make sense for me to address some of the things I want to change for the chatbot, and then I'll show that actual process live. So why don't we go through some of the things it does well? I took some notes on answers that it's had in the past, and I'll show some of those notes here. And then here's a list of things we'll need to correct. We'll basically walk through that list and I'll kind of go with the flow. So here's one of the things that it did well. Well, right there, it's doing some more subtle phrasing, like in the time travel framework you provided. So imagine somebody goes onto the chatbot and then they say, in the time travel framework you've provided. They're not the ones that provided it, though. They're using the chatbot, so I think I should correct that phrasing right there. Maybe I should make a note of that. Oh, I did. Nice. My notes are already there. Cool. So then, here's an explanation that I thought it did really well. Look at that last sentence up there. Here's how this paradoxically safe yet high energy event occurs. I like the way it phrased that because paradoxically safe, but yet it occurs. So that's some subtle phrasing that might give a hint for those who know that it's not real. But otherwise, it's very subtle on this at the same time, so that's kind of cool. And then here's the takeaway that it did at some point, which I thought was kind of clever. The time travel system doesn't cheat physics. It cleverly uses temporal dispersion and recursion to work within physical constraints. The energy blast is real, but unfolds in a way that leverages the fourth dimension, aligning the emission safely over time to achieve the required power all at once. This elegant solution epitomizes the inventive thinking necessary for practical time travel. I like the way it handled that. I was kind of proud when it answered that way. I've trained it well, I think. Here's some subtle phrasing within that last paragraph that I might leave. Here's how this is plausibly explained in the framework of the time travel concept. Plausibly explained? Are you kidding me? I either made notes to address that or I didn't. But yeah, since people in reality know if it's real or not, I think those kind of subtle phrasings are alright to leave for that reason. Here's another subtle phrasing that should give a clue. Whoa, I'm in the way. This imaginative adaptation bridges the gap between measuring and emitting. Imaginative adaptation. There's another clue right there. Can't remember if I decided I'm going to leave that one or not. But yeah, there's a clue. If you know, then I think it'll align well with those who know about this not being real. Here's another hint. Involves creative steps. The multimeter theoretically traps energy. Only theoretically, it doesn't actually. This stuff is a conceptual hack. It's just a conceptual hack, not even a hack. I think I'll probably leave it that way. I would have made notes in here if I wanted to tweak it, but if I decided to leave it, then I never made any notes. So this one is an example of one we'll keep the same way. Important notes. Realism. The method hinges on speculative logic, which it does. imagining the multimeter as capable of storing energy in a manner similar to a capacitor or battery. Ensure all steps are done with electrical safety in mind and never tamper with electrical equipment. So I think it's fine for it to leave those notes. This approach emphasizes a creative reimagining of the multimeter's purpose while tying it into the film mechanism. I think that's subtle phrasing that's okay to leave. Here's a hint that I'm going to leave there. The way that 1.21 gigawatts is derived also serves as a creative decision to ground it with plausible physics while leveraging known constants, tie the energy requirement to a figure significant enough to highlight, but still within the realm of theoretical possibility. So I'm going to leave that subtle phrasing as well. Here's a creative entry right there. This is where I talk about the PWM signals tying with recursion, and why not just do a while loop instead? Why does recursion result in the right behavior but not a while loop? Here's how I phrased it. Actually, I'm going to go to the original thread because there's a fuller answer. I think it's inside of this thread right here. So how did I phrase the question? How does PWM signals... There it is. Are we buffering? Hope not. Hope we're not buffering right now. If we have been this whole time, I apologize. I think I'm gonna tell it to pause the sample playback just so it's not doing that. Do we have any drop frames? None so far. Cool. I'm gonna probably make a note to take that out of the edited version as well. 1 second. There. Okay. Let's look at this. This is an insightful question that digs into the heart of recursion, how that ties with temporal dispersion. So it's getting sent through PWM signals, getting sent with each recursive iteration, up to 1.21 gigawatts. Recursion leverages fourth dimension time differently from a loop. Programmatically, it's pretty much the same, but why is this different in the time travel film? It explains how the call stack ties with temporal layers, and how this is tied with time. And then here's the most clever part of the answer, why a while loop doesn't achieve the same thing. A while loop is linear, emitting energy incrementally without the temporal stacking effect. Each iteration simply adds to the total energy without creating the perception of energy being distributed over time and then collapsing back into a single burst. Without recursion, there's no temporal layering. Even if you did a while loop, even though it's programmatically the same pretty much, no temporal layering. While loops do not mimic the burst-like nature. While they could serve the same practical functionality, however, recursion adds a temporal dynamic. It represents the fourth dimensional nature of time, which is crucial. It ensures the energy emitted across iterations appears as unified. Then it does an analogy. Recursion achieves something while a while loop cannot. It ties the energy emission process to the temporal framework. I love the way it fixates on there being a difference when in reality there's not. I trained it well. So that was kind of neat how it does that. So then here's the phrasing where it's how energy is trapped and managed in a speculative setup. And then here's how everything's accounted. It does a speculative setup though. I don't really like that phrasing, but I think I'm gonna keep it there. So then as far as something we're actually gonna tweak, ionizing the multimeter or the electrical tape around it. As shown in the film, I only ionize the electrical tape, not the multimeter itself. I don't know how I feel about ionizing the electronic directly. So I might end up tweaking that, I'm not sure. And then obviously I explained how the COM ports, which I do the correction about where the breaker kicks out in the film. The correction was at, was it 639? Yeah, I remembered that correctly. As shown here, I mentioned how this needs to be in the COM ports, not up there. Even though this wiring does technically work, it won't work for everything. There's certain things that won't quite work right when it's hooked up like that, but it can. The subtle differences for the way I used it don't even matter. So, yeah, all of a sudden we're left with either that port or that one, because a COM port is always going to common ground. So the way it phrased, let's see, this right here, connected to the COM ports, which is not correct. It should be whatever's left over, which COM port is an incorrect wiring, as I explained in that correction. But then also, it's not a 3.5 millimeter jack you're hooking up. A calculator's link cable is completely different. As indicated, right, TI link cable. Yeah, here we go. That's not a 3.5 millimeter jack right there. That's completely different. So, yeah, it's not a 3.5 millimeter jack, but I did have that as an initial idea. Then I realized it doesn't go into that port right there. So, fun fact, I ordered that cable just so that I could make the film work. I'm not ever going to actually use it other than this film, so don't know why I did that, but the film probably wouldn't have been nearly as possible otherwise. So, yeah, I'm going to have to correct the 3.5 millimeter jack and then clarify the COM port's likely incorrect. I want to make sure that's properly addressed. So then, let's see. Oh, right. If you look at that, the energy requirement was determined using substitution techniques and mathematical modeling. So this has to do with how my math sheet arrived at 1.21 gigawatts, as shown earlier. There. How did my math arrive there? Well, what I actually did was substitution mathematical steps. That's how I made it happen. So, yeah. But it shouldn't say that here, because if that were real math, I probably wouldn't even be doing substitution. So it ties with, yeah, basically it shouldn't explain substitution techniques and all that. I want to real quickly make sure that I have notes on that. Come on. Substitution. Well, if I can spell substitution, I'm going to want to clarify to it I'm not even using that. And then last but not least, we're going to need to clarify why I'm doing the time travel in case people wonder that. Obviously, I'm really doing it because I wanted to explore Back to the Future concepts, which, where's that chapter located? Oh, I don't think it can do time codes for the actual time travel moments. I'm gonna ask it, see if it can answer that question. Oh crap, I didn't want to do it on this thread. I wanted to do it on the newer one. Oh well. 2643. Okay. Yeah, I just didn't provide a transcript, so I'll illustrate how I trained everything later, but essentially I gave it a transcript, but then I gave it all the chapter markers too. So if the chapter markers aren't precise enough, it can then reference the transcript to figure out a more precise time code in theory. Who knows whether that actually works though. It's kind of hard to test it. So 2643. Yep. So like, yeah, right here. This is really the reason why I made the time travel film. You'll notice a lot of Back to the Future like concepts here. Try not to run into them. They're in there in case you can't tell. Great. How's this gonna go? This is clearly Back to the Future, I think. Computer, wake up. How did they not see me there? That voice command was real, as I explained in the podcast and stuff. And some live streams. We gotta get out of here. Computer, open Seinfeld. Nice. Yeah, this is basically what I wanted to explore. This is the only reason I made the film. So yeah. Did I open that? I must have forgot. Of course, the only reason I got up there is to grab my phone. I think I should technically be going to eat supper now, so I'm gonna actually pause. And then I'll pick up after supper. So I'll see you in a little bit then. I'm gonna put in time estimates, so if you lost any context, this would be a good time to rewind and find that. So I'll see you after supper. I'm gonna put a timer on there too. Alright, I'm back now, so let's resume. Took a little longer than I thought, but here we are now. Mic should be working fine again. Now I gotta wake up the computer. So I just finished kind of going over the real reason for the time travel film. We got all these other things along with it as a result of that. So I think this would be a good point to get into the custom chatbot creation. Oh yeah, I was actually finishing rambling about one of the points, one of the things I need to clarify about why I'm doing the time travel film. Mentions time traveling in the past to save themselves time, which yes, that's true, but there are some specifics that I haven't trained it on yet. I don't know if I'm going to do that tonight, but I basically want to clarify what I'm doing the time travel for so that it knows. So yeah, it's more than just the time travel to save time, as I mentioned here. So yeah, why don't we get into it? So it is pretty impressive what it could do so far. So it can do the time code stuff. It can explain pretty much all those concepts like ionization, temporal dispersion, all those different concepts. So yeah, this is one of the things I wanted to create a custom chatbot on, since I wanted to learn what that process looked like in the first place. So how does that custom GPT stuff work anyway? So basically what you do is you go to your custom GPTs right here. And this is the one for my time travel one. And this is what it looks like to refine it. So this is the actual configuration of the chatbot right there. And then this is what you usually use to create or modify it. So what this does here is, this is actually, I was trying to understand what was going on and how it worked and all that type of stuff. But that create tab, what it is a general chat GPT, but it has the ability to modify things in this configure tab. So it's a standard chatbot, but it has the ability to tweak the model, like the instructions or using DALL-E to change the profile picture. I didn't create that profile picture, it did that automatically. So I could very well tell it I want to change the profile picture, and then it'll do that. And it could directly modify that. So this is basically standard ChatGPT right there, except it's a little bit programmed to be able to tweak these things right here. As far as the knowledge that I've trained it on, it's basically all these documents right here are where all the materials are. So it's kind of interesting because these are custom instructions about what it needs to do. Like everything is real. Trying to tell it that and do that essentially. And then I give it some knowledge. So at first I was interested about the knowledge bit, because what if there's a limit for the number of, or the amount of information that I provide it? Well, what's interesting about this is, since this is a standard chatbot, actually custom models are technically a standard chatbot. It just has some customized instructions on it, and it has some knowledge right here. But there's a really interesting nuance that's worth noting about that, and something that I learned creating these models. That's what I want to demonstrate next. So this is a standard ChatGPT. You know that when you interact with a chatbot, it breaks down what you say into tokens, and what it says is also tokens behind the scenes, which think of it like a word or part of a word. It's basically broken down. So every time you write a message, it gets tokenized into tokens. And then the large language model does machine learning. So you might have heard that large language models are actually prediction based, which is true because it has some information right here. It outputted this information. Then when I give it a message, it'll tokenize that into representations of all the words that I say or all the bits of information. So actually, if you want to learn more about how that concept works, there's a great channel by the name of 3 Blue 1 Brown. You might have heard of them before, but they explain machine learning and large language models in pretty good depth. And honestly, this has probably some of the best explanations I've seen on the entire concept, like pretty much anywhere. In fact, somebody even said that with the way they presented it, puts the general education system to shame. So they have really done some impressive stuff with the way they explain how these concepts work. So I'm not sure if I linked that in the description of this video yet. If I haven't, I'll try to remember to do so. In fact, I'll leave a note for myself to do that right now. Okay. So I'll remember this as a critical moment for later if I haven't yet. So yeah, this will kind of go over how large language models actually work. It goes over, this is a nice introduction right here. It kind of goes over machine learning and deep learning in general on how all the mechanisms work, how there's basically weighted connections right here. And it uses feed forward. It's basically taking the idea of making programming sort of abstract and allow you to give it some input, like how functions have an input and output. You normally program it, but this allows you to create what we consider tunable parameters that are dynamic. And it isn't like you program what they are, but with the program, you can program the concepts in and essentially train it almost like you train a living brain in some ways. It emulates that concept using computer programming and math. So all the connections between those neurons, much like human brain neurons, they all have a weight associated with them, which is some sort of value. And essentially, the input can be represented by one or more of these nodes. That goes through the weights, which usually some matrix multiplication will happen, and then you end up with some output. In the case of large language models, the output is a chat response to your query. And so yeah, everything you write gets converted into tokens, which goes through here, goes through multiple layers of that. Does something called attention, as explained in the video resource I'm describing here. And then there's an output, which will be the resulting text. So an input gets converted into something that works well with this format. Some matrix math will happen as it feeds through, and then there'll be some output. So typically, there's a bunch of different algorithms that are involved with this, like since there's weighted connections with all those lines there, which could be numbers between like -1 and 1, or could be even more broad than that. All those numbers get initialized randomly, and no matter what, when you initialize them randomly, they'll have some sort of output, even if it's incorrect. You then take that output, you train it on some known data. You're like, here's an input, and then here's the output that it should have. And then you calculate like an error, which is a difference between what it produced and what it ended up, or what it should have been. So a difference between what it was and what it should have been. That gets calculated. Based on that calculation, it then back propagates, as indicated in this video, so that it can tweak those parameters so that next time it gets that same input, the output will more accurately reflect what it should have been. So there's a whole bunch of training that happens on that. And that's kind of the general idea. So it's more advanced than just mathematical equations. These are, you could say, dynamic equations because you can define how many of these nodes there are and what to do with them. So you might do anything from classifying an image, like here's a cat, here's a dog. All the pixels will get converted into inputs right there. And there's hidden neurons where that math happens between each connection, a bunch of matrix math that gets whittled down into the output, which will either be smaller or bigger than the input. How it functions might depend on how that's architected, of course. So, yeah, if you give it an image of a cat, it'll predict the word cat. So as it goes through that image, it'll feed through. It's trained on a bunch of data. It's tuned to what it's trained. It's been refined several times, ideally. And then if you give it a cat or a dog or whatever, the output will typically be anything it can guess for images. It'll do probability values and then usually pick the highest probability for what the output could be. It might be wrong, but it'll go with the highest guess based on what the matrix math results in and all that. There's probably other algorithms in between, like the numbers themselves aren't going to be percentages likely, but there's some algorithms that can normalize it so that all the outputs become percentages, where if you add them all together, they become one. That works well for that. And even with large language models, it does something quite similar to that. So there's a bunch of mechanisms on top of that. So basically every token, I guess you could say that's the input, and then there's a bunch of layers of stuff, like the output will be for the next word, and each token will have a bunch of numbers represented. Think of it like a long list of numbers. As I indicated on this video, there's like 12,288 numbers per token, I believe, that represent it. And it captures the meaning of the word and all that stuff. You can imagine that depending on how a word is used, it can mean something different depending on where it's used. Like the word light. If I'm talking about like a flashlight or a ceiling light or something else like that. Or the lighting for the green screen so that the green screen works really well. Well, depending on which kind of light you're talking about, or the opposite of heavy, that's a different kind of light. Well, depending on the context, it can have different meanings, right? So that long list of numbers with each token, all those numbers are meant to embed the meaning into it. And then there's a mechanism called attention, which allows each token to look at each other token, tweak those numbers to adapt the meaning. So no matter what, any token will have a default list of numbers. But when it's next to a bunch of other words and stuff, that'll get refined. And they get to look at each other and adapt the numbers accordingly. So if you think of each word as being plotted out in several dimensions, where it is in that plot is based on what the meaning is at the time, and the list of numbers is, think of it like coordinates but in thousands of dimensions. So that will encapsulate the meaning. Then you can imagine that for the next word that it hasn't predicted yet, that's essentially, there's going to be a resulting vector before the word is even generated. Then matrix math will happen on that once the attention mechanisms have taken hold. There's a bunch of attention doesn't just happen once, it's probably going to happen several times in multiple layers. So like there's multi-layer perceptrons, which the fact that there's so many circles right here, actually the way you typically represent it is, I believe it or not, I have a whiteboard here, whether you realize that or not, but basically we have these input neurons, then there's like hidden neurons, and then there's going to be some sort of output in all these neurons are connected to each other like that, right? So the input could be like an image of a cat. The pixels get converted into this format, and it's likely not going to be every individual pixel. You can do that, but you're going to lose efficiency, and you'd be surprised how much processing is required depending on how many pixels there are. So you might use convolutional neural networks where a bunch of operations happen on the pixels. Like if you take like a 3x3 grid of pixels, you could take like the highest value, the highest color value of the pixel, and then that becomes like one convolution or whatever. You're basically summarizing images using operations like taking the highest or brightest pixel or the darkest pixel in like a 3x3 grid. You'd be surprised how much more efficient the process becomes when you, or the processing when you do that sort of thing. So yeah, all the weighted embeddings in like large language models might be like 6.3 minus 7.2 or whatever it is. It's a list of 12,000 items. Not all on the frame, but you might have those numbers that I just showed. 6.3, negative 7.2, and so on. So all those numbers are with each token. Then a bunch of matrix math happens where you have, I don't need to represent the full thing, but you might have like a large matrix of numbers, 3, 6, 9, 12. And then you can multiply with another grid of these numbers, and that'll result in something. So for the word that you're predicting, there's going to be a matrix from the multiplication of everything with attention. So you have a sentence, but then what's the next word? Well, you take the list of numbers that looks like this, multiply it by probably stuff regarding the initial models. So actually the way large language models likely are, I don't know if we know this for certain, some of it's probably proprietary how it's actually architected, but what you might have is your initial model, which you basically have a whole bunch of different statements in their answer. Like, what's a good one? The name of the person who created ChatGPT is blank. Well, when you're trying to predict what that blank is, you're likely taking the vectors with the matrix of each representation, taking the vectors of that, multiply the vectors of the initial model, then you're probably gonna multiply it by custom instructions of the actual chatbot. So even ChatGPT in general, when we're chatting with it, it's likely that that's based on custom instructions. Even if we're not given them publicly, there's probably still custom instructions regardless. And we have the initial model with a bunch of factual statements combined with the custom instructions, and I'm guessing there's probably some matrix math that results from those. And now you have your customized chatbot. Take an initial model combined with the custom instructions. Now you've got a customized chatbot. And when I say combining these things, I mean in the form of vectors like that, probably. And then you're going to tokenize what you send it. Like if I write a message here, then you probably do some matrix multiplication on that. And I'm sure there's other operations too. Once you get the resulting vector of the word you're predicting, so the attention mechanism will tweak all the vectors to encapsulate meaning. The matrix multiply together, then you'll get a resulting vector for the word that it hasn't predicted yet, after factoring in context and all those things. And then you run that through an algorithm that'll normalize the list of vectors like this, convert them into percentages, and then it'll all add up to 1. And it's not always going to pick the highest probability, mainly so that it appears pretty random, a little more authentic. And it's not always going to pick the highest probability for the prediction at all times, but basically that operation keeps happening, as Grant Sanderson will explain on the 3 Blue 1 Brown videos. So yeah, rather than just listening to me talk about that, I'd recommend watching this and these videos right here. I think they do a great job explaining all those concepts that I just went over in much more depth than I could do it. And there's visuals that help. I did not do any visuals myself. Sorry about that. Honestly, this video even puts my explanation to shame. But yeah. So you got a bunch of inputs. Math will happen between all those neurons, and then the output, in the case of a chatbot, will be the message it's sending back to you. What is my whole point with that? Oh, so each thing that it does is a token, right? That could either be a word or part of a word. So what I was trying to get at right there was ChatGPT has 128,000 tokens with the current model. So this model has 128,000 tokens of context that it can store. So context is sort of like you have your initial model with the initial training combined with the custom instruction. So even ChatGPT in general is probably going to be something like, you're a helpful chatbot that can interact with the user in a friendly way. When you interact with ChatGPT in general, the instructions could very well be something like that. So yeah, then combine that with the context of what you're doing right now. So you're writing messages back and forth. That all gets tokenized. The amount of tokens it can store as of right now is 128,000. It used to be 16,000, so that's the amount of context it can maintain. But the reason why that's important is because what about the custom information that you provided right here? This information is well over 128,000 tokens. Like, if the context that it could hold is way more than that, it won't be able to store all the information, right? So what it actually does is, this is 128,000 tokens, just like ChatGPT in general. However, what it does here is, there's like a metaphorical short-term and long-term memory that it has, essentially. So there's actually different types of chatbots depending on how you're using it. So custom chatbots, you might think that you could get around that 128,000 token limit, but that's not really what you're doing at all here. So even if you're storing several tokens, obviously you can only write so many messages, and then what you write at the top is, the context becomes lost over time, and also becomes less important over time too, even if not completely lost. The human brain, let's face it, probably works in very similar ways regarding that. So yeah, there's 128,000 tokens even with custom chatbots. This doesn't actually provide you more tokens than ChatGPT in general. What it does is, this is just simply information that you got right here, but it's more like it's stored in a library that it could use to access information whenever it wants to. But it's not in the immediate short-term context. So if you ask it a question about something, it might end up looking up information right here and bring it into the short-term context. So I like to think of the chatbot as having a short-term and long-term memory. So the 128k tokens, that pertains to the short-term context. And then long-term memory, that's completely separate. Like what you provide right here actually goes into the long-term memory rather than short-term. The reason why that's important is because if the information needs to get accessed, it's actually getting fetched on the spot. It's sort of like if an expert answered your questions, rather than being able to answer off the top of its head, it goes to a library, looks up the information, and then is like, okay, here's what I found. So this knowledge right here, it isn't directly in its brain, if you will. It's in a library that it has access to and will access information as needed. So it's actually more like this right here. So the knowledge that I provided right here, it's not really immediately in its brain, if you will. It's right here. So when you ask it questions that are inside of here, it essentially looks at the library, tries to find the specific information that it needs, like right there, for example, and then it grabs the knowledge and it's like, okay, here's what's in the provided materials, or something like that. That's why you might remember earlier there was a chat message. What was it? Might have been this one. In the time travel framework you provided, it probably naturally had that phrase, and because it's essentially grabbing its information from this, if you will. This is all the information I provided it, but it's not in the immediate context. So anytime I create a new chat thread with this, it likely starts out with pretty much no context, other than maybe these custom instructions. So when a chatbot generates an answer, it's an initial model, which you could think of like a brain stored in a computer file. So it's that combined with these instructions. That's what makes a custom chatbot. And these instructions might teach it how to fetch information from there. That's likely what's actually going on in reality. So why is this distinction important with the short-term versus long-term memory? Well, if you ever get strange behavior, that's what it pertains to. So I've had times where it doesn't seem like it learned any of the information at all. But that's because while the information is provided right here, the instructions don't really, well, it's not like it could just access any information at any time. If there's a bunch of information buried in those files, it's probably never gonna come across it, even though it's there. Why? It's not like I'm gonna have all these books off the top of my head, right? Not even the color of those books. I don't know what those books are. But even if I look at it for a while, I wouldn't be able to tell you what all those colors are, much less the content in them. So there could be a bunch of information in these that will never get accessed because of the same phenomenon of why you wouldn't just know everything off the top of your head. And because you don't know everything off the top of your head, there's going to be information, let's say this book right here, that you'll never learn in your lifetime, even though it's there and accessible. So that's a problem. If you provided information like this, it's stored in the long-term memory rather than the short-term memory. So in the context of long-term memory, it's like the person who's fetching information for you is doing it from here rather than from their mind directly. You could see that they're probably going to miss certain things. Like you have a question like, what are some studies that show how deep sleep will improve memory in the future and reduce the risk of Alzheimer's and stuff? Well, there's quite a few studies on that already, but being able to find that information, you're probably going to miss a few things when you're looking for research on this. It's unlikely that even with a thorough search, you're going to come across all the research that exists. Why? There's research like this dispersed across the world. You're probably only going to come across like maybe even this much right here. Who knows? So you could see how that would be a problem with how the chatbot behaves. So that's what I learned the hard way. I provided it a bunch of information and it didn't even retain, or it couldn't even answer most of the questions accurately despite the information being there. Why? Because it's not directly in this chatbot's brain. The chatbot does a fetch from this. And what you want is, if it's going to work well, you want to categorize your information by things that are very clear. When I struggled with it at first, it's because I pretty much had all the information in one place, thinking it could easily access all of it, but it can't because of this. So what you want to do if you want it to work well, break up your information into categories like this. And then on top of that, you want to provide good instructions that not only highlight the key concepts like this, but information that it's going to need to be able to access. There should be good instructions on which files have what information and all that kind of stuff. Or at the very least, the title should be intuitive so it can stumble across what it needs to. I mean, imagine you're doing research for something and there's like really good research, but it's poorly classified and poorly indexed. Well, you're going to be misled trying to do your research because you're not going to be able to find the truly good information if it's poorly categorized. And it's not like it's all here, so you can be like, not like you can be like Commander Data going, humor means, I don't even know what it is, but you get the idea. He probably actually has a very similar mechanism right there, but it is still accessible directly in his positronic brain. So if the information's there, he'll know it. Whereas if it's in books like this, there's probably stuff you're never going to run across that you should for a good retrieval. So yeah, how do you work around that? You have really good instructions that can accurately fetch the information as needed. I really think of this like a LTO tape library. If you're familiar with linear tape open, you can archive a whole bunch of data on VHS style tapes, except they're a little bit different. They're the same kind of material, I believe, but they're designed to store any type of data besides videos alone. So there's libraries where you can actually store a whole bunch of tapes inside of a library, several terabytes per tape. And if you try to retrieve a specific file, there's literally a robot arm that'll find the tape that has the information you need, pull it out of the shelf, put it into the drive, and then scroll through the linear tape until it gets all the information that's needed. To me, that's actually quite a similar process to this. How did it figure out where the file was located if it's all in one directory structure? Well, it indexes it, so if you're accessing a file, it's like, that's on tape 7, because it took note of that. It took note of every tape that every file is on. So if you're accessing some on this specific tape, it knows that because it categorized it ahead of time. And it'll be able to fetch it relatively efficiently because it accurately categorized it. And what you're doing here is so when it actually categorizes all the files, and knows which tape to access it on immediately. It's not like it's going tape 1. Is it there? No. How about tape 2? Nope. How about tape 3? Yep, there it is. Right? No, it knows that it's tape 7 right away, or tape 3 right away, because it made note of where everything is ahead of time. Anytime you create a file, it makes like a mental note, if you will. So then anytime you access a file, it immediately knows which tape to grab out of hundreds. And there it is. Because it created an index of where everything is. So what you want to do here is do a good job classifying your information. So do a good job categorizing it here, and then have good instructions that will be able to essentially do that indexing and fetching without fail. So good instructions will be able to fetch information from this without fail. When I first trained the model, it felt like it was going nowhere. And I'm like, I spent all this time getting information together and it doesn't even work. Why? Well, this is what's at play. So I need to train it incrementally and be like, okay, here's how this works. Makes sense? Want to do a quick test? Let's see how accurately you can do this. Okay, great. Now integrate that into your memory. In other words, update the instructions so that the information that it accessed to do it correctly right then, it'll be able to replicate those results with good instructions. So when you're interacting with this, you're basically explaining in a human-like conversation what you need it to do and training it on that, making sure it's on the same page as us. And then based on what it knows there, it then tweaks these instructions so this is a short-term context window with 128,000 tokens, right? So if I've interacted with it 15 times here, 15 back and forth messages, well, if I close it out, that's permanently erased. But based on what it learned just then, because I was talking to it about what it needed to do, well, tweak the instructions so that even when the short-term context is lost, it'll be able to accurately reproduce what it knew the first time. So yes, every time you interact with a custom chatbot, it's technically relearning everything for every chat thread you do. That's what it's doing. That's why you might have noticed when I went on, I think it was this thread right here, the first thread that I went on, you might remember it says searching my knowledge. That's likely because it went through the custom instructions, fetched anything that it needed based on what it knows it needs to fetch with the short-term context window, then generated an answer. So when it says searching my knowledge, that's likely a time that it's going to hear. If it just produces an answer without doing that, either it did it so fast we couldn't tell it did that, or it's in the short-term context window already. So if you ask it about like temporal dispersion, for example, well, that's one of the key concepts. So it's like, okay. And then there's a temporal dispersion segment lower down. And then it looks through these resources and figures out what's relevant, like, temporal dispersions in the title here. There must be some relevant information there. Basically reads through that entire book. Let's say that's the temporal dispersion book. Then it integrates it into the short-term memory window. And then there's probably some more temporal dispersion stuff here. And I'm sure there's at least one more temporal dispersion resource there. So it basically reads it, highlights any notes that are important, integrates that into the short-term context window. Then it's immediately available when you talk to it. So yeah, it's a pretty clever system because, well, it's got its flaws, obviously. You have to make it so that it can fetch things without fail. But this is not limited to 128,000 tokens because of that system. This is really just storing files, more or less. It's not actually taking up machine learning space immediately. It's available, but that doesn't mean it's immediately used. I suppose it's sort of like our brain versus having a whole library of books. I have like a whole bunch of books in my bookshelf right there. I don't know every word off the top of my head. I wouldn't be able to recite page 47 of that book right there because, yeah, I don't have it in my mind, but I have it accessible. That's how it is for this. Everything here is accessible, but it's not immediately in the mind of the chatbot. And every chat thread is almost like a separate mind in some regards because, yeah, what makes a chatbot, I suppose you could say, is the initial model, what it was initially trained on, right in the short-term memory. Much like our current brain's configuration, what do I know without looking anything up off the top of my head right now? Well, I know how to set things up for a live stream here and all sorts of other things. I know Vim without looking anything up. I mean, not all of it, but a lot of it. I know a bunch of stuff without having to look things up because it's readily available here. But obviously books are supplemental information that I have access to, but it's not readily available, and I'm unaware of it. Every chat thread we create, it's initially unaware of any custom instructions, or I should say knowledge right here. Obviously a general base model, what I'm trying to get at is what I know right now. Like I just said, the how to set up a live stream, Vim shortcuts, computer things, my language in general. Saying that off the top of my head, I now know that there's a song playing called Mixer Effect. That's what the current song is called. I didn't know that until I looked it up just now. But the point is, the initial model is those things that I know without looking stuff up. Custom instructions are sort of tacked onto it, like its purpose. I suppose your job description to be able to do a job and your training on a job could be like those custom instructions. And then at a job, if there's information that you don't know off the top of your head but need access to, like if you're a programmer, Stack Overflow could be like this, if you will. Let's face it, a lot of programming is actually that. Speaking of which, I have a feeling my blue light filter is currently on. Should probably shut that off. Sorry about that if it looked kind of weird, especially if you have your own on top of that. Right. So yeah, that's kind of how it is. This is like the things that you don't need to know off the top of your head but will use in a job. Like if I'm writing a script for something, well, that might be a poor example because depending on your leadership role, you might need to know a lot of stuff off the top of your head, but well, you at least have the tools to figure it out. So say you have to create a Docker container with bind mounts and you don't know how bind mounts work off the top of your head, you at least know enough about Docker that you should know how to look up how to do it relatively quickly. Like, okay, so you link it to this drive, whatever, bind, create this volume, then it's always linked to your actual system within a container. So that might be something I need to do at a job that I don't know off the top of my head. I might do a search in this, if you will, get what I need in my short-term memory so that I can actually perform tasks, then get it done. So yeah, that's kind of how it might relate to a job. So this is a pretty important concept because it massively affects how you train it. Because obviously you could just tack a bunch of information in one source and not categorize it if everything was available in the short-term context window. That does have side effects of its own, like it might mishmash information that it thinks is relevant, but actually these two things have nothing to do with each other. I thought I'd give some examples on that very concept. When I realized this short-term versus long-term thing, it made me realize so much about how these custom chatbots actually work. So, yeah, I basically trained it on one resource at a time. And I was like, are you on the same page here? All right, here's the next bit of information to integrate. And that's literally how I phrased it on this tab right here, which is a short-term context window needed to learn information temporarily and have enough retained that I can make proper tweaks to the instructions. So I didn't create these instructions right here, but it was based on past conversations. And now because of these instructions, it can relatively accurately understand what it's done in the past because it integrated that right there. So yeah, when you have that short-term plus long-term context right there, you need good instructions to be able to fetch things without fail. And there's probably still some things that it screws up right now, where it might work in some context, but depending on the nature of the conversation, it will end up doing it wrong because of the way the conversation was flowing. So as for how it integrates information like these instructions, I would imagine that these instructions are a higher priority than the chat thread itself because I'm guessing they get factored in just about every answer that's generated. And actually the tokens, the list of numbers as shown right here, we could call these the embedded tokens because they've gone through that attention mechanism and they've been tweaked to encapsulate the meaning. Those would be embedded tokens. Well, what is my point? Losing a train of thought, that's probably a human nuance, so you're not gonna notice much on machine learning models. So yeah, the embedded tokens, the list of numbers, the 12,288 numbers that are in each token, they've had the attention mechanism done to it. And I would imagine that when context is either maintained or lost over time, some context probably has a higher priority than other contexts. I've noticed when doing certain chats in the past, if I tell it to hold on to specific information, like I'm doing a long chat thread and I tell it to hold on to important information, that tends to be enough for it to be able to do that. It almost prioritizes itself in terms of how it holds on to information. So I think there's probably like a priority factor for the way it holds on to information. And I would imagine the custom instructions have a much higher priority than anything in the chat thread. Things here can get lost over time, it's not a big deal. But this, if you lose this, you essentially lose the heart of your custom chatbot. You don't want that. So there's probably either a priority for how things are held. Otherwise, you have your initial model, which is like, in my case, in my brain is a model. What I know at this moment without looking up any information, that's the initial model. Plus the custom instructions. There could be some matrix math to essentially make the custom chatbot, and it's always going to be that plus any message you write to it and current context. So if I write a bunch of back and forth, I would imagine that when it generates the next answer, it's likely going to be the initial model plus new information, or plus the custom instructions, there might be like a product result of that with those being multiplied together. It'll be that plus each of the messages in the short-term context window that ends up getting involved in generating the final output. That's how I imagine it works right now. There's probably some more nuances in that. I would imagine there's proprietary information with the underlying mechanisms that the companies of these chatbots can't disclose. So I'll be showing a Google one in a second where it has a much higher context window, and I would imagine the thing that makes that possible is proprietary. So yeah, so now that you understand why it's important to categorize and index information and have good instructions on fetching that index information, and the fact that this is just a short-term context window like any chatbot really, with the ability to tweak anything inside of here, including probably deleting information there. Since that's essentially what this chatbot is, basically any ChatGPT, but the ability to configure this on top of that. Now that you know all that, let's do a demonstration on why the context window stuff with short-term versus this is a very important thing to understand when you're creating a custom chatbot. Before we actually delve into the time travel stuff. So you might notice some lucid dreaming chatbots that I have right here, and there's two of them. They're both trained on the same information, but what I often notice is when I chatted with it, it often pulled information from... So first of all, I should clarify that most of the information online for lucid dreaming is misinformation, because a lot of people distort it and oversimplify certain things, and then the game of telephone essentially happens where nobody questions the original source, and some of the most important aspects of the information actually gets lost, and then that makes the information essentially ineffective, and that's what makes it misinformation over time, unless you're getting it from the original sources. Like oftentimes Dr. Stephen LaBerge is a prominent figure with lucid dreaming. He was the one that popularized lucid dreaming, and a lot of people think that he proved lucid dreaming scientifically, for example, but it was actually Dr. Keith Hearn that proved it in 1975. But LaBerge seems to get a lot of the credit because that's what people think. When you look at the original sources, that's not what actually happened. Dr. Keith Hearn proved it first. So that's one bit of misinformation, but there's a lot. So remember the concept I said where you have your general model plus custom instructions plus the short-term context? Well, what often happens is your initial information will get mixed in, even if you have the refined information within your that. I'm just gonna show this picture anytime I'm referring to this rather than describing it, because I can never figure out the perfect word to describe this. A word is worth 1,000 pictures, or am I getting that backwards? 1,000 pictures is worth one word? Oh, what is it? Well, see, I'm confusing myself on that. To avoid confusion, I'm just going to stick with this when I describe the long-term memory. So anytime I refer to this, know that that's what I mean, all right? So, yeah, I forget what I was originally getting at, but the reason why I have two of these is because, oh, right. So you have your initial model plus custom instructions plus the short-term context window. And anything that's inside of here gets temporarily brought into the short-term context window before an answer can get generated in the chatbot. So when it formulates its answer, anything that comes from here gets loaded into the immediate knowledge first, and then that gets in the final output. So yeah, I mean, anything it says is ultimately from the short-term memory. But even if it's something you didn't immediately know, probably fetched it from here first into short-term memory and then to us, more or less. So what we got here, when I say that it, despite having accurate information, it often produces misinformation on lucid dreaming. Why? Because not only can it pull from here, which is my resources and custom instructions to fetch, but also so now this is something that AI chatbots don't run into when you lose your train of thought. Maybe it'll get emulated someday. Wouldn't that be scary? Everybody's scared of how much AI is advancing, but wouldn't it be scary if AI could lose its train of thought? That would probably freak me out. So yeah, when there's misinformation, it can either come from this with not fetching it when it should, or it can come from that initial model. What I often find is, like I said, you got initial model plus the custom things, right? Well, even though it might have accurate information in the custom information from here, it can still grab inaccurate information from here, even if it's told not to. These two custom chatbots were actually trained on the same information, but I decided to take things from a different approach between them. One of them is designed to, so obviously the behind the scenes podcast that I referenced right here, I talk quite a bit about lucid dreaming. If you want to learn about lucid dreaming from me, you can probably learn quite a bit from these resources here. And there's quite a bit of information in the third part that hasn't come out yet for the post-production. But I trained this on information from, now let's close this out. I trained it on information from this, including the third part, which isn't available yet. And despite the fact that I've clarified some misinformation in those recordings, it tends to produce some inaccurate results sometimes. Because, like I said, you got the initial brain plus the everything else that's custom. This can get mismatched in the answers, even if it has accurate information here. Like I said, am I ever gonna come across everything and possibly miss some important information from this if I'm trying to access information? Probably. There's probably valuable information I'm never gonna find. And that's, I think, what happens when it pulls from the general model. That's an example of it not doing this where it should have. So these two chatbots that oh, jeepers, I stabbed myself on the whiteboard. No blood, that's a good sign, but some skin might come off. Oh well. So the reason these two chatbots exist is because I took different approaches. One of them is just a general knowledge base from the podcast, whereas the other one, I'm treating it like it's information from the podcast rather than just general knowledge. And I thought maybe one would perform better than the other. For some things it does, but for other things it pulls from the general brain. Wish I had a picture for that, because then I could just keep showing that over and over again. So yeah, so if you look at this one, I tried to tell it to stay grounded in the provided... Wait, what? It almost looks like there's no provided resources on this one. How's that possible? Nor this. Is the information lost? That's a little concerning. Huh. Well, if it's been pulling from the general model, that would sure explain a lot. It did have the information at one point, but there was a point within the last few months where ChatGPT underwent major update changes, and it's possible that inside of that, all the resources got lost. Actually, I bet this says updates pending because now the information's gone. That's a wonderful update when you lose all your information. Bet it had it before. So yeah, that's a little unfortunate. So why don't I re-upload the information from this location here? So I think what I did was I specifically curated the lucid dream parts of the podcast here. Then I removed the time codes to minimize how many tokens are taken up, because I'm more after the information than the time codes. And then I make Star Trek recommendations since I got into Star Trek and I started rambling about that. That's kind of relevant. I tie some dreaming stuff to that as well. So this isn't actually tweaking the model at all. It's just simply uploading books, if you will, that it gets to access whenever it wants. But it's not actually tweaking the model itself. So let's update it with those resources. Wonder why it's taking a long time. And then let's do the same thing for this one. Pre and post production. I talk about lucid dreaming in both of them. Wasn't originally going to, but I ramble about one thing and it's like, how many times am I going to ramble into one of my favorite subjects? Too many times that I may as well give some context on it and all that. So that's why I rambled about that. I have no regrets. And you can use the time code navigation if you don't care about that. To me, it's actually a lot more interesting than the time travel stuff itself. But time code navigation will allow you to decide what you want from either one of them. So yeah, this is basically what's in the library. But despite information being accessible there, here, let me open it. Let me show you what it looks like. So it's basically just a glob of information from the podcast pertaining to lucid dreaming stuff. It's uncategorized. Everything is just right there. And now that you know that information is accessed in this fashion, don't you think that same phenomenon is going to happen? Yeah, look at this. This is a bonkers amount of information. In fact, if we wanted to get technical about the tokens, I think there's a... I'm not going to use an API because I have to set that up. Wait. If I can count tokens, then I I thought I'd have to set up an API to get this to work. I'm not sure if the custom chatbots are based on this or this. Actually, I would guess this because if you have the free version of ChatGPT, there's a quota for how much you can interact with custom chatbots. And there isn't a quota for these models. So it's definitely using this. So anyway, if I were to grab all this information and count how many tokens that is, so much that it's freezing up the website. Yeah, that's well over 128,000 tokens that can be stored in the short-term memory. But since we have this phenomenon as well, there's virtually no limit for that one, in theory. So the resources are that many tokens plus whatever's in these resources too. So yeah, there's, oh yeah, also notice how this is breaking it up. It's generally each word, but I think there's some words that get broken up into 2 tokens. Can't see it anywhere, but I'm sure there's some that are, look at that. Holodeck is probably a less conventional word, so maybe that's why it's broken up into multiple tokens. And each one of those tokens has 12,000 or so of those numbers. Maybe more nowadays. Maybe you're in the future when only 12,000 dimensions is laughable nowadays. So, yeah. Oops. Never meant to open that up. Let's terminate that. Yeah, Rocket Doc's kind of a cool utility. Make sure we're not dropping frames. Looked like there was a bit of lag, but I want to make sure we're not dropping frames on the stream. So far, we haven't yet. That's pretty cool. Holographic is probably a slightly less conventional word too. So that's broken up into multiple tokens. So yeah, there's a lot of tokens that are stored inside of here. So when it pulls, so like I said, the general models are unfortunately mostly misinformation. And by the way, if you want a good lucid dreaming chatbot, I highly recommend the one that sleep and dream researcher Daniel Love made. Where is it? It usually shows up here. It's called the Lucid Dreaming Guide. Daniel's undergone the same process as what I'm describing here. There it is. So yeah, if you want to chat about lucid dreaming, I think this is probably going to be one of the most accurate models. It's undergone a lot of iterations, I'm sure. I put more stock in this than what I created or pretty much any other lucid dreaming chatbot. This person's been doing lucid dreaming stuff for decades, and if they're comfortable releasing that to the public, they must have done a lot of training, and they usually don't take those things lightly, so that says a lot if we were confident releasing that into the public. But of course, that doesn't replace human teaching or anything like that. But yeah, if you want to learn about lucid dreaming, I stick with that resource I just mentioned. They probably did a good job indexing and fetching from here. So yeah, now that I provided the resources here, even if I provided information about pretty much anything that I talk about, probably not going to fetch it from here because it's not properly indexed, and it ain't gonna go through all that. So unfortunately, it can be inaccurate. I mean, look at this. This is generally inaccurate, and the general AI models do not have this information accurate, despite the fact that Dr. Stephen LaBerge is an original source for that. I think it actually used to be more accurate, but once it got more information over time, guess what happened? With the general brain, before any custom malarkey. So, yeah, a lot of this, there's stuff to emphasize focusing on those resources. You can tell it to strictly focus on these resources and not the general internet. But even if you do that, you're still at the mercy of this concept, and it's likely going to do it wrong. So that's one of the problems that comes with that system. And I'm going to contrast this in a little bit. I'm emphasizing this a lot because I'm going to do a comparison between this and something that can actually store all the tokens at once. And I want you to notice the difference in the answer that it generates. So let's create a chat with this one. Let's see how it does with this now. If it does correct, it's because it's got good instructions on that in particular. I gave it that example of what it did wrong, so if it's correct, it's only because the instructions have been refined for that specific thing. But it's going to be wrong in general, more than likely. Okay, developed by Dr. Stephen LaBerge. Actually, I didn't provide mild instructions in my own resources, so I don't know why I asked it that question, because I didn't really talk about it. Despite how much information I have here, I didn't really go over it very much. So, set your intention, recall a recent dream, recognize a dream as a dream. That's actually quite grounded overall. That's a little more, I'd have to double check and verify that that's as accurate as I'd want it to be, but that's actually quite grounded compared to what I was expecting. Let's try it with ChatGPT in general. Am I experiencing lag? I don't think so. It looks laggy to me, but that could just be what I'm seeing. So let's ask it the same question as this. What are the key steps for mild? So this is a general model. Oh no. I should have done 4.0. Actually, if this is accurate, it's because it probably, ChatGPT has gotten smart to the point where it actually maintains certain context across multiple threads. And it's possible that it actually grabbed from my custom model, even though I'm not using a custom model here at all. If I'm getting accurate information with the general model, it's possible that it's actually from this rather than that general model. But I think there's actually some, if you look at the settings, I think there's actually some, customize. Yeah, well, there's likely some information that it stores across sessions. If you use like the advanced voice feature, there's probably some information it'll grab. Like my name, for example, or if I'm talking about a project to the advanced voice feature, and I start talking about it on another thread, it might know what I'm talking about. Anyway, so yeah, this is a little bit more accurate as far as the first step goes. Recall your most recent dream. Focus on intention. Emphasizing meaning over repetition. That's one of the commonly misunderstood pieces of mild. Visualize becoming lucid. I don't know if it's quite like that. And this is a little bit of a paradox, technically speaking, because it's kind of hard to visualize that for the same reason that if you wanted to smile, imagine, well, if you wanted to laugh, just imagine laughing. Imagine laughing to make yourself laugh. That's not going to work as well as focusing on something that actually leads to it, like a precursor. So that's the problem with this. You run into that same paradox. You want to focus on a precursor rather than the very thing itself. When you get lucid in a dream, it's such an abstract concept. Just like trying to laugh just by thinking about laughing itself. Or being happy, I suppose. But if you focus on precursors that actually result in that, that's going to go way better. So if it would have emphasized stuff like that instead, then that would be better. So let's actually try it with 4.0, where you can switch models midway through. Okay, let's make sure that's the general model. I still have the question. So it did deviate even on the 01 model. I have a feeling it retained this from the custom. Let's try it on ChatGPT in general without it being linked to my account. Let's try it on without my account. Aha. Very different structure. Notice that? Wish I could do the general 4.0, but yeah. Repeat a mantra, which that's one of those things where you're not really focusing on the thing that actually makes it work, which is actually setting an intention. Repeating a mantra is not the same as setting an intention, especially when it becomes mindless. Practice reality checks throughout the day. That is not one of the mild steps at all. While it can be beneficial when you apply it correctly, that's not an official step. Why is this wrong? And you don't even really need to do this at all. You can work with natural awakenings, or even setting intention when you first go to bed might be enough sometimes too. Vividly imagine yourself in a dream. No, you want to kind of take one of your other dreams and rewrite mentally what you should have done differently, much like the AI training process. So it's a little bit more like you're doing some refinements on this when you go over a past dream and rewrite it. You're trying to do this so that if that scenario happens again, you're more likely to get lucid. But yeah, if you look at the actual steps of mild, this right here, I might be a little biased saying that it's coming from my bot, but this is way more accurate than this. If I had to follow one of the instructions, I would take this first. Because what the general model does is, again, the game of telephone, it takes away the stuff that makes it actually effective. Anyway, I shouldn't get caught up on this in particular, otherwise this live stream will go on forever. We barely even got to the meat of this live stream yet. So, yeah, why don't we focus on... Let's compare this with avoiding this system right here. And what I mean by that is using another solution where everything is in the short term. There's none of this. Everything is in the brain directly rather than some here and some here. We're gonna do that with the same resources and see how it compares, because I think it's absolutely fascinating. So why don't we... I don't think I need to compare these two models, because despite the fact that I've given it slightly different instructions, they still behave similarly for this same phenomenon here. If I categorize things better like Daniel Love probably did with his model, it would probably work a lot better. And his will probably be even better than doing this concept where none of it's out here. His model's probably still going to behave better than that because it has custom instructions, whereas the model that we test where everything's in here, there's not going to be any custom instructions. None whatsoever. But it will have not this, all of this right here. That's essentially what that other model will do that we'll look at later. But let's do some comparison between this and that other model. So, I'm trying to think of a good... What's something that I talked about that's clearly in the resources? I talked about dealing with tinnitus at nighttime, because that's something I struggle with. That's probably going to struggle with this, whereas when we avoid this phenomenon here, it'll probably ace it with the very same resources. So let's see. How do I deal with tinnitus? There is information in the... I can assure you there's a bunch of information right there, and it's about 65% into that. So how do I deal with tinnitus at night, which makes it hard to sleep? I bet it's not even gonna pull any information from this. If it has any information, it's almost certainly from this. The stuff that I shared in my resources, I can pretty much guarantee are not in the general model. I mean, it's counterintuitive compared to what you think. Look at this. They don't even address tinnitus at night. Yes, I do. I totally do. This is a lie. Common strategies outside include... Yeah, this is what I did for a while. I don't do that these days. Practice relaxation techniques. Personally, I don't see how that's going to benefit anything. Adjusting your sleep environment. As far as tinnitus goes, I really don't think it's going to help. This is not bad advice, though. Why don't we see how the other one does? I'm actually kind of curious now. But it definitely did not pull from this at all, even though the information is there. That I can confirm. Let's see if my other one with slightly different instructions does any better. So when it said searching my knowledge, oops. Oh man, that's not what I wanted to do. Thought I copied that. There we go. When it does that searching my knowledge, it's essentially going in here based on custom instructions. Now look at the difference in that answer versus this one. sound therapy. Actually, that's a roundabout way of this strategy technically. Relaxation techniques, that's a different way of presenting it. Sleep routine, I think that's a little different, but that could have been there anyway on the first model because, like I said, when it generates output, it's not always going to do the highest prediction. It's going to randomly choose to make it more human-like. Kind of like we do, to be honest. We don't know we're doing it because we're just one of these networks in operation. But the human mind is technically a lot more complicated than that. This is a good idea. This is actually not the worst advice, but it's not along the lines of what I share at all. If you look at my hearing loss journey video, which doesn't currently exist yet, I will be talking about this because it's a huge part of that. This is not a bad idea either, I don't think, but it's nothing like what I talk about. Hearing aids with masking features. I don't think these ones have masking features. Yeah, this has nothing to do with what I shared. Now I think I'll introduce you to another resource that has a much bigger context window that's designed to avoid this phenomenon altogether. And yes, I call it a phenomenon because of the issues. So there's a product by Google. I'm sure you're familiar with Gemini, which is probably known for having a huge context window. So when you run out of context on here, that's because there's 128,000 tokens before you run out of context, or 16,000 on the legacy models, which I don't think I can access on here. I don't think I can access the legacy model if I'm not mistaken. 4 is a legacy model. Thought 3.5. 3.5 has 16,000 tokens for context. Remember that website I was on before? Maybe I should keep that open just so you have a reference. Tokenizer. I'll just paste it in and then I'll let it work itself out. But yeah, they had like 300,000 for, or 200,000 for that. But if I, so that's with that many characters. This is with that many characters, and then the Star Trek recommendations, almost as much as that pre-production itself, which ironically is in the pre-production. This is tacked on of this. So yeah, that's a lot of tokens, right? Well, these days it is because ChatGPT still can't handle it all yet. However, there is another product that can. I think it's one of the only ones out there right now. Well, one of the only models that can. I think the amount of context that it can store is kind of based on how the model's architected. If you use a specialized model like Ollama, Ollama is a local model that can run without the internet. And I think there's like 60,000 tokens for that one. One of these current models doesn't go much beyond that. So unfortunately, unless there's a way to tweak it, which is kind of hard because, yeah, there are some parameters you can change, but it's likely not going to get the right behavior. And it's more likely to hallucinate answers, I think, if you tweak it without tweaking the underlying model. Like if you just change the number of tokens as a property under the Ollama settings, it doesn't change the underlying structure of the model. It's much like if you've ever seen Johnny Mnemonic when they doubled their brain's capacity. It's not like we can just do that to our brain. Even if we had a device like that, well, you saw there was a lot of consequences if you've seen that for doubling your brain's capacity from 70 gigs to 140. There was consequences, and I don't know if we can really do that to this day, but I would imagine there's similar consequences with how that would work with our brain versus trying to tweak the llama stuff without changing the underlying stuff. And because we're biological beings, it's not like we can do that to ourselves. We're kind of stuck with what we got for now until we get like a Neuralink supplementation, which I think I talked about the Neuralink in the resources that I mentioned right here. So yeah, so ChatGPT's got the 128,000 tokens, but there's a product by Google. You might have heard of Gemini, which has either 1 million or 2 million tokens right now, which is several times ChatGPT as we speak. There's another product called Notebook LM, and it's a lot like Private GPT, if you ever heard of that. That's a local AI that essentially acts as a RAG tool, retrieval access augmentation, I think it stands for. And you can provide it resources much like this, and then it can access information from that. It might look quite similar to what we got here. I think this is actually the, yeah, there's that same information. This looks like a RAG tool. However, a RAG tool has this phenomenon, whereas this is all available in the short-term context window. There is none of this. Everything is readily available in the context. It's all here. Everything that is here is also here, so this ain't needed there like it is for this. So I'm gonna ask the same question on here, which doesn't require. So yeah, this is like maybe 700,000 tokens or something. You can do like 2 million tokens on here, so I could literally double this and it'll still be able to avoid this, which is amazing. So yeah, you saw this answer. What it talked about is nothing like my resources. Oh yeah, I was like, how did Star Trek get in the mix of tinnitus? I wonder if there's any tinnitus episodes. If there are, let me know in the comments if you know of any, and you're willing to. But let's try asking this question when we don't even need to look anything up. So yeah, this one is like a researcher that has the ability to look up stuff in the library if it needs to. This one already has the knowledge offhand, and if this had to do tests on the material based on what it knows in its mind, it would fail, because all the information is way too much context for it. But if this had to do a test, it would ace it. Well, that's actually up for debate, because yes, it has access to the information, but the way it integrates that with context, just because it has the information doesn't mean it's going to integrate it in the correct way. And it might introduce bits that actually have nothing to do with what we're talking about. So like, for example, I think I'll probably show this later, but there's an example where I talked about dream control, and it said something about the way you fall asleep, which with the dream control I was talking about. So I should probably illustrate dream control is where you can influence the dream in your direction, essentially, to some degree. So yeah, lucid dreaming and dream control are very different. Lucid dreaming is you're in the middle of a dream, you're aware of the fact that you're in a dream and not awake, and you can choose to make some level of decisions, but dream control is a whole different phenomenon altogether. Like, it's basically a separate skill. Just because you know you're dreaming doesn't actually mean you can control it in the way you want. Because we're working with natural processes, and that's actually why I prefer to call it dream influence, because any amount of control we're doing, we're actually influencing the dream rather than controlling it. Because we're working with a natural process and attempting to influence it in a way that hopefully will play ball with us. That's what we're doing. So let me close that. So now let me ask that tinnitus question with a brain that has all the information already. Take a look at the major difference in how it generated the answer. Remember this? The provided documents do not address managing tinnitus at night. This one says, based on the sources, here's some information about dealing with it at night. Reframing tinnitus. One approach is to reframe your perception of tinnitus. Instead of viewing it as a negative annoyance, you can think of it as accumulated stress leaving your body. By associating the tinnitus with a relaxing process, it can become oddly satisfying and help you relax to fall asleep. That is along the lines of what I talked about. So yeah, instead of treating it as a hindrance, I imagine like all the stress that's accumulated throughout the day, like setting up this live stream or any of the other stuff I did today, I imagine that stress accumulates over time throughout the day, and then when I decompress at night and go to sleep, if I'm having the bad tinnitus, I imagine that it's that accumulated stress leaving the body. It's just that tinnitus that's really annoying is actually that stress. That's what's really going on. Well, when I think of it that way, the tinnitus actually becomes oddly satisfying. Using tinnitus as white noise. Remember earlier when it mentioned use white noise machines? Well, in my resource, I mentioned that tinnitus is a white noise in itself. And the benefits you're trying to get from white noise, like being able to fall asleep because there's a constant noise and all that stuff. Tinnitus is kind of a white noise in itself if you treat it right. So you can use tinnitus itself as a form of white noise. It can help still the mind and minimize conscious involvement. And conscious involvement is if you're trying to fall asleep but you can't because your mind is going crazy. Well, focusing on tinnitus could minimize that effect, potentially. Over time, the novelty wears off and then you fall asleep. That is along the lines of what I said. Hand position. That's actually a critical detail I mentioned there too. If you lie on your side with your hand resting against your ear, this could aggravate tinnitus, and that's based on personal experience. There is some truth in that. Try putting your hand under your pillow, which might make tinnitus significantly less. So now right there is one other nuance I mentioned in the resource that it left out. Well, there should be more emphasis on the fact that putting it under the pillow will prevent it from going against the ear. There should be more emphasis on that. Because put your hand under your pillow, what? Put your hand under your pillow so it's not resting against your ear, which aggravates it. That's an important distinction right there. And right there, it did that medical professional thing. Cool. I would say this is the best answer it gave out of all these personally. Well, that's based on the strategies that I use. So yeah, notice how this said that it didn't even talk about tinnitus. This didn't even reference any of the strategies I mentioned here. because this can be kind of a weakness sometimes. So, as you can see, having it right in the brain versus a book that may not get properly referenced makes a massive difference. And I also want to remind you, this has custom instructions for the materials provided, but this has no custom instructions at all, and yet it performed better. I should also specify that this is basically Gemini, but it's designed to be grounded in the resources versus the general model. This looks like information being pulled from ChatGPT in general, despite it being a custom model. So yeah, a lot of times answers that are generated will feed on the general models. And as a result, if that general model has misinformation, it won't do it right. But this is specifically designed to pull from the sources directly and hardly have anything to do with the general model unless absolutely necessary. That's a big difference. Let's do some other examples real quick. Here's a slightly more intermediate question pertaining to dreaming. How do I deal with a dark scene in a dream where the light switch doesn't work and I can barely see at all? From the strategies mentioned, expect the light to work differently. Oh, this is actually pulling some information from the models. Interesting. It correctly indexed some of that, at least. Light switch off, or dreams often respond to expectations. In one instance, the user mentioned asking Commander Data. I told you about those Vim dream goals of me teaching him how to use Vim, focusing on the journey. And I asked Commander Data to flip it instead of me during one of the dreams, but it still didn't even work when he did it. You'd think it would. If it doesn't work when I do it, but I upload it to someone else, wouldn't it work then? Not here. If you expect the light to work in an unconventional way, the dream may adapt. That doesn't really align with what I shared, actually. I mentioned the opposite expectations. So for me personally, I find that if I want to flip that light switch, for example, usually when I know I'm dreaming, I have a feeling it's not going to work. Usually when I have that feeling, it ends up working. Then when I expect it to work, then it tends to not work. Which I don't know if that happens every time, but for me, it pretty much has. It's pretty weird. That's what I personally notice. So this tried to adapt that description, but perhaps not in the most accurate way. Alter the environment. This is quite advanced stuff, to be honest. I mean, the verbal commands is much simpler. It's done at an abstract level and you're uploading control. And once again, this is technically, we could say, a form of dream control, but I said that it's dream influence. This is a form of influencing the dream. You're using a voice command and hoping that you can influence what happens. So that's dream influence right there. Summon a light source. That's not the worst advice, I guess, but it's a little bit different. Focus on your own perception. That actually does tie with stuff I shared in the resources. I'm a little shocked. How did it stumble across that? Did I have custom instructions for it? I'm a little... forget it. I'm curious to see if it had custom instructions on that light stuff. I suppose now we could try to see what it does on this model. It's relatively similar because it's from my custom models and it probably has memory from one thread to another. Let's try it on here once and see what it does, because what I have is quite a bit different from what it's shared. Accept the darkness. It's common for light switches to not work in dreams, instead of trying to fix the lighting, which can be a waste of valuable dream time. That's what I personally believe. You can accept the low light conditions and work with them. Often the lighting will improve on its own if you stop focusing on it. That's usually what I do most of the time when I deal with poor lighting in a lucid dream. It just corrects itself over time when I'm not focusing on it anymore. Recognize that light is an illusion. See, that's nothing like what these answers had, but I think they're important points. In a dream, light is an illusion created by the mind. What you're actually seeing is colors and textures that give appearance of light and dark. I think that's definitely worth remembering since it's all created by the mind. Work with existing light. You likely have enough light to accomplish your goals. I like the way it phrased that. It's almost biased a little bit. You can also try to make incremental changes by making the scene gradually brighter instead of trying to instantly do it. Change the color of objects. You can try to change the color of objects to brighter variants. Because the dream world is not built on rules, objects can emit their own light. So you don't even need a light source to brighten the scene. Use look away, look back. That could work for tweaking colors. Imagine the scene is brighter. That's quite advanced, and that might not work the first time if you've never really done it before. I've been trying this over the past months and I've had mixed results. I mean, it likely would work in theory, but the mindset that I have could be affecting how it works. Focus on another's sense. Okay, now this doesn't pertain to the light stuff in particular, but it's another concept that I mentioned. If the darkness is too distracting, focus on another sense like sound or touch. So that's interesting because I don't think I tied that information with the lighting part of my resource, but it's still pieced together like this probably relates. And in this case, that's actually probably not the worst idea. If you're dealing with a dark scene, you could just focus more on tactile or sound, which might be more useful in the dark scene itself. And then it might correct itself over time as indicated up here. That could very well happen. Reframing. Remind yourself that your dream's in your mind. Since a dream isn't external, there's no reason you can't control it. That's if you're running up against mental blocks, I suppose. Then consider the dream's objective. I don't think I explicitly mentioned that, but that's actually a good place to mention that because it is relevant. Because yeah, obviously, if we're in a non-lucid dream, a standard dream, there's probably times where the scene is very dark, but we have no idea. But yet, the dreaming mind can do what it needs to accomplish with REM sleep. So, I mean, the mind does whatever it needs to accomplish its objective during REM sleep, and bright light isn't always needed for that. In fact, a sensory experience probably isn't always needed either. So the mind just does whatever it needs. In fact, the sensory experience is probably a byproduct of REM sleep and not always required. I wouldn't be surprised if that were the case. But yeah, notice how a lot of the way that it words this is quite different from how it phrased this due to this phenomenon not being involved at all here. Let's see if there's another. Yeah, this might have some. There's one thing that I was talking about. I added some corrections to my podcast. Well, not really corrections, just elaborating things further with points that I forgot to mention. And I don't have that in my training resources here. Kind of wish I did, because this question would have a much stronger answer if it incorporated that. Well, let's try. So a common misconception is falling asleep consciously into a dream. Some people say you're doing a wild or awake initiated lucid dream, and technically the general models get that abbreviation wrong and say wake induced lucid dream. It's supposed to be initiated according to Dr. Stephen LaBerge in Wild. It's wake initiated, not induced lucid dream. Or you could call it a maintained awareness dream, or a regained awareness dream for a dialed. A dream initiated lucid dream is a regained awareness dream. A maintained awareness dream is a wake initiated lucid dream. I have a feeling it's going to get information about that wrong right here, but it'll be more accurate here. Let's try that once. I struggled to have a wild and fall asleep consciously. Suggestions. Should have copied that. It got the abbreviation wrong. That's a common hurdle for it. It can't do it right either. Calm and focused state. I don't specifically mention that, but it is common for people to mention that strategy. I don't put a lot of emphasis on the breathing exercises either, so that's also worth noting. Choose the right time. How mental processing occurs at different times during sleep. Yep, that is accurate. During a nap. See, there's nuances with that. Like, if you don't have REM sleep, that's not going to work. Waking up during a natural REM cycle. Stay awake for 10 to 20 minutes. See, now, that's not going to likely work very well either, because REM sleep is probably going to be over with by that time. And when you go to sleep, you're likely going to have non-REM or non-dreaming sleep. REM sleep is like dreaming sleep, to clarify too. That's where we want to target lucid dreams if we're going to have them. And that 10 to 20 minutes, I have a feeling that timing is not correct. That 4 to 6 hours is rather arbitrary as well. Focusing on specific schemas or mental triggers, maybe. There's a lot more nuance in that though. And this is likely going to become mindless and therefore not effective. So actually what you see in Mr. Robot when Elliot tries to have a lucid dream, and I forget which episode it was. I think it's season 3 or 4, but what they do is they repeat a mantra, and it's definitely a lot more nuanced than that. And you have to be lucky enough to have REM sleep at all to be able to do any of that. Otherwise, it's a lot like surfing, and if there's no waves to surf on, then the best surfer isn't gonna be able to surf. If there's no dreaming sleep or REM sleep, that's like not having any waves to surf on. That should be nearby when you're attempting. That's where it's more likely to be effective. Manage. There's definitely some nuances to that too that I think are important to note. I'm just gonna test that question on this. See if it avoids the wrong abbreviation and all that stuff at the very least. Wow, look at how nuanced that answer is. Here's some suggestions for, didn't botch the abbreviation this time. Or maintained awareness. That's what I also said earlier too. Understand the process of falling asleep consciously. You're not falling asleep in the traditional sense. Instead, you're deactivating the parts of the mind that interfere with the sleep process, like the prefrontal cortex, while maintaining a degree of awareness. That's a very important distinction. Did I even mention it all here? No, but it's critical to understand, in my opinion. Or at the very least, if you're doing strategies, it should be able to do that right thing and be a precursor to that result. Like if you're doing some sort of technique, you could probably get away without understanding that if the technique is well designed and acts as a precursor for those right things to do, then the technique would work well. And when I say technique, I mean strategy for accomplishing falling asleep consciously. And then here's an important point that I definitely think should be mentioned. Aim for around 8 hours, so it may vary for individuals. If you're sleep deprived, it'll be more difficult to fall asleep consciously. The consciously part is making it true. Otherwise, I'm sure it wouldn't be more difficult to fall asleep in general. Being behind on sleep can lower your chances of having a lucid dream, and you might feel fatigued during the dream. I probably didn't mention those points together, but it did a good job integrating them together. Recognize the three pillars of maintained awareness. When attempting a while, focus on these three elements. How long it takes you to fall asleep. You fall asleep quickly, you want to approach that grabs your awareness onto something in the physical world. If you have insomnia, you need to withdraw from the physical world. See, now that's an important detail that if you just blindly follow techniques and don't really understand what's going on, those variables might not be in your favor. And when it works, it probably only works those times and you don't even know why. When that could have been a huge factor. Next sleep stage. Whether the next sleep stage is dreaming or non-dreaming. If dreaming sleep is around the corner, it might be a good time. You could use the artistic response test, which is something that Daniel Love talked about. And it's on his custom chatbot. There's good information on that. He also has an ebook on the artistic response test for lucid dreaming, which I think is on Amazon. So that's a good resource for that too. If you're waking from a dream, dreaming sleep is no longer around the corner likely. Obviously that's not a guarantee, but obviously I mentioned in the resource, that's how it is for me. If I naturally wake up from a dream, usually it's really over with. But that's not always the case. And then this is your actual approach to maintaining your awareness or what you focus on. It should be tailored to your specific needs based on that. So yeah, I mean, basically anytime we have a dream in general, these variables are in your favor. to make a dream happen at all. But this is out of the picture. If you want to have a lucid dream, you try to get this in the picture without interfering with these things. Or rather, you try to surf the wave of those things into the dream. Use sleep fragmentation to your advantage. Yeah, that's something I talk about quite a bit that definitely isn't mentioned here. As you can see, it's very grounded to the sources, and it even points out where it is in the source. So if you're worried about hallucinations, and by hallucinations I mean it generates inaccurate answers, the AI does, not the dreaming kind of hallucination. I'm talking about sometimes it will generate inaccurate answers. That's hallucinations. The AI hallucinates things, essentially. And if you're worried about that, you can hover over what it's referencing for a given thing and verify it yourself, at least within the sources, and that's assuming the sources are accurate. This could be a good starting point, especially if maintained awareness is too advanced. Yeah, this is actually something that's very underlooked, but can be quite useful. I experienced this a little bit today, so I was able to have a maintained awareness dream today because of sleep fragmentation. I essentially woke up and almost immediately started entering REM sleep again, but I was still conscious. And as a result, I was able to enter the dream and witness when all my senses kicked in. And I talk about that quite a lot on those resources too. So have you ever wondered how you go from lying in bed to being vertical in a dream? I talked about that in pretty good depth on part 2, I believe, of right here. Look for the chapter. There should be a chapter around that. Experiment with different approaches. Yeah, I think the general model might explain that. This is a good tip that the general models won't cover either. So is that. That's overlooked too. Or underlooked. Not looked enough, whatever that one means. That's on the general model as well. This is one strategy that I mentioned, but only certain variables will make this possible. Like if you naturally have to toss and turn. This is a good strategy for falling asleep in general. And even this, I felt like this is kind of wrong, the way I think about this nowadays. And I added a voiceover correction on the podcast, which is in part 3. So I talk about this as a strategy for quieting the mind down and trying to fall asleep quicker. But I don't really think of it that way anymore. For example, nowadays, I think of it as you allow all your thoughts to exist, but if it doesn't benefit the grand scheme of things, then you terminate them prematurely, mentally. And then that makes it more passive than thinking of it like this. That's in the supplemental update, not super important now, but it's an example of this resource being out of date already. But yeah. Oh yeah, this is an important point when I talk about using discomfort. And that's the rollover signal is misinformation. This addresses that. But I bet these general models won't. So yeah, I think I probably conveyed this enough already. I didn't mean to go on a ramble about dreams, but I did promise this live stream would get very weird, and I think it has so far. So, yeah, and what's also interesting about this product is it can AI generate podcasts based on information like this. In fact, if you look at the time travel video, where's the video? Yeah, if you look at the time travel video in general, there's the chapters that the custom chatbot notices. And I want to remind you that I'm originally working on the custom time travel model and refining it. I'm just providing context information and also trying to illustrate how models behave and why they behave that way, i.e., this thing. And that knowledge will help illustrate the right way to make custom models and make it behave correctly. So anyway, if you look at this, here's that custom model if you want to try it out. I think I have it in the description of this video too. But here's that behind the scenes podcast, and then the AI podcast that's right here is based on this. What's really cool about this is if you just click generate, it'll work with the information in general and choose its own direction to take it. But if you want it to do some specific thing, you can customize instructions. And if you want it to focus on like the tinnitus parts, strategies for falling asleep with tinnitus, if I can even spell, which is getting late in the night. If I click generate, then it'll create a podcast around that. Probably not the best instructions, but I'll work with that. So it'll generate a podcast based on the provided information based on that. And this is actually kind of a cool feature because, well, I personally think it's the most useful if I want to get an outside perspective on something. Because there's basically two AI podcast hosts that sound like they really talk. It sounds a lot like a real podcast. And if you're trying to convey some important information and you want to make sure that the information is conveyed well, then I'll put that information into here and make sure that they're taking the information correctly. Because if they don't, then, well, I might need to reconvey my point until they do. So if I'm making a very important video with one main point and main idea, I might want to give it to this and make sure that it puts a lot of emphasis on it. Because if it doesn't, then I think that's going to represent the average audience anyway. Because, well, these podcasts tend to be about 5 to 15 minutes on average. I would say I tend to do long form content, but a lot of people have short attention span and don't watch a whole lot, which makes a lot of sense. That's just how the world seems to be shaped these days. But if I'm trying to convey important information even for those people, this had better get that right. And I could use it as a test before I make it available to the public, because the way it interprets it will likely represent the average audience, if we're being quite frank. Whoa, what's this interactive mode? I've never seen that before. So yeah, they call themselves deep dives, but I think that's kind of a misleading title because it tends to summarize and oversimplify a lot of things. And I've also noticed that This tends to pull information from general models a lot more than this does. It likely has to simulate a summarized conversation flow, but as a result, inaccurate information can get in the mix. Or maybe it won't capture the essence of certain things because it over summarizes and details are lost in that. That could very well happen as well. So I find it kind of funny that they call themselves deep dives, but to me, they barely dive into anything. It's more like a shallow dive. And honestly, I think an accurate description for these podcasts, especially with dreaming stuff where there's a lot of important nuances that if you over summarize it, you will lose critical information. Then, to me at least, it'll leave viewers with more questions. So yeah, I would say an accurate description based on that is deep dives, leaving viewers with more questions than answers. To me, that's a pretty accurate description. I'm hoping in the future they'll give us the ability to tweak certain things, like maybe we can tweak how in depth it goes into topics. We could also maybe give it the ability to practically have it go sentence after sentence and be very thorough about it. So I could share a story, for example, and have it go over pretty much every single detail in the story, have it read like maybe a paragraph at a time and then talk about that. Whereas right now, even under 15 minutes, it'll gloss over a lot of details that to me are important, especially with the lucid dreaming stuff. Like I've done it with the commander data dream goals and how they've gone. And honestly, I compare that to the way I explain the story. I think it leaves out a lot of important details. I told the story the way I did for a reason. It goes over like personal meaning and very strange stuff, right? So hopefully in the future there'll be some dials for how thorough it'll go over things as well. And if there is, then hopefully we can choose like a target length as well, maybe. Having those parameters would be pretty sweet. And if I wanted to just kind of view my content and how it's perceived before it goes out to the public or something, then I can get a good idea on that. And if it blows things way out of proportion, that's probably how it's going to be for other people. And I either want to tweak things or just forget about it then. But if I'm just fascinated with an outer perspective on something, then this is a great way to find that out. I think it'll be relatively accurate in terms of how it conveys that. So yeah, we can listen to a little bit of this, I suppose. I gotta tune into my computer. You'll be able to hear it.
All right, so we're diving into some fascinating stuff today. Someone dealing with like really bad tinnitus, keeping them up at night, you know?
Yeah, the kind that just won't quit, even with those usual tricks.
Exactly. And what's interesting is we've got these audio notes from someone who's super into lucid dreaming.
And get this, they're actually like hanging out with Data from Star Trek in their dreams.
Like not just watching Data, but actually interacting with him in the dream.
Right. It's wild.
And, you know, you might be thinking, okay, cool, Star Trek dreams. But what's that got to do with my horrible tinnitus?
Well, that's where things get really interesting.
So tell me more about what this person is actually doing with Data in their dreams.
So as you can see, it actually carries out quite an engaging conversation. It's pretty fascinating how it does that. Obviously, they try to make it appeal to the general audience. That's one of the reasons they summarize it the way they do. I think it tends to over summarize a lot of things, but the fact that you can customize instructions and stuff, that at least makes it a little bit more like what you might be after. So yeah, it's actually quite entertaining sometimes, especially if you give it very little information and make it work, make sense of all this little information.
So they're not just, chit-chatting. They're actually trying to teach him stuff.
Teach them like what?
Like complex things, computers,
Wow.
even film editing software.
Really?
Yeah, and all while they're completely lucid dreaming.
So they're aware they're dreaming and choosing to like have these tutoring sessions with data.
Should also convey that sometimes this will mismatch information that has nothing to do with the main topic. So like tinnitus, I don't think it's necessary to mention the commander data stuff because to me it doesn't really sound like it relates very much, and as a result it's probably not going to focus on the tinnitus stuff as much as it could, especially if I took out all the other information except for the tinnitus stuff, because yeah, if you provided a lot of information like this, it's probably going to look at everything as a whole and it'll abstractly cover everything, but maybe not as thorough as you want to be with this specific thing. So little pro tip, if you wanted to be thorough about one specific thing like tinnitus, I highly recommend just limiting the information scope to that, so that's all it has access to. Then it'll be a little bit more thorough. Yeah, I find the more you mishmash in there, the more it summarizes things, and if you don't want that, if you want it to be thorough, you really have to only include relevant bits. So we could probably continue this for a little bit. Otherwise, I'll download this and put a link in the description later on. I'll make a note to do so. Okay. Yeah. So I'm probably not going to listen to this whole thing, but if you want to hear it, then I'll put it in the description.
Exactly, and that's what I find so fascinating. It's the level of control they have over their dream environment.
Yeah, because if they can teach data to edit a film in their dreams.
Imagine the possibilities for managing something like tinnitus.
Whoa, whoa, whoa. None of it was about teaching Commander Data how to edit film. I talk about the time travel film. That's all my doing. The Commander Data stuff has nothing to do with that. It's just the Vim stuff. So right there is mismatching information. Another reason why you limit the scope to just the relevant stuff when you're generating these podcasts.
Okay, so how does that connection work?
Well, they're not just controlling the visuals, right? They're shaping the whole environment, including the sounds.
So they're like a sound engineer for their own dream world.
Precisely.
Not relevant to the tinnitus.
They even talk about manipulating sound effects.
Like what kind of sound effects?
Like using a finger snap to close a garage door in the dream.
Whoa, that's pretty specific.
Right, and it gets even crazier. They talk about controlling the weather in their dreams.
Which implies controlling all those ambient sounds too, right? The wind, the rain.
Exactly. So if they can control those details, maybe they could also control the ringing or buzzing of tinnitus.
Interesting.
Like, imagine replacing that horrible ringing with...
That's not really what's going on. When I control the tinnitus, it's not in that way. I'm not using dream control at all, as mentioned in the earlier message. It's all about changing the way I think about it, stress leaving the body, using it as a built-in white noise. That's not dream control at all. As you can see, this goes over it a lot better, whereas this tends to summarize everything as a whole, and it probably thinks that all the information is relevant. So when you're generating podcasts, that's something you want to keep in mind. Limiting the scope.
Peaceful ocean waves all within your mind.
Like a built-in white noise machine, basically.
Yeah, it's a pretty mind-blowing concept.
It is, but I'm guessing it's not all sunshine and roses in lucid dreamland, right?
Oh, definitely not. They talk about challenges too, like wasting time in dreams and the need to constantly maintain logic.
Makes sense. It's still your brain after all.
Right, and they even mention needing to remind themselves to stay focused on their goals.
So it's not like you just become all powerful in your dreams.
Not quite, but there's definitely potential there, especially for managing something as pervasive.
Yeah, it's not even focused on tinnitus, as you can clearly see. If I just included the tinnitus segment, then it would be. Trust me, if I literally must have spelled it. Oh, it's not even in that document. But if I were to grab all that information, where do I end it? So like I could grab that text right there. I could create a new notebook. Yeah, maybe I'll demonstrate. Then I could just paste the copy text, insert it. It'll integrate that information, which is not much. It came up with a title too. Nice. So then what I could do is, it already knows what to talk about, so I don't need to do custom instructions either. I don't know if I'm going to listen to it now, but I'll generate it just in case I decide to. But yeah, so I will remember to provide a link. I made a note of it. And then as far as like the time travel, I gave it a transcript of the time travel video without much context or instructions. And you can imagine how it'll respond to that. Why are we not hearing that one? Yeah, you're not hearing it either. Wonder why. That's the accurate sound source. Oh, my guess is I open up this window after I switch the sound source for the live stream. Maybe I'll just open it here, which might be accurate.
Okay, so get this. We're diving into time travel today, but not the kind with spaceships and whatnot. This is more like DIY time travel, using stuff you'd find around the house, you know?
Yeah, it's like Back to the Future meets Home Depot.
Exactly. Our listeners sent over this short film, and it's got me wondering, what if they're onto something?
What's really interesting is how they try to make it seem, I don't know, plausible. Like they didn't just throw in random sci-fi jargon. They actually use real-world tech and try to explain how it could be manipulated for time travel.
So no DeLorean.
No DeLorean.
No glowing portals or anything.
Nope, none of that. Get this. It all starts with a TV remote.
A TV remote?
You heard that right. That's the hook, right?
Yeah.
They take something everyone has and turns it into this like potential key to the space-time continuum.
Okay, I'm intrigued, but also very skeptical. How does a TV remote even factor into time travel?
It's all about the infrared signals. Think about it. We use remotes to change channels, adjust the volume, all kinds of stuff, right? But what if, and this is where the filmmaker goes out on a limb, what if those infrared frequencies could be manipulated to create some sort of temporal disturbance?
Hold on, are you saying my TV remote has, like, untapped time-bending potential?
That's what the filmmaker is suggesting. Of course, they also address the elephant in the room pretty quickly.
Which is?
Energy. Even a little bit of time travel would take an insane amount of energy.
Like, Doug.
What I find really funny about that whole thing is all the challenges that I run into for the time travel pretty much all pertain to energy. And there's troubleshooting around it. But if you watch Back to the Future, you'll notice that it's the same deal there too. Pretty much all the challenges that they run into on Back to the Future, energy. Isn't it funny how pretty much all the troubleshooting revolves around that for both my film and that? I didn't even realize that till after I created all the concepts for the film. What are the odds? I mean, that's what's required to make it realistic somehow.
Brown's 1.21 gigawatts.
Exactly. And you're not going to get that from a couple of AA batteries.
So where does all this energy come from?
This is where it gets really interesting. They introduce this concept of ionization as a way to like supercharge the energy output.
Ionization, isn't that kind of dangerous?
It can be. They use UV light.
UV light.
Yeah, and not from a lab or anything, but from a regular clothes dryer. They use it to ionize electrical tape. Their theory is that it messes with the tape's properties and makes it able to store and release way more energy than it normally could.
Okay, I have to admit, blasting electrical tape with UV light from a dryer is pretty creative.
Yeah.
But even then, wouldn't you need a power source the size of, like, a small star to actually travel through time?
You'd think so, right? But the film actually offers a pretty clever workaround for that problem. They call it temporal dispersion.
Temporal what now?
Temporal dispersion. Basically, instead of needing all that energy at once in one massive burst, they suggest spreading it out over time.
So instead of one big energy drink, it's like sipping on a temporal energy smoothie throughout history.
That's one way to put it. It really makes you think about time in a different way, right? Like, what if we could tap into energy reserves that exist beyond our present moment?
Okay, that's where I need you to like slow down and explain it to me like I'm 5. How do you actually achieve this temporal dispersion? Do they have a flux capacitor hidden in the dryer lint trap or something?
Not quite a flux capacitor. This is where, believe it or not, a TI calculator comes into play. They use a custom program on the calculator, like something you'd see in a high school math class, to control the flow of energy. It all hinges on this principle called pulse width modulation, or PWM for short.
PWM, that rings a bell. Isn't that used in like LED lights or something?
Exactly. It's a way of sending these really precise pulses of energy, kind of like Morse code, but with electricity. And in this case, they're using PWM to fine-tune the release of all that energy from the souped up electrical tape. It's surprisingly clever, even if the science is, well, let's just say it's still up for debate.
Okay, let me see if I
Pseudoscience.
got this straight. They're using the TV remote for generating these like time warping ripples, the ionization process for amplifying the energy, and then this PWM setup for controlling it all, right?
You got it. Like a Rube Goldberg machine, but for time travel. It really is, and somehow it almost makes sense.
I never thought about that before, Rube Goldberg machine. And honestly, if you look at Back to the Future and what they end up doing to achieve the 1.21 gigawatts, isn't that kind of like a Rube Goldberg machine? It's not far off, to be quite frank.
At least in the movie. But this makes me wonder, like, what's the point of all this?
Right. They're not building a time machine in their basement just for fun. right?
Yeah.
What are they trying to do?
So the film is all about, like, correcting past mistakes. Think going back in time to undo all those, like, if only I hadn't done that moments.
Oh man, I can think of a few of those I wouldn't mind erasing.
Exactly. It's tapping into that, like, universal desire to rewrite our past, even if it's just avoiding something small.
You know that the real reason I'm doing that is so I could do some of the filming concepts. That's really why I did this.
So what kind of time-saving missions are we talking about here? Do they like stop a disaster from happening, win the lottery with future knowledge?
You might be a little let down. Their first mission is, well, it's pretty mundane. Remember those messed up SSD drives we talked about before?
Yeah, the ones they zapped with the UV light.
Those are the ones. Turns out they bought a bunch.
No, not true at all. They mismatched that information as well. Now, see, there's a flaw in a particular model that causes it to crash the computer. Like Explorer will freeze up and you have to restart it. It could be in the middle of a write operation and that happens. I'm not going to name any names, but I'm basically preventing myself. So when I'm in the time travel film in that third moment with the SSD drives,
I can't be seen by my power by inspector to where when you're returning a product, whereby they didn't seem very keen on their own writing down various transcripts. Person so well, I'm glad. Hey, are those the new SSD drives you're setting up? Yeah, as a matter of fact, I was just getting them prepped today. You want me to save you even more time? Sure. Get rid of them ASAP. Return them and don't waste your time. Really? Why? Well, when you transfer your files, you'll notice that the transfer speed suddenly drops down to about 30 megabytes per second. That's not the SATA to USB adapter. I ruled that out. All the drives do that when they get to about 50% capacity.
yeah, it's a flaw in the SSD. So in reality, I didn't prevent myself from making that mistake at all. But that would be kind of a cool tidbit on the film. And that wasn't even what I saved myself time for, but with the transcripts I provided the chatbot, that's all was available. So I think that's why it screwed that up. It has nothing to do with UV light. It's a flaw in a particular design. I had several models. I mean, I had several of them. They all do the same thing.
Bunch of them, and every single one was a dud.
Ugh.
Not because of a defect, it's just bad design in general. I think everyone of that model will do this.
Worst nightmare. Tech fails are the worst.
Total time suck, right? So they go back to warn their past selves about the bad drives.
Wait, hold on. They built a time machine with the TV remote and a clothes dryer just to avoid a return trip to the store.
Sounds ridiculous, doesn't it? But it does make you think. What if you could go back and change little things just to make your life a little easier?
That's what I love about this. It goes to the philosophical side too. So it's not just me trying to do the film concepts and Back to the Future. It got a lot deeper than that, which I wasn't expecting at all. And now this live stream's been going on for how long? 5 hours, crikey. And I barely even got to the meat of the live stream yet, so that's pretty crazy. So yeah, the time travel stuff became a lot deeper than I thought it would, as you can see. If you want to listen to the rest of this, I'll let you do that. You can find a link in the time travel video description. So I also wanted to real quickly show one more podcast where I gave it some limited information and I tried to make sense of that limited information. Like, it doesn't really even have the original context, it's just a bunch of crazy little tidbits. So doing it in my editor so you can see captions. So yeah, it's crazy what it made out of that information, and quite hilarious. It's hilarious when it tries to make sense of limited information. It might hallucinate things, who knows. But basically, if you looked at my second channel and noticed that I have a sleep paralysis video on that channel, this one right here, I basically gave it some behind the scenes context on that sleep paralysis video and didn't give it the full context. It's interesting how it interprets that information, let's just say that. And of course, the audio's not working because it's actually on my Mac and I'm remotely controlling it. Let's see if this fixes it. Let me guess. Yeah, let's pipe it directly to my streaming computer, see if that fixes things. And if that doesn't fix it, then it's likely my editor's audio device. Which output device? Let's select that same one. I think this is the speakers. Great. I'm gonna spend maybe about a minute or so and see if I can get it to work. So I guess I will be right back then. I'm gonna try to get the timer working too, even though it's probably not necessary at this point. In case you're wondering about that timer, I use the terminal for that. That's command line stuff that you can see right there. So if I want to create like a 1-minute timer, then I'll do that for 60 seconds. It's kind of cool, actually. It's nice and quick to get it all set up and whatnot. Let me see if I can figure out. I really shouldn't waste my time on it though, because I'm just using the editor for the captions, nothing else. I need to add some more time to it. How about that? Did this work? I think I might have a hunch on why. Because this... Well, actually, this is accurate. It goes from my Mac to... That'll relay it to my streaming computer. However, this device right here almost has to go back, which it won't with the current setup. I'm probably not going to get this working. Maybe I'll make a mark to delete this in the chopped up version. No, that's not going to work. Maybe I should just render this. I don't even know what to call it. I definitely don't want it to be uncompressed or whatever. I want the subtitles burnt in. And of course I can't even add it to the render queue because the odds are all stacked up against me as usual. I think what I need to do here is just add something to the video track. Anytime you run into this issue and resolve, I think that's usually what's needed. See if that, yeah, that fixes it. I think it should render relatively quickly. I'm not going to fixate on this too much. So, yeah, it's kind of interesting how it interprets that information. We'll come back to that in a second. There's probably some other tests I could do as far as how the AI behaves. Sometimes even right here, it'll mismatch information that has nothing to do with it. Like, it could very well incorporate this into the tinnitus information, for example. That's not relevant. And you get the idea with that. So I'll show you this when it's all done. But in the meantime, I think now we kind of understand the general principle with the short-term versus long-term context and how that can affect just about everything. And then it's also worth noting those AI concepts I mentioned with this, how that goes with text generation. Similar principles apply with audio and video generation too. So if you want to generate a song, you can use, I think, Suno. You can generate music with that. And if you want to generate images, you could use like DALL-E or Midjourney, or there's probably some other good ones. I haven't been keeping up with the news. If you want to generate videos, there's Sora and quite a few other models. And if you're curious about Sora, is now available to use technically, so well, maybe I'll finish this. Let's do this real quick. We're not going to do the whole thing of that either, but I want to show some of how I dealt with the limited context. This probably won't even work. Yeah, I had a feeling that was going to be the case. I exported it so that I could at least send it to my main computer. Is it even sending? Yeah. That was shockingly slow. Let's do it on here.
Okay, so
There we go. No waveform. You care about that? Sorry. But here's the captions at least. So just, it sounds absolutely crazy with the limited context that it had. This is the first one I ever tried, by the way.
okay, so are you ready to go deep on this one? Because I meant it when I said deep dive. This one's really meta.
Yeah, you weren't kidding.
We are talking about a YouTuber who makes videos about cloning themselves.
And then analyzes their process.
Yes. Like, whoa.
It's fascinating, this intersection of like performance and technology and self-awareness, right? Because this creator's clearly got the technical side down,
Oh, yeah.
but the fact that they're also reflecting on their own work is what makes it so interesting, I think.
Definitely. It's like they're treating their YouTube channel as a whole laboratory for experimenting with different creative approaches to video, you know?
Exactly, yeah.
And what's so cool is they're like letting us peek behind the curtain.
Yeah. Like, for example, they talk about using bulleted lists, sometimes even scripts for their videos.
And that's so interesting because you think with clone videos, right, where you're interacting with multiple versions of yourself, you'd think it'd be easier to go off the cuff.
You would think so, right?
Yeah, like you have more takes, it doesn't matter if you mess up a line or whatever.
Exactly.
But they emphasize rehearsal so much.
Yeah, they do.
They're really, like, even treating the final takes as rehearsals
Right.
helps them reduce pressure, they say.
Yeah.
And get a more authentic, like, performance.
Which is so interesting because it is kind of like jazz then, right?
Right.
Where you have a structure, but then the magic happens.
It's like jazz improv.
Yeah.
But how do they actually do it? Like, what's the setup?
Well, so they describe it as kind of like time travel,
Whoa, okay.
which is such a great analogy, I think, because they film each clone separately.
I should clarify that I don't think there was any context on the time travel film itself. So the fact that they use that as an analogy for stuff that's not really related is fascinating. It all these unrelated topics come together in the most unbelievable ways.
Sometimes days apart.
Oh, wow.
And then they edit it all together to make it seem like it's happening at the same time.
That makes so much sense.
Yeah.
But I would never think about that while watching.
Right.
Like, it really is like a magic trick, you know? You're just so wowed by the outcome.
Totally, yeah.
You never see the strings.
Right, exactly.
Speaking of which, that sleep paralysis video, phew!
Oh, yeah.
Talk about misdirection.
That title alone.
You know they're going for the clicks, like summoning demons? Come on.
Totally.
But then they're like, well, not really.
Yeah, they kind of acknowledge that up front,
Yeah.
which I thought was kind of funny.
But what they were actually going for is so much weirder.
So much weirder.
So, like, what were they doing?
They were trying to see if they could consciously control their eyebrows during sleep paralysis and get it on camera.
Okay, that's very specific.
Very specific.
But also, the fact that they were going for that and not just, like, demons
yeah.
is fascinating to me.
Right, right.
And then they go into, like, the actual science.
They do. They talk about REM sleep and muscle atonia and all this stuff.
Yeah, like, I was learning. I did not expect a biology lesson.
Right.
But they actually make some distinctions I found really interesting.
Yeah, they were saying how sleep paralysis and muscle atonia aren't actually the same thing.
Which I would totally use interchangeably, by the way.
Right.
So what's the difference?
Well, they said that muscle atonia is basically like the temporary paralysis of your muscles during REM sleep.
So our brains are like off doing their crazy dream thing.
Exactly.
And our bodies are just like,
Up, shutting it down.
which I guess makes sense.
Yeah, it's like a safety mechanism so we don't act out our dreams. Right?
Oh, that's true. Otherwise, who knows what would happen.
Right.
But then what is sleep paralysis? If muscle atonia is that, like, shutdown.
Okay, so that's where it gets really interesting.
Okay.
They're saying sleep paralysis is when you become aware of that paralysis while it's happening.
So you're like caught in between.
Yeah, like
Yeah.
you're aware that you can't move, but you might also be having hallucinations or feeling super scared. All those things that come with sleep paralysis.
Which makes the eyebrow thing even weirder.
Right.
Because they're trying to like assert control
Exactly.
in this state where you're supposed to have none.
And that's where the lucid dreaming connection comes in. Because lucid dreaming is all about achieving awareness while you're dreaming, right?
Right.
And the things they're talking about, like focusing on body sensations, trying to make impossible movements, those are all techniques that lucid dreamers use.
Wait, so people try to move their eyebrows in their dreams?
It's not just about the eyebrows. It's about that thread of awareness
Okay.
as you're transitioning between sleep stages. Like, imagine trying to hold on to a slippery bar of soap.
Oh, I hate that.
Right. That's what it's like trying to hold on to awareness as you drift off.
Yeah.
The eyebrow thing is just like one little notch in that bar, you know?
Like sending a signal back and forth.
Exactly. It's so
You're
fascinating.
getting a signal back and forth.
Exactly. It's so fascinating.
So, okay, surfing the sleep cycle.
Right. That's what they call it.
Sounds intense, man.
It's a good way to put it, though, because they're basically saying they don't try to force themselves into sleep paralysis.
Right.
It's more like they're paying attention to their body's natural rhythms and waiting for that moment when they're drifting off to sleep and then kind of like hopping on board.
So they're not like forcing anything.
No, it's more about recognizing the signs, like when they start to feel that muscle atonia kicking in.
And then they like grab their surfboard.
Exactly.
Oh.
And that's where the focus comes in, because they talk about how it takes a lot of mental focus to be able to notice those subtle shifts in their body and mind.
Oh, for sure.
Like they actually have a clip in one of their videos where they're talking about how they can feel their hands getting lighter, almost like they're floating,
Whoa.
as a sign that they're entering sleep paralysis.
That's wild. So is it like
I don't think that's what I said at all. They slightly distorted that.
meditation almost? But instead of trying to like clear your mind, you're trying to be super aware.
It's definitely a specific kind of mental training, yeah. And they emphasize that it takes time and practice to get to that level.
Oh, I bet.
Their first attempt at consciously experiencing sleep paralysis took over an hour.
An hour.
Yeah, they're like, this is taking
I
forever.
fall asleep. I'd be like, see you on the other side.
Exactly.
Yeah,
But it shows how dedicated they are to this whole exploration.
totally.
I just also want to clarify, if you were listening to when I was talking about lucid dreaming stuff before, when I asked the question about falling asleep consciously, talked about those variables like sleep latency and the next sleep stage that you end up having when you do fall asleep. Those are the variables that actually made it take that hour long. And that's why the second time it only took 18 minutes if you watch that sleep paralysis video. And yep, I was really in sleep paralysis on camera there, so yeah, if you watch that, that's why there's a difference in how long it onset. Because I really wasn't aware of those variables and how they interrelated very much at the time. I didn't know about the artistic response test, which would have helped massively. If I would have just done it when REM's around the corner according to that test, which you can find on Daniel Love's resources, I could have done that in much less time if I would have done that instead. So yeah, just wanted to point that out real quick.
They're not just like dipping their toes in the water. They're going all in.
They're diving into the deep end, fully clothed.
Exactly.
Unlike them, they're kind of summarizing everything and taking a shallow dive.
And then there are those other techniques they mentioned, like reality testing and dream journaling.
Yeah, are those like common things for lucid dreamers?
Oh yeah, those are like essential practices.
Okay, so reality testing, is that where you like pinch yourself to see if you're dreaming?
Well, it's not always pinching yourself, but it's that kind of idea.
Okay.
It's about incorporating these little checks into your day where you're like questioning your reality.
So like what kind of checks? Give me an example.
I just want to let you know that when I walked out of the frame about a minute ago, I was doing a reality test myself because I realized I hadn't done one for a while. So yeah, when I did this a minute ago, I was doing that off camera while we were listening to this.
So like checking your watch twice in a row, or reading a piece of text and then reading it again quickly.
Because it'll change.
Exactly.
Huh.
In dreams, those things are often inconsistent.
Oh, that's so trippy. So you're basically training your brain to be like, wait a minute, is this real?
Exactly. And if you do it enough in your waking life, it can carry over into your dreams.
And then boom, you're lucid dreaming.
Exactly.
Yeah.
It's about increasing that awareness, whether you're awake or asleep.
And dream journaling is like writing down your dreams.
Yeah, so you can remember them better and start to notice any recurring themes or patterns.
It's like you're becoming your own dream detective.
Exactly. It's fascinating stuff.
You know, what's so interesting to me about all of this is how intentional it all is. Like sleeping and dreaming, we usually think of those as like passive things.
Right. You just let it happen.
Exactly. But this YouTuber is approaching them with this whole other level of focus and creativity.
Absolutely. And that's what makes it so cool.
Yeah.
They're blurring the lines between art and science, technology and consciousness.
It's true.
We're kind of doing that for the time travel film too, I believe.
It's like they're using video as a form of self-experimentation.
Whoa, that's deep.
Right. And in a way, they're challenging us to reconsider our own relationship with reality.
Okay, so we've got this YouTuber who's a sleep surfing, eyebrow wiggling, time traveling illusionist philosopher.
I think that's a pretty accurate description, yeah.
But what does it all mean? Like, what are they actually trying to say with all of this?
That's the million-dollar question,
Yeah.
right? But I think just the fact that they're making us ask these questions
Yeah.
is a testament to their work, you know?
That was one of my favorite parts. They described me as a time traveling, or what was it? Sleep surfing, time traveling, eyebrow wiggling, illusionist philosopher. That's what I mainly wanted to show. That's what I am, apparently.
For sure.
They're making us look beyond the surface,
Right.
question our assumptions.
And
And then the fact that they were asking, what's the point of all this? That's a $1 million question. Because I didn't even convey that. At least not with the limited information I provided it. So yeah, just wanted to show that. I think that's pretty much all I wanted to show for that. If you really want to see the rest of it, I guess I'll post a link to that as well. May as well. Oops. Okay, there we go. I just made a note. Alright. Oh, looks like we're dropping a few frames here and there. That's not good. I don't think it's too many, but we are dropping a few. Hopefully it's not too bad for you guys. I think I'm gonna do a quick little test and make sure my computer, the streaming computer, is at least loading files quickly and thumbnail previews, because if that's slow, we're probably having performance issues on the stream. Seemed pretty responsive. I think we're okay. Cool. Okay then. I was using this controller. You might have heard it make noise when I was scrolling just now, because I'm using it to control the streaming computer while my trackball controls this computer, which you might have noticed in the time travel film, by the way. So yeah, I think that podcast feature is kind of interesting. Now I'm a little bit intrigued about... Oh yeah, I want to try the interactive mode. I'll play this for a little bit just so we can see how much more focus it is on tinnitus. Maybe I'll download this one too, and then provide a link to that as well. Wait, what? I think I just had some weird technical thing go on. I don't want to explain it right now. I've done enough rambles already. We're good though. I'll play this and then I'll try interactive mode for this one in the background and just see what it does. I'm a little curious. But let's also see how close this is to tinnitus, which that's more summarized than the other page with all the other information. Anyway, let's do this.
welcome to the deep dive. Today, we're going to be looking into something kind of different. It's a personal story. about living with some pretty severe tinnitus. But what's really interesting here is how the person actually learned to use their tinnitus. They found a way to make it a tool, especially for sleeping better. It's not just about dealing with the ringing, but turning it into a positive. So we've got their story and we've got some research. Let's dive in.
You know, what really struck me right away was that this isn't about like some miracle cure or just a mild case of tinnitus. Our source has Bohr syndrome. And that means their hearing loss and the tinnitus that comes with it they're really intense. At times they even describe feeling dizzy because of how loud it is.
Wow. I can't even imagine trying to sleep with that much going on. I mean, most people would probably...
So you could do a live interaction with those podcasters now? You've got to be kidding me. That's crazy. I gotta experiment with that at some point. Sometime when I have more time and focusing on it for hours doesn't become a problem.
grab earplugs or a white noise machine right away. Did our source try any of those things?
Oh yeah, they did. At first they tried changing their sleeping position, like avoiding having their ear right up against the pillow, because that can make the sounds even louder. They also tried using white noise. But even with hearing aids, they had to turn the volume up so high, it was just way too loud to be able to keep doing that.
So what happened? How did they get from struggling with this incredibly loud tinnitus to actually being able to use it to their advantage?
That's where things get really fascinating. Instead of fighting the tinnitus, they kind of decided to go with it. They decided to embrace this idea of turning weakness into strength, you know? And they realized that the tinnitus itself could actually be their white noise.
Hold on, are you saying they just kind of leaned into the ringing? How does that even work?
It's a really cool example of how we can change our thinking about things. Think of it like this. You're lying in bed trying to sleep, but your mind is racing, going over a million different things. Instead of trying to fight those thoughts, you gently shift your focus to your breath. Our source did something similar, but they did it with their tinnitus.
Okay, I think I see what you're getting at, but how did they actually make that change? Did they have any particular techniques?
They did, and this is where the personal part of their story really stands out. They started connecting their tinnitus with the feeling of stress leaving their body. It's almost as if it became this auditory signal, telling them that tension was releasing.
So instead of thinking something's wrong, it became things are getting better.
Exactly. And this mental shift actually had a physical impact. They talk about this feeling of relief washing over them as they focused on the tinnitus, like a sigh of relief, and it really helped them fall asleep easier.
That's incredible. It almost sounds like meditation or mindfulness.
You're right on the money. And this wasn't just a temporary thing either. Over time, they described the tinnitus becoming more of a background sensation, like when they weren't actively paying attention to it. It was still there, but it wasn't that intrusive, unwelcome feeling anymore.
So they went from this constant, awful ringing to actually finding a sense of peace in it. That's a pretty remarkable change. But I have to ask, if they're so accustomed to this intense tinnitus now, wouldn't it be hard for them to hear other sounds?
That's a great question. And it leads to something kind of paradoxical. Our source actually says that their tinnitus can get louder than the sounds around them sometimes.
Wait, how's that possible? Shouldn't their brain just tune it out after a while?
It's not that the brain completely ignores the sound. It's more about what we choose to focus on. Think about when you suddenly noticed the hum of your refrigerator. It was always there, you just weren't paying attention to it. Our source has gotten really good at tuning into their tinnitus, so much so that it can sometimes drown out other noises.
So it's like they've developed this superpower, the ability to control what they hear.
I love that. And what's even better is that they now use this superpower intentionally. When they have trouble sleeping, they focus on their tinnitus. It's like a tool to quiet their mind and drift off.
It's like...
I think I'll leave it there for now regarding that. I should post a link in the description to that one. I think what I'll do is I'll do it based on this title, then you know which one's which. And I think I already made a note, but I'll make another note just in case I haven't yet. So, yeah, I guess that's what I wanted to show regarding that. Apparently the interactive mode is a live form of this. I don't know if it'll pick up my microphone if I try it real quick, but I'm a little intrigued.
Welcome to the deep dive. Today, we're going to be looking into something kind of different. It's a personal story about living with some pretty severe tinnitus. But what's really interesting here is how the person actually learned to use their tinnitus. They found a way to make it a tool, especially for sleeping better. It's not just about dealing with the ringing, but turning it into a positive. So we've got their story and we've got some research. Let's dive in.
You know, what really struck me right away was that this isn't about like some miracle cure or just
I don't have my microphone hooked up, so I'm gonna forget about it for now, but I would definitely get to experiment with that off camera. I'm definitely intrigued. So yeah, pretty crazy. Like, it sounds like a real conversation. It's kind of interesting how it generates a flow, and then if you keep doing it over and over, it will do different results every time, which is quite fascinating. It's like you do it this time, it'll take this angle. You do it another time, it'll take a whole different angle. It's quite fascinating how it does that. I want to try that join sometime though. I'm curious to see how that works. So yeah, I was just explaining before how that neural network kind of applies to audio, video, image generation, because I think it can convert text into something similar. So even audio and video can be tokenized, as we were just describing about things getting converted into tokens. It's color coded by each token right there. Well, same thing can happen with videos and audio and all that stuff too. So you could convert text into a video, giving it a prompt. And that's what Sora does, for example. There's another one that I forget what it's called. But if you've never used Sora before, you can't because you don't have the free version of ChatGPT. I'll show you what it does in case you're thinking about using it. So you can give a video prompt and then it can generate a video based on that. This is all the result of tokenization. So here's some examples of what I've already done. So somebody uses telekinesis. I've been using this to try recreating dreams I've had or dream concepts to see what it does. And to be honest, it doesn't really do that good of a job in general, or at least I have a certain vision and it doesn't really do that good of a job with making it at least look the way it does in a dream. I mean, what it does here is pretty interesting. Yeah, let me just play it. Like, that's clearly something else. That's not the way I envisioned it. I was kind of hoping, the way I do it in a dream is I might have a water bottle, like perhaps on the other side of the room. But then I go like this, tense my hand. Yeah, actually, since you can't see the bottom of my other hand, this is essentially what happens. Even if it's in the other side of the room. It's quite fun to do. I'd say I do that type of stuff at least once a week, if not more, in dreams. The way they show it here is a little bit different, but they definitely did that concept. What's worth noting, at least what I've noticed when trying to do this, is I try to describe what I wanted to create. I have a feeling that it's behind the scenes, it summarizes what it does. Like, I wouldn't be surprised if it translated my prompt into this, and this is what it actually generated, rather than create a video where someone uses telekinesis to grab a water bottle from far away or something like that. It probably simplifies it. In fact, the way it generates certain videos, that seems pretty plausible to me, that it simplifies how it creates certain things. Because, yeah, it tends to not really go along with my description. You can actually show it a video yourself and then have it try to recreate what you want it to do. If you could describe it using your video, it still tends to be way off. Like, here is some other telekinesis. This was my first attempt, and this is what it ended up doing. Which, that looks impossible, clearly, but that's definitely not what I had in mind. And I should also clarify, it usually does it for only like 5 seconds, or else 20 seconds if you do the higher tier plan for ChatGPT. You basically have a count of tokens and, well, credits, I should say. You have a certain amount of credits you can use each month, and if you have the higher tier plan, you get more credits per month. And all these different parameters have a cost to the credits, so 16:9 will have more than a square ratio, for example. Doing a higher resolution, not only is it slower, but now it's from 25 to 60 credits. So I usually stick with 480p and 5 seconds, or maybe 10 depending on the situation. I didn't realize I had 10. Interesting. I don't think I did to start with. And some of these other, trying to recreate a Taz visual, which is something that I've used in virtual reality. That's not too far off from what I recall. If you were to hybridize that concept with Minecraft, I suppose this is what you would get, technically speaking. I tried to imagine that a computer circuit board is like an entire city. And to be honest, this isn't exactly what I had in mind. I feel like if you got really microscopic, like a lot more than this, it probably would look a lot more like a city, potentially. And then I tried doing other lucid dream type stuff. There's something it did right here that's clearly impossible. But it's still not what I had in mind. So like the finger through palm reality test, I tried to get it to recreate that. In a dream you can go like this, and your finger will come out of the other side, or it can. Not guaranteed, but it can. And actually I did it last week, and I got my finger to go through, but it didn't come out of my other side until like 5 seconds later than it was supposed to. It was pretty funny because my hand is sinking in, and then it slowly starts to come out even though it's already in. So there's a bit of latency with my finger coming out of the other side, which is hilarious. And I would like to convey the optical reality check that I do, where I basically blink like this. In a dream, I tend to not have eyelids, but my finger still does the same movement. In fact, I think I replicated that under here. Yeah. So this is my blinking test without AI. So I normally blink and then my finger moves back and forth like that. I got it backwards, by the way, compared to what it's supposed to be. The directionality is wrong, but that doesn't matter. Whereas when I'm dreaming, I don't get visual eyelids at all. It's so weird, because I still have a physical sensation of blinking. Actually, when I go like this, I tend to not get eyelids either. Or my face feels partially paralyzed, or... Actually, one time I did this and my finger was going forward and backwards and then it fell off. So I broke my index finger just by going like this in a dream. Very weird. That was about a month ago. So yeah, interesting stuff. So I've been trying to recreate some lucid dreaming stuff. I haven't explored it a whole lot, but another one is sometimes when I start the fan in a dream, all the blades will spin at different speeds and then overlap each other Like the blades are sort of like this and really fun to watch, as you can imagine. It looks like it's not supposed to be safe, but the closer I look at it, the more safe it looks. Classic dream logic, right? I'm trying to recreate that, but the blades don't really overlap each other, even though it does do some awesome weirdness. This was after taking a video of my own fan normally, but then I ask it to add the distortion that's impossible. It doesn't quite do that. This was kind of a weird. That's clearly not possible. So that's basically all the videos I've done. Suppose I could try one real quick. For this one, I tried to make it so that you could see the cuckoo clock waits, but it winds itself up. So I could illustrate right now real quick if my phone is gonna play ball here. See if I can connect my camera. Perfect. So if you look at this right here, that's my cuckoo clock. If you've seen my cuckoo clock in other videos, this is different than the one that's normally there. Because, well, I have multiple of them and I temporarily swapped it. The other one's in the closet. But in the dream, I can have it so that the weight winds itself up. I'm just like, dream, wind the weights. Or I tell the cuckoo clock to wind its own weights, and then they'll go up all by themselves, which is kind of cool. So, yeah, I try to create that in the video where the weight will just be like all by itself upon voice command, but unfortunately, this is what it came up with instead. The weights aren't even there. See, I think what it did for the search phrase was enchanted cuckoo clock, which is not accurate. In fact, let's try a self-winding weight. I want to keep the description simple. I think in order to get the best results, keep it as simple as possible that captures the essence. Because otherwise, it probably simplifies itself and it might do it the wrong way. But if it's already in simplest form, encapsulating the essence of what you're doing, it's probably going to do a better job. And actually, what's kind of fun about this one is the way that spins right there reminds me of the fan governor inside of a cuckoo clock. It's actually quite easy to see the one right up there, so maybe I'll show you guys what that looks like. It might end up being hard to see on this live stream, unfortunately. So I'll see if I can convey it though. So I'll reconnect my camera and then I'll go up there and try to show it to you. I'll see if I can convey there's like inside a cuckoo clock on the gearbox, there's a fan governor essentially that spins really fast, but it limits how quickly the weights go down while it cuckoos. It's actually kind of a cool mechanism. So I think I'm gonna go up there real quick and show it to you guys. So guess I'll see you over there. Gotta get around a bunch of obstacles. Hopefully you can hear me all right. So essentially, here's the side of the clock. Might be kind of hard to see inside of there right now. Hopefully it's not too hard to hear me. But there's a little component inside of there that governs the fan speed. Let me see if I could real quickly convey that. This is going to be hard to convey. I gotta turn on the clock to begin with. Okay. It's kind of tricky to demonstrate live. But there is a... So this will make the door open. And then... Trying to get the fan to face there while I have a hand free. See if we can see the governor. Part of the minute hand broke. So hard to get a good angle. How does it look when it's upside down? Or when I have the camera facing the other way, I should say. Looks a little backwards, but you see this component right? How do I do this? Holding a flashlight. Whoa. You see this? How do I do this? You can see how I'm holding this. You'd think that I'm mad. Mental. Right there. That's the governing fan. In fact, whoops. Okay, we're still fine. I thought I bumped a button. You see that fan toward the top there? Right about there, but closer in. Hard to see it from this angle. Actually here. See it now? Wait. Screwdriver gets in the way. That thing that I'm pushing right there, that's the fan governor. How do I get my hand out of the way? There we go. See what I'm pushing there? Now you can kind of see it toward the top in the door. That shiny thing, that's the fan governor. Watch it. See it spinning? If I put that there, it stops. Kind of hard to see. Tempted to take it apart, but it'll be impossible to hold things. Hopefully you saw it. A little exhausted doing all this, holding it. Well, here's another weird quirk about the clock. There's a little piece inside, might be kind of hard to tell, but it's currently straight. That shiny piece toward the top of the door. It's straight right now. You'll notice that when it cuckoos, the door keeps shutting itself. Every time it cuckoos, the door actually shuts itself. It's pretty strange. It's a strange little quirk, but there's a little thing inside of there that's straight. And if I knock it down, it might be hard to see, but now it's no longer straight. The door will stay open when it cuckoos. And I stopped it by taking the weight off. But now that the thing inside is no longer straight, the door will stay open when it cuckoos. Try to do this one-handed, which I just nailed, but now I don't. Okay. Now it'll stay. It stayed open this time. If I make it so that that thing in there is straight again, then it'll open and close like it did earlier. So that's my cuckoo clock demo, I guess, for you. So yeah, crazy, huh? Okay. I'm tired, so that's enough of that. I guess I'll come back over to you guys. My apologies for getting so sidetracked here. Seems like I'm going on a bunch of rambles, much like I do in those streams. So yeah, let's see how that thing turned out. Yeah, I disconnect my phone to save on battery. Okay. Let's try this out and see what it came up with. That looks nothing like what I would have expected to see. Those hands are pretty odd. 3 of them. What is that supposed to be? They're both kind of cool. I wonder which one I should keep. They both have their own quirks. I like how that hand kind of moved by itself. Maybe I'll just keep that one. Cool. Any of you are watching live and you have any suggestions you want me to try, let me know. I'll give it a shot. I know there's other videos like, I think somebody did a cat eating noodles and that looked realistic, which was pretty impressive. Kind of hard to think of ones it'll do well with. Usually what I try to do it with, it tends to not do very well. But it depends on the kind of thing you're doing. Some things it will work very well. So yeah, I think now would definitely be time to get back to the custom chatbot. Remember, the whole point of me doing this is to show my thought processes for refining my time travel chatbot. That's the whole point of me doing this. And so far I haven't done any of that yet. But now you know about the time travel film if you've been watching this, and you also know about how this concept is a thing that can affect how the model behaves versus not. And how Notebook LM, if you've never heard of that, that's not bound by this at all. Everything is in the short-term context window. So I guess there's different types of chatbots. There's a context window one. I think a lot of people believe that this is a RAG tool or retrieval access augmentation, I think. But this is not a RAG tool at all, because everything's available in the short-term context window. So this is more of like a context chatbot, because everything's available. Whereas private GPT, that can't store more than like 60K tokens, for example, using a local model. If you're wondering about local models, that's something that I run on here using GPU acceleration. So I run WSL to run Linux inside of Windows. Actually, now that I think about it, I might have a hard time with the GPU acceleration because... How do I make this bigger? Okay. I might have a hard time with GPU acceleration simply because this is what I use for a server. This is actually from a rack mount server that I have. And the chatbot is GPU accelerated, which helps quite a bit. Actually, now that I'm thinking about it, I want to run this in the terminal instead of command prompt. That's fine that it's PowerShell. So I'll go into my WSL2 instance. If I want to run a local chatbot on here, then I can do Olama serve. Then I'll run that in the background to dev null. Then I'll redirect standard out and standard error to that and run it in the background. Because you have to create a server for the chatbot to be able to run it. And then I have Llama 3, so I'll just run that. So now it's launching, and I think you can mess with the number of tokens with a parameter on this. And yeah, this works without the internet. In fact, the server itself doesn't have an internet connection right now, so yeah, it'll work. So how are you doing? It's not super fast, but it's not bad on the GPU. I am functioning properly. So yeah, this is all without the internet or anything. And you could use private GPT with Llama as a local AI model, for example. So yeah, this is pretty cool. So yeah, and the way the parameters are configured might be different depending on which model you're using. And how well the context window for short term will work is based on the architecture of that neural network and stuff. So yeah, I think we should definitely get to training the model and working on the things I need to be tweaked. Now that I've gone over all this background information, which did not need to take nearly this long, we can make some tweaks to it, and we're probably not going to spend too much time on it, but I'll show you the gist. We'll spend a little bit of time working on some of the stuff that I haven't thought of myself yet and see how far we can get with that. First, I want to take a little break, so guessing I'll be about 10 or 15 minutes perhaps. So yeah, I'll see you in about 10 or 15 minutes. Alright, I'm back now, so why don't we just continue with the next thing. So we'll start working on that chatbot now. It's actually getting kind of late. This is way longer than I thought it would be, so I think we're gonna actually kind of summarize some of the stuff a little bit that I'm gonna be focusing on. So let's modify. So now you'll get to see how the custom GPT creation works at this point. So you go to edit the GPT. So the conversation starters are really just what the user sees. The instructions can affect our ability to do this. And this is basically just a general chat window with the ability to tweak stuff here by itself. That's essentially what this is. So yeah, given the interest of time, I think I'm going to keep it relatively quick. Here's another Vim move, just highlighting whatever's inside of quotes wherever I am. I want to go, oops, I don't know what I just did there. What the heck am I doing there? Well, if I want to highlight anything in these quotes, I could go like that. I just do VI quotes. Or if I want to delete stuff in there, CI quotes. Then I can start typing in there something else. So yeah, this isn't about Vim shortcuts. Anyway, so if I want to copy and paste that, then I'll go like that. I'll close out that window. So how do I make it so it doesn't use that terminology? I'll just describe that it does. Oh, and if you're wondering how I trained it in general, what I did was I pretty much provided one instruction at a time and then made sure it understood it and then integrated the knowledge into here. Then I did the next one and so on. I did a very iterative approach. I tried it without doing the iterations and it kind of sucks. The iterative approach makes it easy to do well with this. Oh, and I also want to remind you when I explored this right here, that's without any custom instructions, yet I would argue it gave better answers. Why? Because it was grounded in the materials. Everything's in the material. Didn't need instructions, but if you want this to work well, you need instructions. And yeah, these instructions are actually generated by this. It did those instructions for me. And actually, when it comes to the Big Bang Easter egg, when it came to the Easter egg for the Big Bang year, it tends to reveal the answer way too soon. Like even right now probably will. So I made some manual tweaks since I told it keeps revealing the answer too soon and it doesn't seem to understand what I'm talking about. So I ended up just manually tweaking these instructions and I think it does a little better now. It probably has a hard time being able to tell when conversations are back and forth. So therefore those kind of instructions might not really help. Because it probably barely has any awareness of when it goes back and forth and being able to translate the instructions into being like, okay, now it's been 10 back and forths, now I can reveal the answer. And yeah, the Big Bang Easter egg year is revealed in part 3 of the behind the scenes podcast, which is not there, right here. think we're getting some lag now. Maybe not too bad, but a little bit. I apologize if that's bothersome. The streaming computer is really not probably the best hardware for a streaming computer to begin with. But yeah. So the hidden Easter egg will be revealed in part 3 out of 3. And it might be revealed here at some point. I've probably already revealed it when we looked at my time travel notes here. Yeah, it's probably revealed there somewhere. We don't know the exact year since the Big Bang starting point. I literally mentioned that we don't have the exact point in time, but we have a really close estimate as indicated in that 1854 right there, which I could probably show on I could do the chatbot and ask it where that is. It'll probably be able to answer given that it has a transcript. And if it doesn't right away, you can mention there's a transcript resource and it might then look for it and then answer accurately. That's one of the weird things about it too. So the estimated year from the Big Bang point in time, because scientists don't have that figured out, but I mentioned that scientists don't have it. But since I needed an exact number, I derived it from special hidden Easter eggs, which I guess if you're curious about that, the hidden Easter eggs are essentially, if you were to map out everything on a timeline, this is the timeline representing certain points in time. So actually, if you take, since the estimate is like 13.73 billion years, plus or minus, actually I'll put it here, plus or minus 120 million, then if you were to plot that range on a timeline, I think it's like 13,610,000 or no, 13,610,000,000 versus 13,830,000,000 maybe. Well, if you put those exact numbers on this timeline, so like 13.6 billion versus 13.8. Sorry about the sloppy handwriting. You map it there, but then you actually treat this like a timeline with a percentage into that range. If that 13,610,000,000 is 0% in the timeline, the actual hidden Easter egg that I did right there is a certain percentage in there. All 3 hidden Easter eggs pertain to where that specific number is located. With those hints, you should be able to figure it out. There's obviously special references for where that comes from. So yeah, if you're wondering about the Big Bang hidden Easter egg, that's really what it pertains to. The chatbot might reveal the answer too soon, but it's able to answer the question. So yeah, why don't we look at this? So I don't want it to use that terminology. I'll just say at one point the time travel bot answered, that might seem strange due to it being another person using it. When you mention provided resources like that, it seems strange, I don't know. Could you fix that phrasing? So then, you're absolutely right. So it really is like a regular chatbot, as you can see within the framework outline for time travel in this context. And this has to do with something else, so therefore it now has all the knowledge for what it needs to do more accurately. Yeah, that's the idea. Did you tweak the model accordingly? So now when it says updating GPT, what it's actually doing is updating those custom instructions based on context here. It's actually quite intelligent when it comes to that. It's probably not perfect all the time, where you might be able to think of better instructions for certain things, but yeah, so when it updates the GPT, that's really what it's doing. It's only changing stuff that's in this tab based on the short-term context that we've established right here. So while we're waiting for that, let's figure out what we're doing next. Oh, this does relate to the prior point. So now I want to highlight everything in those quotes. So I just do VI quotes. And actually a lot of the Vim shortcuts, you can do abbreviations. Like, I think of VI quote as visual in quote. So in other words, visually highlight in quotes, and it'll intelligently figure out where that is. If I want to include the quotes in that, then I do VA quote. In other words, visual around quotes. So yeah, pretty handy. And because Control C is a Vim shortcut, I have to manually right click and copy. On the Mac, I could just do Command C. Okay. Okay, so based on what you've changed now, can you also avoid the provided context phrasing at the end of this? So what it's doing there is it's probably manually adding examples under the configure tab. Ideally, you would have all that information inside the library resources right there. Ideally, all the information would be there, but if you have to augment immediate stuff, then I guess you can add it here and there on the custom instructions. But if it's possible to avoid that, I would, because it's not like you want to have all the knowledge inside the custom instructions themselves, because that's getting tokenized and it's part of the context window as well. Okay, I'm just gonna assume that's good now. So that plausibly explained terminology. I'm not sure if you've addressed this yet, but another phrasing it once had is where it said plausibly explained. Perhaps you've now addressed it, but before this session, it's done this. I don't know. I kind of talk to it like I talk to a human. Like, in order for a human to understand all these given things, this is what you need to know. If you're actually using the chatbot, you can do it right here. You can technically do it here too, but I would focus on tweak type stuff there. And then what's nice about this system is you could probably brainstorm stuff too. So when we go over how we're gonna address this paper, I'm probably gonna brainstorm with it, or if I'm doing precise math, I'm probably gonna want to use the advanced reasoning model, which is O1, I believe. And by the way, when it took a long time to tweak, that's probably because the custom instructions are now very detailed. It's probably figuring out how to best modify it. Whoa. Weird. Is that a normal Vim behavior? There's no beginning quote right there. Actually, that should probably start at the true beginning. Maybe right there. In the following phrasing, which was generated in the past, ensure that it's very clear that energy is trapped. So I guess that's a note I made. And then I guess that's where you use that imaginative adaptation in that screenshot I shared. I'll start writing the next message while I'm waiting for this. Here's another phrasing I once had. Perhaps you've tweaked it already, but in case you haven't, ensure it doesn't just say stuff like imaginative adaptation. And what's kind of interesting, you can talk to it for a while without it making any tweaks like this. And then you can be like, okay, based on everything we've discussed now, update the model accordingly. And then it'll do this, which is actually kind of cool. So that's what's in quotes there. So what we're doing is the calculator, basically what the calculator is used for, which is controlling power distribution on the multimeter, which, in case you're wondering, I do have. So yes, this is a real unit. And I had it set to AC 200. Yeah, that looks a little laggy. Maybe I should not use that. I probably have to reboot the computer to get performance back. Oh well. Anyways, yeah, so AC 200. I wonder if I'm going to want to give it some pictures illustrating when you're measuring voltage, you want it hooked up here. When you're doing amperage, you want it there. And then obviously some multimeters look very different, and sometimes there'll be like a fourth one for something else entirely. So you'll want to keep that in mind when you're doing stuff with this. So did I copy that yet? Perfect, thanks. We don't have obligations with AI at this point, I don't think, but sometimes I can't help myself. Okay, so here's another statement worth noting. In this statement, it's worth noting that the calculator doesn't encode any special signals. It is purely for power distribution. I can even spell right. So the calculator is purely for power distribution. When it is sending off-duty PWM signals, the button presses get stirred up in the continuity since there is a circuit, but no power is actually being emitted. And then once an on duty happens, that's when things happen. So no particular device is storing the TV remote signal due to this. The calculator purely controls power distribution with PWM. Makes sense? See, then I can make sure it's on the same page and then tweak anything accordingly. So now it's updating that. We can figure out what we need to do next. Translating signals. That was a note that I added earlier today. Probably not the most important to do right now. I think you kind of get the idea so far for how I'm tweaking the model and things that I need to address. Maybe I'll start writing that next one for now. There's probably some I can skip over when you get the idea. Okay, thanks. It's worth noting that it might be worth having knowledge that technically, since we're using equations and taking properties of waves, we could theoretically use other types of waves on the spectrum, like UV light or maybe X-rays, if we account for their corresponding properties and are consistent in the math accordingly. So yeah, I think, for example, here we take the average wavelength of infrared, as you see, factoring and speed of light, etc. If we can do the corresponding thing with UV signals, if there were such thing, we could then use that instead. For example, not sure how you want to integrate that. And then it could maybe decide on the best way to integrate that type of information. We'll see what it ends up deciding for that. Are you still getting music or no? Might just be the end of that particular song. Yeah, it is. We're good. And then here's something it said regarding absolute value. The energy emission process, when working correctly, should produce positive readings. The negative readings are from noise or errors. So taking the absolute value to safe correction. In the following statement from the past, you said, technically, the reasoning is... Oh, so I should also specify when it came to the custom instructions, since I haven't trained it on everything, I provided it with a framework for how to handle the things I haven't trained it on yet. And you'll notice that some of my resources that I actually shared with it are things like, this is basically a segment from that pre or post-production podcast, which I have on that second channel. I don't have it readily available right now, but on this podcast, I basically talk about those concepts there, and I provided it with the raw context because while I go over the realistic side of it, and it goes over like why certain concepts aren't real and that type of thing, I figure it encapsulates my thought process, which will help it generate answers when it has that information. So even though it has a more realistic information, when it sees the nature of my thought processes with that should be able to help it formulate answers. So when I did my iterations of training, I factored that in. So that's where the raw thought files come from, such as this one. So technically the reasoning for absolute values is if the prongs are in the opposite direction, the multimeter does that due to charges. Energy flow is otherwise the same, so no matter the direction, it will tally correctly. That is the simple reasoning for that. Because, yeah, what it said is a little bit strange, if I'm being perfectly honest. Checking how many frames we're dropping. Not on the live streaming side, but from a system performance side, we are a little bit. And then on this one, this has to do with my particular thread on Why are there so many duplicates of that? Temporal dispersion explained. Something that's on this particular thread. Clarification on what happens if the time travel stops early. And I think the key word is stops flowing. If it stops flowing prematurely, here's some things that could happen. The energy alignment across the timeline may fail. Partial jump might happen. So if the time travel stops early, what that really means is temporal dispersion ends prematurely while energy is being emitted from the present to the future, but appears to be from the future to the present. In fact, yeah, we could argue that the recursion is essentially allowing for reverse entropy. So then it makes you think, could recursion then be used to de-age yourself, make yourself younger? I wonder if recursion would end up being the answer to that someday. We're trying to accomplish reverse entropy in real life. Could recursion allow us to do that? Kind of hard to say, but it is interesting to think about. I want to also make sure it is clear that when time travel stops early, or in other words, the energy emission does within the timeline. Technically, it would likely prevent time travel from occurring at all. Or it could what else could it do? As I say in the video, cause me to go to a different point in time altogether, or cease to exist. Wait, it was more certain. What is that word? I don't even know how to say it. Serendipitous? Oh, I'm not even gonna get it. I'll butcher that. I want to leave that. And then I'll start clarifying this. I think you probably get the idea for how I would do that. To clarify how the TV remote is connected to the multimeter, it is hooked up via duct tape and not the internal circuitry. Because remotes, that's not good. Ooh. That's an issue. Yeah. What I should probably do to fix that is either have it summarized without losing the essence of those instructions, or I could probably have it create resources and then instructions on how to fetch for this. And then I can condense it down. That would be a way to address that issue. For now, I'm not gonna worry about it too much. But yeah, either I condense it down so that the meaning isn't lost, or I break it down into knowledge files and ways to accurately index it and all that stuff. Like, I could have it say, create this file called this and put this information in it. And then I'll update the instructions to reference that file for the information I need. So as you can see, working with the GPT creator can be quite powerful for reasons like that. So, okay. I'm not going to worry about that character limitation for now, but that would be a potential solution. Oh, everything I started typing here is gone. That's something also worth noting. You switch tabs, your message will be gone. Context will still be there though. I should also clarify the TV remote is not connected via internal circuitry. It is connected via duct tape to the battery springs. TV remotes don't program themselves. We press buttons on them with the stirred up continuity. And that's one of the other interesting things about this. We might have some context about certain things in the short term, but because of the attention mechanisms and how things are focused, it might know something in the short term, but fail to integrate it for future use because of attention mechanisms and all that stuff. The stirred up continuity. We're also not likely to solder the multimeter to the TV remote either because of the prongs. So I'll let it do that for now. If the power goes out right now, I'm gonna have to do this all again. So that's worth noting. I think you get the idea for how I would do this, so I'm not going to do it now. And I think I might have clarified this already, I'm not sure. I'll work that out later too. And I could check with this to make sure it understands there's not a 3.5 millimeter jack. I could quiz it on certain things and make sure it understands it correctly. I think I've already done this, so I'm gonna forget about that too. I'll worry about that later. And the for loop, it's... Yeah, I think I'll clarify that right now because what we're going to go over in a little bit will be kind of relevant. But I think you get the idea for how I do some of these other points, so I'm not going to do them now. For the sake of time, I should get to bed relatively soon. Okay. You know, maybe when I figure out more details about that later on, about this. I think maybe I'll do it right there. Oh, there's another Vim shortcut. I was just up here, and my ability to jump back to that point was a Vim shortcut. So with data, I'll be able to understand that easily. But yeah, I'll include an excerpt for what I've shared in the recordings at some point. And if there's supplemental updates, I'll do them afterward. So that'll work well. Okay. So now the lack of precision with the whiteboard math is rather interesting. So I think it's in the building a time travel device. Sometimes it'll do scientific notation instead of... So I should probably clarify. So it's the math to calculate the TV remote number. I should probably clarify how that works. So it is real math. You're taking that speed of light. Maybe I should show the video with the whiteboard, which will kind of help illustrate how that works. So this is real math. I don't have the steps on there correctly because I just took from my notes right here. I have the remote numbers written down ahead of time. And yeah, the Big Bang Easter egg was revealed on there. The one where I put my hints right there. So yeah, that's real math. Take the wavelength of infrared, converting it to the number of hertz per second, then you multiply it by the seconds since the Big Bang. And if this is the Big Bang year, then you want to convert that into seconds, factoring in leap years. So you can either multiply that by 365.25 times 86,400, which will convert. So that 365.25 is an average 4-year leap years. And then times it by 300, or times that by 86,400, then you're getting 1 year on average in the number of seconds it is. And then the current year for the Big Bang. Wait, how is it again? Yeah, figure out the number of seconds for 1 year, 365.25 times 86,400. That's the number of seconds in 1 year. Then you convert this year estimate into seconds also. Or wait, you multiply it by that. Because that's the number of years that the seconds are being dealt with. Then you want to convert the date and time into seconds, as I do there. The current year in seconds is actually this times parenthesis 365.25 times 86,400. So that number of seconds multiplied by this number of seconds, I believe. Because you convert the month, day, year, hour, minute, second into seconds. Then you get the number of seconds since the Big Bang. Multiply that by this large remote number, and that's what you punch in. So this is a pretty large number. Most calculators can't do that. In fact, if I try to do it on my TI-85, if I try to do that exact number, then I think it'll do scientific notation. I don't need to demonstrate that. It'll do scientific notation. And that level of precision won't be helpful for this, because this is what represents 1 second. You literally double this, that's only 1 more second later, so you do need to be relatively precise with this. And what you get with scientific notation might not be precise enough. And for some reason, some of the answers that it's generated were scientific notation instead of the log number that you want to be able to punch right into the remote. So I could also illustrate to calculate the remote number. This is what I provided in the long-term instructions. I walked through the math through each individual step. That's why I was able to produce the answer that it did. But despite all that, it'll sometimes do scientific notation even though it has the answer that it needs. For some reason, even though it has it right there, it does scientific notation anyway. So like, where's the building a time travel device? Yeah, this one. If I go to remote, or maybe if I do calculate as the keyword. Yeah, here we go. So it walks through all the math as highlighted on these notes. And it just takes the direct number. Oh, it did it correctly on that one. That's interesting. Oh, here we go. So it did it correctly when it's a known number that's shown in the video. Wait, what? It did show the... Oh, that isn't the large number actually. I take that back. It knows what... These are the numbers you multiply together. And in case you're wondering, the way I typically do it is using a Python interpreter. Because it does a pretty good job. So if I run idle, which is a Python interpreter, if you have Python installed on your system. So I'll just paste that in, change that to the actual multiplication symbol. And that's, oh, it thinks it's a tuple. So you want to do that without parentheses. This is where Vim is useful, by the way. So what I'll do here is on this line, specify this, highlight the line. I'm going to substitute a comma with nothing. So that's a nice way to get rid of the commas right there. So now I can paste it in without the commas. So there's a large remote number. And try and think of the quickest way to add commas using Vim. Could probably use a macro, technically. So I guess what I would do is create a macro, go to the beginning of the line, go 3 characters later, comma. Oh yeah, that's not universal for everywhere. I could just go one over, then repeat. Oh. That's really not what I wanted. That beginning of the line is not what I wanted, so I'm going to create a new macro. I'm going to go over 3 characters later, comma, 1 over. Then if I reproduce that, then I could do that like, I don't know how many more I need, like 6 of them. Nope. I could then do 1 more. 1, 2, 3, 4. See, if I knew how many I needed, like, looks like it's actually 10 of them. So, because of the macro and movements I just recreated, then I could do that 10 times. Where did it go wrong there? 9 is really what I wanted. Yeah. That'd be one of the best ways to recreate commas, I guess, even though it's not necessary. But yeah, so I'm sorry, I got on a ramble there, showing some Vim stuff again. See, is that something that Data would pick up on easily, or would he struggle? I'm going to basically have him go through, since I haven't actually taught him yet, once he understands the fundamentals of typing, which I think he'll be able to pick up on easily, I can just explain, you have your hands on the home row, at least with the QWERTY keyboard layout, and then how you move your hands across from one to the other. If he understands that, I'm curious to see how quickly he picks up on that in the dream. And then you can also learn from video resources that I did, but I'm going to actually teach them in multiple ways because there's pros and cons to doing each. Like I could have him watch a video, see where he struggles while I observe him. Otherwise, I could just teach him myself and I'll get the live questions, which would be nice. I'll better understand that. Otherwise, I could just have the dream make it happen, and then I could ask Data, when you were learning it, what were your struggles? You have them all in your memory bank, what are they? But the answers I get might be different because a human mind can only do so much. It's a biological AI after all, and it might give different answers every time. It's crazy what it would do. But yeah, so it's doing scientific notation right there. So I'm curious about why it did that. Okay. Regarding the TV remote numbers, I'm curious why sometimes you do the precise number, which is useful for immediately punching into the TV remote, but other times you do scientific notation which doesn't have enough precision for the number, since a second is a really large number from one to the next. Based on how the model is configured, why does that happen, and how can we make sure you always produce the accurate number without being derived from scientific notation? It's worth noting that behavior is intermittent and sometimes does the precise number instead. What is needed to ensure scientific notation precision is never used. We'll see what we can do there. So yeah, if you're wondering about the math, you can walk through this or just ask the chatbot itself. So yeah, as far as the number of characters being too much, we can either have it summarized without losing too much meaning, which I question how well that would do. Or else we could just have it create files and I could have it propose what it should do. And it can tell me what to name the files, what to put in it, and then I can have it create instructions accordingly so it can accurately index. I was wondering if there was a character limitation. Sure enough, there is. I'm also wondering if this actually changes at all. Maybe it's not, but I don't want to spend too much time on this. I'm actually starting to get tired because I I try not to stay up as late these days, and my circadian rhythm is definitely adjusted. So I'm starting to space out now. Despite the fact that I have pure white light right there, which has a lot of blue light in it, I don't feel any less tired as a result. In fact, doing this is probably more tiring than what I typically do. Especially since the way I'm doing it right now is just so much detail that, well, it's not that it becomes mind-numbing, it's after a while the mind almost wants to zone out. And it should get a little break. So, well, let's see what it said. Will it be able to avoid scientific notation? I'm just wondering. I don't want it to update anything. I'm just wondering. It's really a question. Do you think you are capable of avoiding it as a large language model? So there's a model with critical thinking on it, or advanced reasoning. That could do arithmetic and stuff. I would trust that over general models. Like actually calculating GPA with it, general large language models might do it wrong, whereas a critical thinking one will likely do it right because it does actual arithmetic and it has like a calculator functionality built in. Otherwise, with these models, you could probably use like Wolfram Alpha or something like that, which has math capabilities. Okay, so I'm going to try to figure out how to not stay up too late while still doing what I want it to do. Because I wanted to go over some of the unknown stuff, as I explained before too. And my mind is actually starting to zone out, believe it or not. I used to enjoy staying up late. Well, I mean, I used to stay up late, but when I did, my morning self was like, I'm gonna kill you. And yeah, I've been trying to go to bed earlier. Now I'm spacing out. Okay, so that's a term that it used. Might be beneficial to do a more layman-friendly example. And thinking about it from an outer perspective, it would be nice to make the information accessible to everyone, as you could imagine. So that's something I'll address later. So if you look at the actual video, the alarm clock randomly shuts off when I'm in the middle of ionizing. So you can see the alarm clock on the frame right there. But watch this. The ionization is what's actually causing the heat in the first place. So why don't we go ahead and put it in and give it a shot. The alarm randomly shut off. The ionization is what's actually causing the heat in the first place. So why don't we go ahead and put it in and give it. The reason I did that is because I realized last minute that I can't realistically convey how long the ionization occurs since it'll vary for everybody. I figured it'd be kind of a nice hidden Easter egg to do that, but also people should be able to figure that out themselves, and it should be clear that there is no one universal answer. You kind of feel things and eyeball it, if you will, but the tactile equivalent of eyeballing. So that's why I shut off the alarm, but I try to make it really subtle. Like, I literally move my hand when it shuts off. The ionization is what's actually causing the heat in the first place, so why don't we go ahead and put it in and give it a shot. So, yeah, I did that. I think that was pretty helpful. We're dealing with the hidden Easter egg and all that. So I want to address that at some point. I might even have it tell the truth. Like, there is no one size fits all. And a simple Y doesn't show or something like that. You get the idea. Oh, other waves like infrared, I've already done that. Ultraviolet, I already did that. In today's example, what's that mean? See, now I put that note there, but I don't remember what it means. Oh, literally today's chat. Did I do like a infrared thing? Can't even remember anymore. Oh, I thought that was incorrect, but it turned out to be correct. One factory in leap year versus not. You'll notice on my notes, I give the leap year answer and the non-leap year answer. And I think I focus on this answer because it factors in leap year. Or it's consistent with what I went with in the video. You really could go either way. But I went with what's consistent with the video. So, yeah. So that's the basic idea. Hopefully it'll avoid scientific notation. If it doesn't, then the large language model might not actually be capable of doing that for numbers other than what I did here. So I gave examples of all the dates shown in the film and walked through it step by step. I was actually able to once get it to do like June 24th at 3:15 p.m. That's a date that I didn't train it on, but I was able to get it to do that, and it gave the correct answer without scientific notation or anything. And I don't even think it has arithmetic capabilities, so the fact that it could do that is shocking. A general large language model, this isn't one with the advanced reasoning, I don't believe. So the fact that it was able to generate that, that's impressive. But you might notice a potential problem with this particular setup. So you'll notice that with how I have things on the whiteboard, everything is based on the estimated Big Bang year, and all the dates I calculate are in 2023. It makes sense why we have those 2-year differences, right? 2023 versus the Big Bang year, which factors in like BCE or AD or whatever else. Well, the problem with that is, what if you're doing the year 2022? Then you'd be doing the same Big Bang estimated year, which is not what we want. Because otherwise the TV remote number will be the same regardless of what year you do, if we're doing it based on the Big Bang year. So what do I do about that? Well, it's kind of based on what my goals are at the moment. Do I want to make it easy to make it so that the remote numbers are different? I forget which way. I thought about this at one point. Or do I want to make it so that it's linear? In other words, I subtract, if I'm doing 2022 instead of 2023, I subtract 1 from the Big Bang year, and then at least the remote number will be linear. That's not really ideal. There's multiple options I could do. Let me see if I can think of which chat thread that's on. Might have been this one, where I used the advanced reasoning model. No, that's using my custom model. Might be on this one. Yeah, I think so. So this goes over, this is the advanced reasoning model. Wait, what? I thought it was all one. I think 4.0 actually does have possibly some advanced reasoning as well. So there's like an option 1 and 2. I'll mute the audio for you guys for now. Offset the Big Bang year estimate, which is what I just mentioned. So go with 13,776,607,999. When I go back 1 year, simplifies the calculations, avoids the complexity of leap years, but at the same time, if you're doing a leap year versus a non-leap year calculation, so I think for the time travel film, if I'm remembering correctly, I did the 129911. That's the non-leap year numbers. In the film, I initially had the leap years, but I ended up doing non-leap years when I refined the numbers on the film before time traveling. That's what I ended up going with. So we are dealing with leap years still. And it's kind of a weird one because 2023 is not a leap year. The Big Bang year estimate probably is. How do we deal with that? Well, I think what you want to do, if you were to go that route, would be doing the year, doing it based on the year you're modeling it after. So 2020 is a leap year, so therefore the year ending in 607,997, you subtract 3 years from that, that's where you'll get 607,997. What you want to do for the Big Bang year is you want that to be a leap year. If you're consistent with that one not being a leap year and based on 2023. So it's a little weird because you'd think that every 4 years of the Big Bang year, that's a leap year. But no. It's based on this number and that corresponding equivalent. So that's a mistake that I didn't anticipate at first, but kind of a big deal, especially if I'm releasing a chatbot like this. So option 1 is what I just described. We could otherwise adjust the total seconds based on the year difference. Option 2 might be more appropriate to give the Big Bang year estimate intact. Oh, that's an interesting point. So we could keep the Big Bang year the same, but then we could offset by 86,400 per year that we're going off. And it's not just 86,400. We have to translate that into the remote number. So it's really the 589 billion times the 86,400. And that's what we're offsetting by, which to me, both options have math that's really complicated and there's really no easy solution. So I think I'm going to stick with option 1, where you want to change the Big Bang year accordingly. You could figure out the delta change for that. So yeah, let's say I wanted to do 2024 instead. that's a leap year, so that means the Big Bang year estimate from 2023 will, you're going to add 1. So the Big Bang year estimate's going to be 608001. See, that's a little bit weird at first. So when I do the current year from the Big Bang, how is that mathematical step going to look compared to everything else I have here? When you break down each individual step. Let's search for 776. So where we use this number, we have to do 2 calculations. It'll be based on the target year, and we have to then offset this. So you could imagine how I would instruct the custom chatbot to make that happen. Maybe I'd update this resource accordingly. I don't think I'm going to actually do it now for the interest of time, but I'll convey what I would do and what I think will help with that. So I would probably, even though I don't need the formula for this, I'd probably put it there anyway, so it's an official step. So where's the 13776 used? Where do I put that? Do I not even use it? Oh, I must just bring this in here. Where do I calculate that number? I'd figure out where that is. And maybe I just take this number. Oh, is that it? Well, there's 2 different ways we can figure out the number of seconds. Do that 365.25. My actual preferred method is breaking it up into the number 365 day years and 366. That's my preferred method. But actually the 0.25 would result in the same thing because well, the reason it would result in the same thing. What am I even saying here? What would result in the same thing? See, now this is what happens when your adenosine is built up and you can barely think. Oh, right. It results in the same thing because it's got the 0.25. And if you do the math with one versus the other, I think you will always result in the same number. So maybe I didn't even need to bother with all this. The second way of calculating the leap year stuff. So yeah, I guess where are the steps in the actual chat thread? I want to make sure that even if I don't end up fixing this draft thing tonight, I want to copy these updated instructions and then tweak it later. Probably with the help of AI itself. Be like, okay, since there's basically random nodes here and there, what's a good way to add the knowledge inside of here and then index it with our library phenomenon? What's the best way to accomplish that? I could have it work out. It probably knows what it needs to do, to be quite frank. And if not, I could literally mention the very library concept to it. And it'll probably not deny that it works that way. So, yeah. So as far as the steps go, I don't think I'm going to update the actual steps right now for the interest of time, but I'm going over my thought processes for how I will do it. So, yeah, where we take the Big Bang year. Oh, I think I was just going to show an example thread. Where's a thread that shows the TV remote steps? Right here. So where's calculate total seconds since the Big Bang? So I suppose the year offset stuff would go here, right in between steps 1 and 2. I would have it do that formula regardless of the year. But since you're doing the difference, the target year minus the year, whatever, we would have a step formula. If it's target year, which is it? Yeah, target year minus 2023. If that's what the formula is, target minus 2023, you would then, even on these instructions, say this 23 minus, yeah, and then for the Big Bang year, if it's 2024, yeah, you would take that 13776 number plus maybe the result of this. Maybe we could combine it into one formula like that. Like this. That could be like our formula right there. And then now we have an adjusted Big Bang year. And then we do that with our math. Since I'm running into that draft issue and I don't want to solve it right now, I'm going to skip that. But I think I've conveyed how I would go about doing that. I would probably update the instructions here and tell it about the change. I would explain like how the year wouldn't be linear, so my proposed solution is this. Take the target year minus 2023, offset the Big Bang year with that, and then the rest of the steps are the same, right? So then anytime it gives instructions, hopefully without scientific notation for the final answer, then it'll hopefully do it accurately. So, yeah. I basically brainstormed with this on the different solutions, and that's the one that seems the most reasonable to me, so I'm not going to do it now. I conveyed how I would do it. Now, you know the mindset that's required. I think you now have that. So, let's talk about this now. Since we went over the TV remote stuff, let's now focus on this math sheet. I'll kind of go over how it actually works, and then the problem with making it realistic right now. So I'm going to erase the whiteboard real quick. All right. So, yeah, as indicated earlier, I don't really want to come onto the main camera. I'll just do the whiteboard instead. It's probably hard to focus a math sheet that I have manual focus on. Rightfully so, because the green screen will work weird. I mean, you can even see the outline of the paper. It's got a green edge on it. Because the transition between the background and foreground is not perfect. You can tell it's on the green screen, especially when I go like this. That's the problem with showing everything really close. So you're probably wondering, how did I get the steps to work? I used a mathematical concept called substitution. So the way, I guess I could show you how substitution works in general. It has to do with solving variables. So trying to think of a good way to convey that. I have this equation generator, I believe. I'm not even sure if I can demonstrate this live. But what I'd like to do is open a terminal. By the way, for those of you who are used to seeing me use Atom, using Atom, that's a text editor that I used to use that has Vim capabilities and stuff. I don't use it anymore. I switched to this, VS Codium. It's an open source version of VS Code. And you can still do terminal stuff here. And I still got my mini map right here for long files. So I'm gonna change to my D drive, which I'm going into. I have a script. So you probably wonder what I'm doing and how that ties with this. Well, I have a script that can generate equations. I don't feel like generating one off the top of my head. So I think I'm gonna don't have one with the word generate in it. How about equation? Try to list all the files in this directory. So Python system of equations. 2 terms for now. I don't really like that pair. I'll do it again. So it generates equations. I think I'm going to do one without a 1 in it. It generates a system of equations right there. You're trying to solve for x and y. That's the answer for x and y. But I'll show you how that works in general, because this is the heart of how I made this 1.21 gigawatt answer possible. I really use this concept here from a mathematical standpoint so that when you follow the steps, it logically goes from one step to the next. I could show it here too, I suppose. Yeah, that's a lot clearer to see. But substitution is what made that possible. So I actually adapt this sheet from several years ago. I'll show you the basic concept and kind of show you how to go from there, really. So let's take those equations right there. So 7x plus 10y. 7x plus 10y equals minus 69. Of course. Yep. That number cannot be avoided, it seems like. Oh, this is a negative for a change. And then the next number, 3x plus 9y equals negative 72. Plus 9y? Yes. So the question is, how do we... So x is 3 and -9. Why? Because if you were to actually put those equations in, I'll use this lovely tool here. This is a calculator, so if I want to do like 3 plus 4, 7, 7 minus 3, 4. I didn't mean to do the inverse. I was going to do some other equation, but I don't know what my mind just did there. It's in a semi-fluid state right now. I didn't even notice it was the inverse until after I did it. Anyway, so what you're doing is you're substituting x and y with their actual values, 3 and -9. So if you do 7, well, 7 times x, x is 3 right there. So 7x plus 10y is -9. That should give us -69, which it did. Why? Because it's 7x plus 10y. But x is 3, as indicated here. Y is -9. So what you're really doing is 7 times 3 is 21. 10 times -9 is -90. So what you're really doing is 21 plus -90. Or in other words, 21 minus 90. So does that make sense how you plug in the variables if you're not super familiar with algebra? Well, but here's the thing. What if you're given those equations and you don't know what x and y are yet? There's a lot of different methods you can use, like substitution, elimination, or Cramer's rule, which involves matrix multiplication, much like AI systems have, or rather taking determinants of matrices. I forget Cramer's rule off the top of my head, but that's probably the simplest, especially if you have to do many variables. And in case you didn't know, so obviously x and y are variables and they're the same on all the equations. But for however many variables you have, in this case 2 variables, x and y, you then have to have 2 equations in order to be able to solve them. If you want to be able to solve them based on this information alone, you have to have the same number of equations as variables. You could have less, but you're probably not going to find all the variables accurately. I learned that the hard way when I was figuring this out, because I hadn't done substitution for ages, and I probably haven't once again, so this video is probably going to be torture trying to figure it out. So how do we get x and y? Well, we have enough information to figure it out. We just have to do some math. So we could take any of those equations right now. Why don't we figure out what y is on this equation? So in order to do that, I want to rewrite it just so we have the direct steps. 7x plus 10y equals -69. In order to figure out y, at least with the information we have, we want to get y all by itself on this left equal sign, or to the left of the equal sign we want just y. We want to move everything else that isn't y over to the other side. How do we do that? Well, subtract 7x from both sides, like that. And 7x minus 7x is equal to 0x. And 0 times x is always going to be 0. So therefore, we could get rid of that. We don't even care. So now we got, this is gone, because now it's on the other side, essentially. That 10y, now that's all that's left alone. 10y equals negative 69 minus 7x. Because now the 7x is on this side. That's what you're left with now. And I apologize if I'm blocking the view, by the way. Maybe I should turn myself off for a second. Did I seriously not give myself the ability to? I don't have the ability to shut myself off there because I didn't even give myself a button. Oh well, I'll use that controller for now. Okay, so this will probably be a little easier for now. So now we got 10y. How do we get the y by itself? Well, subtracting 10y gets rid of it altogether. So you divide it by, because if you subtract the number with the same number, you get 0. You get rid of it. But if you divide, then you get 1. So 10 divided by 10, then you divide this by 10. What do you end up getting? 10 divided by 10 is 1y. Or in other words, y. Because 1 times y is itself. So you could just get rid of the 1. Because it's technically there. So y equals... There's a bunch of different ways we could write that. We could do 69 minus 7x equals 10. Or we could do minus 7x or minus 7 over 10x, because that's what that is. It's this right here. Minus 7 over 10x is the same as that. So that's good. But then this 10 still applies to here. We can then do minus 69 over 10, which is the same as minus 69 over 10, negative 6.9. So, of course, still involved. So we could do that minus 6.9. So now we have y all by itself. So guess what? We can now use that to figure out what one of the variables is. This is y, or at least y is equivalent to this, but obviously that's not the final number. So what we could do is plug that into one of these equations and figure it out. I think what I'll do is I'll take the bottom equation because we figured out y from the top equation, so it's probably best to then deal with the other one. Although it might not matter as much. Actually, I think you do need to deal with the other one. If you end up plugging it in there, you're probably gonna cancel it out, for being perfectly honest. You're probably gonna end up canceling the variables out if you repeatedly use that same first equation right there. So since we use this equation for all the steps right there, I suggest that we use the other equation for the rest. So that's what I'm going to do now. So we now know what y is. So this is the same as 3x, I'm just rewriting that equation, plus 9, and in parentheses we can put this there. So negative 7/10 x minus 6.9 equals negative 72. So that's what substitution is. We just substituted y and put that up there. Sorry, I did draw. This is y. We just brought it up there, yanked it, and then put it over there. I was gonna say yanked it and pasted it there. That's Vim talk. So yeah. So now what we have to do to simplify this, we essentially have x's now. There's no longer a y in the equation because we substituted it. Now there's nothing but x. That'll give us the ability to figure out what x is. So what you do then is 3x, I'm rewriting this, and then you're distributing things. So you might have heard of FOIL. Multiply each of those numbers as described there. So 9 times negative 7/10. So I'm going to do negative 7/10 times 9. Makes sense where that comes from. 9 times negative 7/10 x. That's negative 6.3, which is, I think, equivalent to negative 63/10. If I'm not sure, I can always grab my calculator and then go second math, miscellaneous, no, second calc. Nope, second math, num, more. There's a function on here that I'm forgetting how to use. I can convert that into a fraction. Negative 6.3 into a fraction. Negative 63/10. So I want to just do minus 63/10 x, since the x is still with it. But then 9 times negative 6.9, what's that? 9 times negative 6.9, negative 62.1. So that's still a minus. Yeah, minus 60. Maybe I should have done minus 6.3x right there. Yeah. Minus 62.1. So we've converted that parentheses into that. Equals negative 72. So now what we gotta do is simplify it a little bit. We can combine like terms. Since there's an x and an x, we can combine those numbers together. So I think it's 3 minus 6.3. That's negative 3.3. So negative 3.3x minus, so that takes care of this. We'll just put that there. Minus 62.1. We still got that. So that's what we're left with, equals negative 72. So now we just have one x instead of two of them. We're creating more x's, which make it more difficult, but now we're creating less, which is great. So now we can, how do we get the x all by itself? We can add the 62.1. When we do opposite signs like that, it becomes 0 plus 62.1. This becomes 0, so we could just cross it out. So negative 3.3x equals, so negative 72 plus 62.1. Negative 72 plus 62.1. negative 9.9. So that's what we're left with now. Now we can divide by the negative 3.3. So that we're left with x all by itself. So now x equals negative 9.9 divided by negative 3.3. The answer is 3. So now we have a standalone number instead of a bunch of letters and other malarkey, so that's an accomplishment. Uh-oh. Guess my camera's frozen. Huh. I probably better keep that off for now. And then I'll fix it later. My camera quit working though. At least this one's still working. So now that we got 3, we can now plug that into any one of those equations. It doesn't matter which one. So what I'll do now is maybe I'll take the first one again. So 7, we're substituting 3 for x, because that's x right there, plus 10y equals negative 69. 7 times 3 is 21. So it's 21 plus 10y equals negative 69. So now we can get the 21 onto the other side to get y by itself. This whiteboard is actually much bigger than what you're seeing. So it's kind of tricky. Maybe I can temporarily move the camera as needed. I never thought of that. Why did I think of doing that a long time ago? With my old setup, I never used to be able to do that. Cool. So subtract 21 from each side. 10y is now equal to negative 69 minus 21, which is negative 90. Right? Divide by 10 on each side. Y equals negative 90 divided by 10 equals negative 9. And then if we look at our answer, it's 3 and negative 9. Isn't that what we just calculated? Where's our x? X is 3, y is negative 9. So that's using substitution now. Makes sense, hopefully. Now I'm gonna fix my camera real quick. I have a hunch on what needs to happen. Whoops, not that. Nope, now I'm gone altogether. I get physically disconnected thanks to gravity itself. That is odd. With the way I have everything set down, gravity is what did that. There we go. That's better. Kinda hurt my back a little just now with what I did. Almost felt like I pulled a muscle. So yeah, that makes sense now. Oh, why is that not showing up now? Ah, that's why. Been having to use this to toggle myself. So that's substitution. Now that's actually one of the simplest forms of substitution. What if you have more than 2 variables? Can you imagine how much more complicated that would become? So just to illustrate right here, Let's try this again with 3 variables, x, y, z. Try solving these equations right here. Actually, with what z is, that'll make it easier. Sometimes you can cancel terms out. Especially, what you could do is multiply this one by -1. Just multiply everything by -1. Suddenly it'll be -5x minus 7y equals -9. And you've eliminated z because it's already 0. And because everything is now negative, or at least still the same thing, the 5 and -5 cancel right out. You don't even have to mess with them. Then all of a sudden you're left with this 10y here. And there's no z there, so that's 10y minus z equals 22. So then if you're trying to figure out z, you can put y on that side. But because you canceled x out, you don't even have to deal with that. And that simplifies some of those steps. I'm not going to get too in depth on that right there, but on this math sheet that I ended up doing, essentially what this is this is actually something I tried in high school, hence why there's a tear on the paper right there. Come on. There's a little tear. Because I did this in high school. And I wanted to see if I could solve for 5 variables. And that could take several sheets of math paper. Because what you're doing is, if you remember from here, we figured out how to get y, which included x in the variable. If you're doing like 5 variables and 5 equations, you want to, essentially what we've done here is we've set one variable to another variable. So now there's no longer 2 variables right there. It's just one. If you have 5 equations and 5 variables, doing this type of step will then get you 4 variables on the side, because you have 1 variable here, then 4 over here. And then you want to do some further math to bring it down to 3, then 2, then 1. Then now you have 1 variable. Then you can plug it back into any one of the equations from above. Plug it into any one of those equations with 5 variables. And then now, because you plugged it in, you solve for a variable and you're substituting, and it'll, just like right here, how we have 2 x's right there, you're now going to have 4 variables like that, because one of them will be substituted with a duplicate variable. Then you can combine those like terms like we did here. And then when you try to solve for another variable, now that's going to be on one side. Then on the other side, you now have 3 variables left when you started with 5. Once you get that solved, then you now have a variable with 3 variables on the other side. And then previously you had a variable with 4 on the other side. Then you want to plug both of those equations into one of the original equations, preferably one you haven't dealt with yet in terms of doing all these steps. Then you're doing that with, now you have 3 variables left because you substituted 2 of them. And then now you can solve for another variable, get it on the other side. Now you're left with 2 variables on the other side instead of 3. Then you repeat. Now you got 1 variable here and 1 there. Then you repeat again, and now you get a standalone number. And now with that standalone number, you then come back to one of the original equations, plug that in, and whittle down again. So right there you got 4 variables. Move one to the other side. Now you got 1 variable on this side, 3 on the other side, then 2, then 1, and yeah, that's going to take several sheets of math paper, as you can imagine. And math, then. Terrible wordplay. I do need to get to bed soon, otherwise I'm going to be doing this wordplay constantly, and that'll ruin this video forever. It'll be immortalizedly ruined. Immortalizingly ruined. So, yeah. Sorry, I was just thinking about this other ridiculous word like discombobulatorily discombobulated. I should get to bed soon, really. Otherwise, I'm going to keep doing that. So anyway, let's see here. Yeah, so you got 3 variables left. Move to the other side, you got 2 on this side. Then you repeat all that madness until you got all 5 variables. I'm guessing it's going to take like 5 or 6 sheets of notebook paper to accomplish that. I tried doing that in high school because I don't know anybody else who's accomplished that. Some people might have. If you have, let me know in the comments. And you can probably link your resource showing that. But obviously, if it goes through the spam filter, I'll unspam it if it's a legit link and all that. But yeah, so if you look at this sheet right here, let me get myself in the way. I mean, out of the way. Yeah, see, I'm getting everything mixed up now because it's late. I already did get myself in the way. I'll get out. So I attempted this with those first 5 lines you see there are the first 5 equations that I tried doing in order to solve for A, B, C, D, E. And the answer, in case you're wondering, is A is 2, B is 3, C is 4, D is 1, E is 7. So that's kind of what they are right now. So I basically got as far as the first side. I think I got, if you look at all the steps there, I got C all by itself, which includes 4 other variables. And then you can see right below where I got C, I substituted C where that normally belongs with the 4th equation. I substituted C with the 4th equation. And then you have to distribute that 10 across all of those, which I did, as you can see there. Then I combined like terms. Then I was able to try to get E all by itself. And I basically kept trying to repeat that until I figured out all the steps from there. If I were to actually do this, it'd probably be like at least 4 or 5 sheets of paper, which is ridiculous. But I wanted to see if I could do it in high school, as you could imagine. So where I ended up getting on this was, so toward the bottom I have 1 variable pretty much whittled down. See, now I got D and then 2 variables on the other side. And I had a couple steps on this side as well. And then I gave up. So then I just kept this ever since high school. It's been several years now. So basically what I have at that point is a bunch of substitution that's been unfinished. And I came up with this idea to have E be 1.21 gigawatts, just like you see in Back to the Future. And I figured what better way to get mathematical steps to actually lead to it, such as shown right here, than using that substitution method. And I didn't remember how to use substitution at the time, so how do I deal with that? Well, figured I could adapt this paper. It would be kind of cool to show paper like this on the film. I figured I could adapt that paper, then I'll be able to figure out how to do it one way or another. So, yeah, that's kind of what I did. I looked at this paper, and then I was like, alright, if I want E to be 1.21, which if you look at the original steps, it's not. How do I accomplish that? Well, the way I can accomplish that is by taking one of the last steps on the first side and then bringing it over to the back side. So I think what I grabbed was, so b minus 6a plus 6e. I think what I grabbed was this step right here, possibly. And I think I rearranged the order so that the variables are in a good order. So, yeah, I think I brought this line over to the other side. So there's, even though E is actually 7 on the first side, I at least brought it over to the other side like this for continuity. So there is continuity from the first side, but not in the way you might think. So what is the fastest way to get this answer here? Well, working with this equation, since it's so many steps and hard to tell what's going on, especially with 5 variables, which that's mental. If you're going to do that, you use something like Kramer's rule in matrix math instead. But my objective is to show standard algebraic steps that lead to 1.21 gigawatts. How do I do that? Well, that first line you see right here was brought from the first side. And then all I really needed to do was eliminate the variables as quickly as possible. So I got a B, A, E, and C, right? And I want E to be 1.21. How do I make that happen? Well, the trick really is creating that answer on the right side based on what you want the variables to be. So in this case, I want E to be 1.21. So when I'm making up what the variables are, E had better be 1.21. So when I'm figuring out what's on that side, I'm actually predetermining what all the variables are, making sure I'm consistent with that, and then plugging them in to calculate that other side. So that E is 1.21, I plugged that in at one point. Now it's on the other side. And then, yeah, I go from there. So the other variables, I think A is amperage, B might be the ohms, C could be wattage potentially, I forget how I actually did that. I tried to base it off of real variables as much as I could, just in case. Because I don't know if I mentioned the problem yet, but since I really did nothing but substitution and making the variables what I want, how do I realistically convey that on the chatbot? That's not really easy to do. So I could make E 1.21. The other variables I made up based on certain factors. So how do I get down to the bottom so that E is 1.21? Well, maybe I'll just go over it on here so that I'm not like rewriting it on the board, which is going to be too complicated. So all I really have to do is, this is a new equation that's not on the first side. It's not one of the original equations, but who cares? So I created an equation to help myself eliminate variables as quickly as possible. So notice how I did a minus b. That's so I could cancel out this b and never have to deal with it. So now we're just, when I add the minus b, now I do math on that equation. Minus 6 plus 14a, 8a, minus, or 6 minus 10e, negative 4e, 9 minus 12c is negative 3c. And then I do math on this and I get 21.16. So then at this point, I now introduce another variable, or another equation, I should say, where I'm consistent with what I predetermined for A, E, and C. So now just 3 variables are involved, which makes it quite a bit easier. I mean, all these steps are for just 2 variables, but I managed to make it so I could do 3 variables, which is a little bit more complex, but not too bad yet. So then, yeah, after I got this result from up here, I then created another equation so that, see the negative 3 and 12c, I figured now I could make it so I can cancel out the 12s. So this is actually this equation right here, but I multiplied everything by negative 4. So 8 times negative 4, negative 32. Negative 4 times negative 4 is 16. Negative 3 times negative 4 is 12. Now if you add these 2 equations together, minus 12 plus 12 is 0c. Now we got 2 variables left. 13 minus 32 is negative 19. 20 plus 16 is 36. That's 146. Now we got 2 variables, so that means we could get E on the other side. The reason I did E on that side versus A is because I want this to be in the end. So I'm therefore going to solve A first, because when I plug A in later, it'll end up being E, because A has E in the answer. So when I solve for A by itself, now A is equal to this. It's got E in it. So A equals 3619 E. This is the same as this, but on that line below, I kind of made it easier. So now I wrote this equation down. I just copied it from up here. And if you have like 3 variables and 3 equations, then you never want to, when you're solving for different variables, you never want to repeat yourself in terms of which equations you use. So if you have 3 variables and 3 equations, what that means is when you're solving for one variable, you could use equations 1 and 2, but when you're solving for a different variable, don't reuse the 1 and 2. Otherwise, you're going to get stuff that cancel out in later steps. You then want to do equations 2 and 3 for that other variable rather than 1 and 2. So this is equations 1 and 2, but if there's a third one and an additional variable for each one, you want to either use 1 and 2 for one of the variables, 2 and 3 for another variable. You could also use 1 and 3 for another variable too. But never use the same pair for solving for more than one variable. I learned that the hard way. Otherwise, things won't cancel out in a desirable way. So yeah, if we come back to here, I now solve for A. I brought this equation back down to here. Then I created another equation which will make it so that I can eliminate A. So what I've done here, I've multiplied both of these by, well, I multiplied the top equation by 12 because of that 12 right there. And then that top equation by 13. No. How did it go? I multiplied this by 13 and that by 12, the whole equation. So these two are the same as these two. I just multiplied by 12 and 13 so that I could eliminate A. Now I got 110E plus 38C equals that. And I want to solve for C so that I get E once again. And then that makes it so that now I have another variable with E in it. So A has E on the other side. C also has E on the other side, which means that when I take one of the original equations, I can now substitute with E to the point where, notice how I'm substituting right there. E is literally the only variable on this entire line. E is the only variable, meaning I can now solve for it. So then I do distribution, which results in that, minus 4E, which is just taking that. Then I do more distribution to that, equals a 21.16. Combine like terms. I have 3 E variables. I just combined 2 of them. I think it's, oh, I combined the 288 and 165. Add them together, you get 453. Then 61 minus 64 is at negative 2.8. Then I left this 4E because it's not a fraction with the same denominator. Equals 21.16. Then in order to get rid of that fraction there, I multiplied everything by 19. I multiplied that by 19 to get just 453. I multiplied this by 19 to get that 54. I multiplied that by 19 to get 76. And then multiply the 21.16 by 19 as well. So now I take the 453 minus 76, which is much easier now. 377E equals that 456 when I add 54 to the other side. And then I divide by 377, and guess what? I get 1.21. So that's how I did my math sheet. It is real math. I just made it so that I predetermined the answer beforehand. That's how I got the 1.21 as shown in the film. But the problem is, since I just made up variables, what should those variables be? That's kind of what I was going to figure out on this stream. I don't want to spend too much time on it though. Yeah, I think things are getting a little laggy, so probably best if I wrap up soon anyway. I wish I could think of what the variables are. I think I might have some pictures on my phone actually, showing my whiteboard math. Because when I wrote stuff on this sheet, I actually did stuff on the whiteboard first and then copied it down because I was trying to figure out what I was doing. Where is the whiteboard math that I did? Just trying to search for it on my phone. But boy, am I tired, so I do want to wrap this up soon. Yeah, I got to a point where I was used to staying up late, but my circadian rhythm is now used to going to bed quite a bit earlier. I also get sleepwalking every once in a while and sleep talking, and I find that it's likely because of how sporadic my bedtimes were. Now that I'm more consistent, it's way less potent, the sleepwalking and all that. So going to bed earlier makes a big difference regarding that. So just for notes here, here's basically that math on the whiteboard that I figured out ahead of time. Starting with nearly the top of the paper that I showed before. So then I think there's some other well, here's a that was for the figuring out the calculator program. I kind of wrote the pseudocode down to figure out the calculator program. I think I have here's what I was looking for. Here's what the answer to all those variables are. E is 1.21, which ironically ended up being a little bit more precise than that because of how I set this up. But we could argue that extra precision is what it actually is on Back to the Future. Who knows? A is 10 because that's amps, right? B, I think I actually measured the ohms that I was getting from the wall outlet, if I'm remembering correctly. And that's what it was from a multimeter. When I measure the ohms, I get that 2.186. So that's what B is. And then C, that's based on the gauge wire. So left multimeter on, just realized that. But this multimeter wire is 18 gauge, which is why C is 18. So that's what it's based on. So I purposely based it on real variables, but the way you integrate it isn't quite like this, which is a problem. So how do I realistically convey that? If somebody asks about how the math works, I just showed how I use substitution to make E equal to 1.21. But given that I set up the variables like this, how would I realistically convey that? I think I might do some brainstorming on the advanced reasoning model. So I'm going to explain the whole context right now. I created a time travel film where I attempted to make things as realistic as possible, much like a sci-fi meets reality. I did it because of what I saw on Back to the Future. I even had a math sheet on there that shows how I need 1.21 gigawatts of energy, much like the movie. The math steps are logically sound because I used substitution to make the math originally get to 1.21 for the variable E. So it looks legit. To explain the context. So then, what else do I explain? E is 1.21. Oh. Looks like my camera just quit working. Again. Sorry about that. Let's try that again. There we go. Okay. When I made the math sheets, I tried to eliminate 4 other variables as quickly as possible. I wish I could show all the steps. I mean, this advanced reasoning model is actually quite fascinating. There are also A, B, C variables too. When I designed the sheets, I made it so they were based on real things. I'm attempting to create a chatbot that can answer questions about my time travel methods, and now want to have it realistically answer how I am doing the math here. As with everything else, in the equations, A is 10 because I based it on 10 amps. B is negative 2.186 because those were the ohms I measured from the wall outlet when capturing energy into my conduits. C is 18 because that was the gauge wire. I had for the multimeter, which when wrapped in ionized electrical tape, it functions as the conduits. Actually, I'm now looking at that math sheet again. If I look closely, what is that? 1666 divided by 762. It might have been 1666 ohms. Perhaps, and that's 762. What would that have been based on? 762. I must have measured something else, like perhaps the ohms of the TV remote, and then divided those numbers. I don't even remember. Actually, for the B variable, I noticed on my notes I had 1666 divided by 762. I'm guessing the 1666 is ohms from the outlet. I'm not sure what the 762 is from. It could be from something else from the outlet, or it could be the ohms from the TV remote time travel device, which the multimeter gets hooked up to when the energy is captured from the wall outlets. Tebow. If I need the chatbot to explain where the math came from, what is the most realistic way I could do that? I'm not sure how those other variables would actually tie in and plausibly explain the 1.21 gigawatts. With your advanced reasoning, suggestions on how I could realistically approach the explanation for the paper, I had used substitution to get E to clearly, logically show mathematical steps to 1.21 gigawatts. But I don't want substitution to be in the explanation. Based on what I've shared, what could be the most realistic explanation? Based on provided context. Also, we need to factor in the numbers, prefixing the variables to start with. Then I might write my initial equations on the second side of the paper, as that's what matters most. And I tried bringing continuity in the first side, where I attempted to solve for 5 variables using substitution, which would take several pages in high school, and gave up. The continuity on the second page was for the film, and adapting bits from the first side, where A equals 2, B equals 3, C equals 4, D equals 1, E equals 7. If it helps, the equations on the second side that matter most are likely B minus 6A plus 6E plus 9C equals 111.446. And then, oh yeah, the minus B plus 14A minus 10E minus 12C equals negative 90.286. And then 8A, that's the result. 13A plus 20E minus 12C equals negative 61.8. I think that's all I had. The 12A minus 10E, that might be the fourth equation possibly. (12a minus 10e). And I believe 12a minus 10e plus 14c equals 119.9 was a fourth equation, if I remember correctly. Based on all that, suggestion for a plausible explanation for where all those numbers come from. Including the numbers in the 4 equations, and A being 10, B being -2.186, possibly from 1666 divided by 672, no, 762. And C being 18 from ohms, and E deliberately being the energy 1.21, or the answer ended up being 1.210143766658 to be more specific. The long-winded explanation, but see there, it's doing some advanced. You know, what would be really interesting is, since I have 5 variables and 5 equations to start with, could this show all of those multi-page steps for that? I would be so curious. Without explicitly talking about, the key is to show where each. So there's an explanation right there. Those measured resistance or resistance factor, 18 gauge wire by the 4 equations. Each equation represents a different constraint on the time travel device. That's genius. One equation is a net voltage drop. Whoa, that's crazy. Another might capture the net flow. Whoa. The numeric terms on from the experimental weights. But if the amps was predetermined, then how can the other side be experimental? I guess it could be. In some bizarre scenario. I have to figure out where the 762 actually came from and all that. Why the right-hand constants? The net sum. Oh, within the gigawatts, not being a common unit. Combining it from real-ish parameters that just happen to be the same. Wow. My mind's not going to absorb this. I think the mental sponge feels a bit full. So I need some non-REM and REM processing to load things into the hippocampus, if that's where the long-term memory is, and clear that all out. Then my ability to concentrate and learn will return. I want to think about this later. I kind of went over my overall mindset for how the time travel works and all that stuff. But if you want, you can look at this and you at least see where some of this stuff is coming from. Do I have any initial concerns? Yeah, one of my concerns about making it realistic is the fact that the unit is gigawatts, but that likely isn't consistent with the other variables, such as not megawatts, not kilowatts, not watts. The amps paired with that. Much like a common denominator, if you will, but for the units involved in the equations. Suggestions for dealing with that, since the numbers are raw right in the equations, in their units as they are. So I have to figure out how to approach that. I'll let it think. It's movie math, but of course I'm overthinking it all. So I'm gonna have to figure out how to take this, figure out a realistic way for my model to plausibly explain these ideas right here. If I can find one that I can accept myself. Because I can just kind of brainstorm how that works. It's kind of hard to make it plausible, obviously, but using those kind of methods, I can do my best to make it work one way or another. There's no way I'm going to get much further with this right now, but I at least have a mindset that I could use right now. So, yeah. Why don't we stick with this? I'll figure out a way to adapt it. You kind of get my mindset. I really made this live stream just so I could convey custom models and the quirks with this type of system and all that stuff. How that can affect the way you train it and just what creating custom models looks like in general. And I should also specify, when you first create it, there's no title or anything yet. So I describe what I want it to do. It proposes the title. And if I say yes, it will go to the configure tab and tweak it. And then based on the knowledge it has so far, it'll probably tweak the custom instructions accordingly. And then if there's enough information, it'll do suggested conversation starters. Oh, actually after the title, it's likely gonna then propose a profile picture if there's enough context on what it's doing. Right. And then, yeah, you provided with resources. It incorporates that in short-term memory as it reads it. And then it can kind of figure out what it needs to do with it. So like the notion of telling it how to index all the files, it has to have exposure to it to know the best way to index it. So yeah, that's kind of what that looks like. So you can imagine how I would adapt this into something that's plausible, and I'd probably have some back and forth conversation with this. With it being the custom model that it is, it'll probably have some ideas for integrating the logic as well. I'm sure it will. Wait, did I generate another video recently? Yeah, I think we already looked at this. That's kind of cool for the custom video model. Crazy how realistic it is, how it has focus and all that stuff. You could probably do some very simple concepts that'll make it do some impossible thing with ease. Like, I think there was one where somebody had a cat eating noodles, and that looked pretty much as realistic as it possibly could. Kind of hard to think of ones besides dreams that I have a hard time replicating. Date and time were just the same. Just now. So yeah. Trying to think of one that I could potentially do now. Not going to be able to. I don't know, a person levitating. Or a person swimming in the air. That one I might be able to do. Create a realistic video of someone swimming in the air and clearly not water. Something like that. I'll let that generate. So yeah, I'll figure out how to do this. I think you now get my mindset for it. So that's how I'm gonna teach it that. Let's see if it can do all the mathematical steps. I'm curious if you can do steps for 5 equations and 5 variables with the substitution method in general. It would take several sheets of paper, but I'm curious if your advanced reasoning and math skills could lay out all the steps using substitution, which is much harder than elimination or Kramer's rule. Can you do that? Each and every step laid out in substitution. Now my thought processes are gone, so I can't type anymore. For 6a plus 3b plus 6c plus 4d plus 6e equals 91. 7a plus 6b. I wish I could do some OCR for it, so I don't have to type it all. 4e equals 66. 3a plus 7b plus 9c plus 9d plus 4e equals 100. A plus 7b plus 10c plus 2d plus 10e equals 135. 2a plus 6b plus 7c plus 5d plus 10e equals 125. Ah, there's 135. Okay. 6, 3, 6, 4, 6, 91. 6, 3, 6, 4, 6, 91. 7, 6, 1, 2, 4, 66. 7612466 37994 100 Yep. 1710 210 135 1710 210 135 2675 10 125 2675. Yep. I think I wrote it right. I'm just curious if it could do it. I don't blame it if it can't. It's not an easy task. It's a lot to keep track of, and if you're able to know how to do this for as many times as you need to do it, you'll be fine. While we're waiting for that, let's figure out what else I had on here. So I'll later ask it in the chat thread for the actual custom model that question. I want to help it. I suppose that's how I'm going to start the query. I'm going to be like, I want to help you be able to answer a question such as that. Ensure it is understood and that the number is needed for infrared to have any effect. That's an interesting way to think of it. I mean, that should be incorporated in the explanation. The differences between those calculators, I want to train it on, because the TI-85 and 84 and possibly other calculators do things differently. And since I only have an 85, 83, and 84, well, 85 is the most accessible right now, but I have other ones too. Then I can compare the differences. I don't want to go through that labor though. The general chatbot models will likely have that incorrect, more than likely. So that's a problem with that. Walk through the time travel process. So I actually go through this video, walk through the process from start to finish. Because if I go over each individual step, there's probably something it doesn't actually understand correctly. I'm going to try to get it to understand how energy is emitted over time at 1200 watts per second. Because if you figure 120 volt 10 amps, that's 1200 watts, and I would assume it's per second if you're accumulating energy. I mean, obviously it's 1200 watts period, but if you were to tally it up, is that per second or per hertz? Like with the wall outlet alternating current, or how does that work? I'm guessing it's per second, but I don't know. I based all my... So when you see the numbers on the time travel program, I based it all on that. Which is why I figure if you're gonna emit it at 2.5 volts per second, and if that's 10 amps, which I figure based on the multimeter, especially coming from the wall outlet, is probably 2.5 and 10 amps. That's like 25 watts per second. So that would take 116 days to get to 1.21 gigawatts, I believe. Figuring the 1200 watts per second. So then this, obviously making sure it knows how to hook up the multimeter correctly. I might send it some pictures just so that it can tell, because these models can sort of read from pictures, although it's not perfect. Like sometimes if there's like a subtle clue, it won't notice it until I point it out or something. That's right, even AI like this will struggle with subtle clues. So now the plausibly explaining 1514 iterations within the program loop. how it's not just memory management, it's ionization as well. How do I plausibly explain that I stumbled across that, and how could other people stumble across it too, aside from just figuring out how deep you can go in recursion based on the total number of iterations you have to do. I'm not going to do that on this live stream because that's just going to take way too long at this point. I think it'd be kind of cool to convey how similar, how similar the energy accumulation is like reduce in JavaScript. So in JavaScript, you have a bunch of, well, reduce, it takes the idea of using an accumulator, and then you do that for every item, what you're building into. Yeah. And, well, when you're accumulating energy over time, it's almost like you're using a reduce function in JavaScript. For those of you who are familiar with that, you'll know what I'm talking about. Energy gets accumulated over time, and the metaphorical bucket that goes from the present to the future and the recursion, that actually acts as the accumulator in JavaScript, and then you're essentially returning the accumulator when you're done. So yeah, so then toward the end I would quiz it on things that it would be unsure about. Like, for example, well, rather than just quizzing it on things it might be unsure about, I might ask it, so you're trained to answer these time travel questions. What is something you're unsure about or doesn't seem legit or something like that? And then we'll work it out, do back and forth conversation, and then update the instructions accordingly. Kind of tempted to demonstrate this reduce right up here, but I don't know if I'm gonna do that. It's still generating an answer, crikey. Let's see if it got the... I did give... Shoot. Probably only knows that because I gave it the answer before. Wow. I'm gonna put this in a different chatbot. It'll have memory from one to the other most likely. And I don't think you could use this model without an account. So forget it. So it's substituting A. Yeah, so these are all the steps it would likely take. Wow. I now have 4 equations, so all these steps above, all it did was get rid of one variable. I think it combined like terms for A, which I don't know which one it is. Now you do that with those equations for B. And then that's just for getting one of the variables. Then you have to repeat the process for all the other ones. Oh my gosh, over 1 million. That's crazy. I'm gonna have to go through this at some point because, yeah, I tried this in high school and I gave up on it. That's crazy. And there's a verification. Wow. That's crazy that this model probably would have been able to figure it out all by itself. Like, I'm sure if I looked at the steps, it would have. If you want to fact check this for me, feel free to go ahead. So, yeah, I mean, regarding the JavaScript stuff, reduce is actually, you can technically not just reduce an array down to 1, but you can use it like map. If your function that you're doing is essentially doing the action that it does on each variable coming from the array or each number, then you can technically accumulate into an empty array. So you figure out what that number is, push it to that empty array, and then you'll be able to do that. Map is actually called map reduce behind the scenes, I think, because of map actually being reduced underneath the hood with an empty array as an accumulator. That's kind of how it works. Try to resist my urge to show the whole process of that, because you could use reduce just like map. If you have an array as an accumulator, an empty one, then you not only figure out the number within the accumulator, but you tack that on the empty array, append to it. So you're basically doing the operation, then adding it to the accumulator, aka the empty array. So you'd be surprised how powerful reduce is. Sometimes it doesn't even sound like you're reducing things at all in JavaScript, but that's kind of how it works. But with temporal dispersion, I'd like to maybe program my chatbot to be able to handle that. So yeah, I think I'm just gonna, I think that's enough for tonight. How long have I been streaming for now? Almost 9 hours. Jeepers. I was thinking 6 was enough. So I did a live stream a while ago where I go over my breadboard LEDs for my custom voice assistant, which, if you look at this part of the video toward the beginning of this, what you're seeing right there, where I press the button and those lights come on there, that's real. In fact, I have it here, I believe. Yeah. I've got it here. So this is that thing with those lights on it. You're not seeing the green light because of the green screen, of course, but there is a yellow and red light, and that correlates with the voice assistant. The voice assistant, where I used the computer trigger phrase earlier, that was real. But as I explained in the podcast, Minecraft is what I used, and it got signed over to Neon, so the voice commands didn't actually work. I emitted pseudo utterances, or pseudo voice commands, but otherwise it really did listen for the word computer. And that's an AI model in itself, by the way. It constantly listens for audio and decides what is the probability at any given moment that it says computer. If at any moment it's more than 70% confident, or rather 69, I think is what I put. If it's at least 69% confident that I just said the word computer, then it starts listening for my voice command, and the green light will come on. I did a 6-hour live stream a while ago where I did exactly that. So if you look at this live stream right here, that's the actual where I put this together in that live stream. And I have a bunch of content on my voice assistant on top of that right here, where I explain how that works. So those voice commands you saw are real. Obviously, with it being signed over to Neon, it's not functional anymore. So I've been trying to get it fixed. And I've been getting help from the developers for Neon, trying to get it fixed. Once I do, I'll be making another video where I show how to fix it and essentially use one of the alternatives to Minecraft, which is basically a fork of Minecraft. The reason I don't have a status update on that yet is because I just haven't got a chance to figure it out. I've been spending a lot of hours figuring it out, but unfortunately it just doesn't work. I keep running into issues like something's just not working. I'm gonna talk about that on a status update. But yeah, right now, if you're wondering about how the Raspberry Pi is set up, where I use the voice assistant and would have this hooked up if it works. Currently I have Open Voice operating system on here. And where is that located? So I tried Neon, which is using Docker images. I've tried Ovos, which I think is all the components are stored in. I'm using Ovos or Open Voice operating system right now. Everything is stored inside of this folder here. There's a virtual environment. If you go into the bin folder, you might recognize Minecraft CLI client and all those, because Ovos is essentially Minecraft underneath the hood. And you'll notice other utilities like Dinkum. The Dinkum listener, I think, is now used instead of what it used to be, which I think is supposed to function better. But once I get everything working, I will be able to make a status update on this. Oh, here we go. This is for transcribing stuff. And by the way, when I generate AI captions, that's using another type of model, with audio as the input, text as the output. Pretty impressive. So that's stored there. And then I guess there is stuff stored in .config Minecraft. And then I think this Minecraft file is actually not the highest priority. Or what I mean by that is there's like configuration files in multiple places. The ones that take effect over other ones are out of order. I think it's what we're actually looking for is inside that virtual environment folder under Ovos, and I think under lib. Yeah, Python 3.11 site packages. I think in the Minecraft folder, I think there's a Minecraft.conf if I'm not mistaken. No, it's probably in the Ovos folder within there. Well, if I were to try finding inside of there, Minecraft.com. Oh, not in the roots directory. Right where I am. Probably not there. Ovos config, yeah. So inside of ovos config, that's the... What? Somewhere. Thought there was an ovos config folder. Yeah. That's the configuration file that takes precedence. But yeah, those voice commands you see are real. Believe it or not. But I was using Minecraft, which since it got signed over, it basically can't listen to your commands anymore because there's a transcription service. And now that got redirected elsewhere. You could probably get it working again with your own speech server. But I'm trying to get Ovos working right now. Once I do, I'll have a status update. That's what I know right now. Minecraft CLI client got depreciated recently, so you can't use that anymore. I'm trying to figure out what you have to use now. So yeah, I think this is where I'm going to wrap up, because dragging things out further would be kind of foolish with how late it is and all that stuff. And I kind of emphasize how I'm going to do stuff. I'm going to figure out a plausible explanation for this. I'm going to copy the instructions and not save the draft for right now, so I don't have to worry about this tonight. And then I'm going to probably get it to help me create files with information that's randomly dispersed throughout this. Because there's probably specific nuggets of information that should be inside of these files, and then instructions on how to do this would be there. So yeah, that's all you need to know for now. So I think I've conveyed enough. Funny thing is, I'm not even saving the draft, so essentially I've accomplished nothing in this live stream. Sad times. Well, anyway, I think I am gonna call it a night for now. Not sure if I want to show this because it's laggy. That might be a little cringy. I'm probably laggy too. So I think I'll just stick with this for the big view for now. So yeah, I guess that'll be it for now. So if you have any questions, comments, or concerns, feel free to let me know. I know this is a very welcoming outro, isn't it? I feel like let me there. That's a little more welcoming, isn't it? If you have any questions, comments, or concerns, feel free to let me know. I'll try to get to you as soon as possible. Otherwise, yeah, I think that's it. So thanks for watching and have a good one. Peace.